GM. Welcome to day 2 of Nebular Summit. I want to give you guys a round of applause for being here so early this morning. I know there weren't many side events last night, but I know many of you went for dinner and stayed out late. I certainly did. And so I'm glad to see there's so much energy here already this morning under the rain. I think we're going to be nice and cozy here today. We got coffee, we got croissants, we're going to have some nice lunch. And so we can all huddle in here under the canopy. It's going to be great. Before we get started, I do want to talk a little bit about Interop Ventures. We're the fund that is organizing this fine crypto event. Interop Ventures is an early stage venture fund, and we invest in early stage teams building in the Interchain ecosystem. So we really believe in the Interchain vision of interoperable modular blockchains, and we want to back teams that are building infrastructure, scaling solutions, interoperability solutions, privacy solutions, better custody solutions, and dev tooling in this realm. So if any of you or any of your friends or people you know are raising funds, please refer them to us. We'd be happy to have a chat with them and see how we can help. A couple of other things we're involved in other than this fine conference is I'm the host of the Interop podcast. I host weekly episodes, weekly interviews with founders in the Interchain space. I try to go deep and technical and try to understand not only the technical aspects of what people are building, but also how it fits in the broader vision of crypto and the Interchain. So yeah, do check out the Interop podcast. It's on YouTube, Spotify, and everywhere you get fine podcasts. So with that, let's start Nebular Day 2.
All right. Bonjour, cosmonauts. Thank you for being here. And thank you for all the projects not having a side event yesterday because we all needed a break and be ready for day 2. Now, so I'm Candice from NIM, and I'm your MC for this morning. So without further ado, let's actually welcome our first speaker of the morning on stage, Magnus Mechanek, the co-founder of Skip Protocol, who will be talking about many transactions, one chain, democratizing UX with Skip. Well, he's changed the talk. He rugged me, but anyway, the title is up there.
I'll change it here. Yeah, I'm just going to change it here because I think the clicker is connected to a different system. Yeah, sorry about the rug. I figured since we already introduced the APIs and been talking about it for a minute, try to just go down the rabbit hole on something that I think is actually extremely important for Cosmos. It is this new technology called ABCI++. If you don't know what ABCI is, it's the interface between the application and a Cosmos blockchain and Tendermint. And ABCI++, or ABCI 2.0, is a brand new re-envisioning of this that I would argue actually basically brings a lot of these narratives and exciting things happening outside of Cosmos into Cosmos. So it's going to be a little bit of a technical talk, so hope everybody had some coffee. I tried to spice it up with some memes. So basically, this is how I feel talking about ABCI++. It's like everyone else is talking about Chainlink, talking about Suave, they're talking about EigenLayer, and I'm just like, ABCI++ does this. It allows for all these things already, and you can have them in a Cosmos chain. And I think that's going to be really important for the next generation of applications to realize this and take full advantage. And so I'm going to try to talk through it. So I think it's bigger than most people think. A lot of people think it's just a technology. I think it lets chains be 10x more powerful and fully sovereign. And I'll talk through why that is. I got a clicker. Nice. Maybe it's OK. It's not a problem. So just to talk through what I'm going to talk about, first of all, I'm going to talk about what is the motivation of this talk. I'm going to talk mainly from the lens of how do we enable more sovereignty for applications. I think the defining characteristic of app chains is the fact that they are fully sovereign compared to any other basic ecosystem. And I think L1s really sort of allow for that, especially in Cosmos. The tool chain I'm talking through, of course, is ABCI++. And then the kinds of applications I'm going to talk about in that context are sort of the functionality that ABCI++ brings, and also what we're building at Skip, and sort of how it builds around ABCI++. So 3 applications to talk about. 1, sovereign MEV. So how that works, how basically Skip's products operate. So how can we, when I say sovereign, I mean, how do you take full control of your MEV market? How do you direct it to any stakeholder that you want without any centralized services? And then number 2, sovereign data. How do you as an application take full control over your data? So this is in the context of privacy. How do you have private data? And then also in the context of oracles. So how do you get data from an outside source in a fully sovereign way? And then finally, I'm going to talk about sovereign blocks. So basically, how do you use ABCI++ to fully construct your app chain perfectly to your application and to the needs that you have? So one argument I have is ABCI++ is actually the thing why we have this new influx of great applications. DYDX, Berachain, I would argue are here partly for ABCI++. And looking through their architecture, you can see really closely how they use it. DYDX uses it for oracles. So they'll use ABCI++ to have this in-protocol censorship-resistant oracle that they need for their exchange. And then Berachain uses it for a variety of things, excuse me, but specifically for MEV block building and also some of their precompiles for Polaris. So what is it? We finally get into this part. So basically, at a very high level, because I'm going to get more technical, ABCI++ transfers control over basically everything from the consensus layer, so that's like Tendermint or Comet, into the application, where the application can define the logic that they want to apply to their blocks. So how did it work before? Before, this was the traversal of consensus. Basically, transactions would collect in the mempool of Tendermint. They would be passed to the proposer, where a proposal was created. Then it would go to consensus, and then that proposer would finalize the block themselves. So they wouldn't ask for feedback from anybody else, and then the block would get executed. So basically, I had a meme at the end of this that I'll show you. But basically, the proposer has full control over the entire block construction process. They have full control over the ordering, full control of what goes in it. And this led to a lot of, let's say, difficult results when it came to MEV, because there's no way to properly enforce, let's say, sharing the MEV with the entire network, because the proposer had full control. This changes a lot, and I know it's quite complicated in ABCI 2.0 or ABCI++. So in the updated model, the proposal is created. It's called, this function called prepare proposal is called. The application then looks at that proposal and decides, okay, is this a correct proposal, and can use application-side logic to modify it. Then the proposal goes to process proposal on all the other validators. Basically meaning other validators can say, did you do this block correctly, right? They could say you ordered it incorrectly. They could say you didn't include this transaction. And this has meaningful implications. Then we go to a function called extend vote. So another part of ABCI++ that I would argue is as important as the prepare and process proposal is vote extensions, meaning you can add additional data that is signed by your vote, meaning that you sort of have this censorship resistance layer at the consensus level so that you can add additional data that must be considered when creating the next proposal. Those vote extensions are then verified, and then finally the block is finalized. So it's a much more back and forth process between the consensus layer and the application layer, meaning that an application like DYDX can basically verify additional things about consensus in order for that block to be valid. So, dumb version, left curve now, like basically before proposer would say, this block is correct, I swear. And validators are just like, great, sounds good, I'll execute it. And now they're just like, I'm not so sure about that. Maybe that's not right. And they do a lot of additional checks. So what are those checks? The ordering check is actually quite limited. You can't do a full deterministic ordering check, meaning you can't say transactions have to be in order A, B, C, D, E, F, because mempools are different, validators might not have received transactions, and you actually get into an impossibility result in this sort of cyclical voting if you try to enforce an ordering. This is why we can't have true fair ordering in blockchains. However, you can do limited ordering, and I'll talk about that in the MEV use case. What you can do is inclusion and vote extension consideration. So basically, when the proposal is considered to be valid, all the validators can say, did you include this transaction? For example, that transaction might be an Oracle update, and only vote yes and continue the blockchain if those transactions or that data is included. Talk about why this enables censorship resistance with 2/3+ of the network. And then finally, you can check for aggregation as a validator. So, or sorry, for logic. So that might include aggregation like, did you consider all the prices from the last block and construct a accurate new price for this asset? And so that's obviously very important for oracles. So I'm going to go into POB. So POB is skip software that is open source and that any blockchain is absolutely free to use. It's running on a number of blockchains today, or getting set up actually. So POB uses properties 1 and properties 2 to allow for an in-protocol MEV auction for chains to just easily, permissionlessly capture their own MEV without any outside parties. So I'm talking through the 3 ways that it does this. It's sort of getting technical again. Whenever you see these diagrams, I get nervous that I'm like over-explaining. So basically what POB does is it introduces a new transaction type. It's called a message auction bid, which allows for a searcher to find a transaction in the mempool, bundle with it, and put it at the top of the block. So this happens through prepare and process proposal. In prepare proposal, the validator will look for these like special meta transactions or wrapped transactions, grab them, and then unbundle them at the top of the block and have them be atomic. This is how it works today. But it has some downsides. The downsides are the validator, again, can just rip it out and put in a different bundle, right? They can just say, okay, well, you made $100,000 at the top of my block. What if I just replace that transaction data with my own? It's called a generalized front-running strategy. It's very common in MEV. And then also the bids aren't private, right? Since it all happens in protocol, all the other searchers can see what you bid, so they know exactly how to bid right over you. So this is where the rest of the parts of ABCI++ come in. So in V2, we have a consensus enforced auction. So just to talk through this quickly, basically all of the validators pick what their top bid was, so like what won their block auction, and they put that in vote extensions so that the proposing validator has to choose that data, since they have to choose 2/3 plus of votes by stake weight in order to move consensus forward. They also have to see the top bids from each validator. That way, you as the top bidder have to be censored by over 1/3 of the validators in order to be censored. So basically, you have a much stronger censorship resistance property around your top bid, which basically makes it a much more credible auction. But we still have one more problem left, which is the bids are still public, which means other searchers can still bid over you. That's where the third property comes in, which is encrypted bundles. So with ABCI++, which was actually created to allow for threshold encryption on Osmosis, you can have fully encrypted bundles, where basically the user or the searcher will send in ciphertext instead of just plain readable data, and then those bids can be selected post facto by all the validators after they've been decrypted. So that way, basically, you have the censorship resistance properties, so you'll always get the highest bid, but it will also be private until execution time, meaning nobody can see it and bid over it until it's too late, which is what you want. So then you have a fully credible system. We also use DKS for that. But basically, what do you get out of this? Like, what's the reasoning here? What you get out of this is you don't need something like flashbots. You don't need an external system. You don't need extra nodes. You don't need extra infra. It just all runs on the existing validator set, and it runs efficiently, and it runs as a fully credible auction, which is in mech design very hard to get to. It needs to be private and needs to be censorship resistant. So you can direct that revenue anywhere, because now proposers can't unilaterally decide where the money goes. It can be split across the entire network, censorship resistant, as I said, MEV stealing proof, and it's just all on chain. And it's an open source module, so any chain can just run it. So if at all interested, do check out the X Builder module, which we published on ideas.skip.money and talk more about. It's also on our GitHub. All that's required is for your chain to run 0.47, and then it's just free software that you can run. So that's the first use case. What's the second use case? Oracles. So my argument in this talk is that you can get a Chainlink-like oracle with all the same security properties native inside your chain with ABCI++. In fact, it's already been done, and I'll talk through how it's been done. So Chainlink is coming to Cosmos. I mean, they're not actually coming to Cosmos, but the Chainlink you have at home is coming to Cosmos. So how does Chainlink work in general? I don't know, maybe this is common knowledge, but I think it's worth noting. So Chainlink has a network of nodes that all grab price feeds, right? And each node will grab price feeds from different providers. So one from Binance, one from CoinGecko, one from CoinMarketCap. That node will aggregate them by taking the median of all those prices. Then all the nodes will post their aggregate prices, and then another aggregate is taken across all the nodes, and then that is posted on-chain to a smart contract and read by developers. But this is actually just ABCI++. So this is the model for how you can build an oracle using ABCI++ with the exact same trust assumptions. Each validator, as part of consensus or as part of its regular operation of the chain, can run a side process to grab prices from all the different sources. So it will grab, Bearer price, ETH price, Osmo price, Evmos price, etc. And then it will put those prices, it will take a median, just like Chainlink, and put those prices in the vote extensions. And then all of those vote extensions are aggregated across the validators. They are finally calculated inside the proposal, and then they're posted into an on-chain Oracle module where they're made available to, let's say, CosmWasm contracts or Solidity smart contracts if you have EVM compatibility. And this all uses the same calculations as Chainlink, right? And the reason I argue it's the same security properties as Chainlink is even if you used real Chainlink, right, on your application, you're still trusting that your validator set isn't screwing around. This way, you're also trusting your validator set, right? You're trusting it with 2/3 plus of the stake weight to actually report correct prices. And so my argument is you basically have the same trust assumptions at the end of the day anyway. So here's just a more in-depth view. This is a little bit small to read, but basically I'll just talk through it. The vote extensions from the last block have now all these prices. Then the proposer, who has to look at those vote extensions to move consensus forward, will grab those prices, aggregate them. All the other validators will check and say, did you look at those vote extensions and did you aggregate the prices correctly? Then the new prices are queried, put into the vote extensions for the next block. They're all verified, and the block is finalized with the updated prices. So this way you have, true 2/3 plus censorship resistance on your Oracle prices. So basically what you get, again, you get basically an in-process Chainlink version. You have the same trust assumptions. You have censorship-resistant data, and in this case, off-chain data. And again, all on-chain. So you don't need any external providers. So I basically said this. We have an implementation of this as well in the X Oracle module, which is actually coming out quite soon. Again, all your chain needs to do is run 0.47, and it can just have this existing price feed. So the final thing, and I don't think something we've talked about previously ever, is what we call modular blocks. So we argue that the abstraction of ABCI++ with the addition of something that we've built in POB allows for this really, really interesting abstraction over the block layer, so that applications can fully and granularly decide how their blocks are built. And it's not just MEV. So we've built this thing called laned mempools, where basically you can separate your blocks out into different lanes that have specific applications for certain kinds of transactions. So in this example, which I realize is pretty small, you can have, for example, at the very top, an essential IBC lane. So let's say those are light client updates. You can specify at the top of my block, the first 5%, always and only for light client updates, right? And maybe those are gasless transactions. Why not? They're free, right? They're so important to my network. After that, maybe you have an Oracle lane, where only Oracle transactions are allowed in there. Then maybe you have an MEV lane, right, to capture the MEV after the Oracle updates. You definitely don't want that to go before you get front running. And then finally, maybe you have a custom fee market like EIP 1559, which is Ethereum's fee market applied to Cosmos, for the rest of the transactions. And at the very end, you have free transactions. And maybe you say, users who are making their first 5 transactions on my blockchain should get it for free, right? Help them onboard. Maybe they don't have the gas token. They're trying to figure it out. And then maybe also you have free transactions for undelegating. A very common thing in Cosmos is people delegate all their tokens, they have none left, and then they can't undelegate. And so it's like catch-22. So you make undelegate transactions free. So you can fully customize your application with different percentages of block space to restrict and reorder things according to your application's needs. This might be really useful if you have an Oracle. And it might just be, generally useful if you want to, let's say, have permissionless CosmWasm, but don't trust it enough to have it take up all your block, maybe just 20%, right? Maybe somebody deploys a gas-heavy contract. You want to make sure you don't get spammed. Especially true if you have 0 gas fees, which is dangerous, but obviously nice for users. So this also fits into all the other use cases, right? So like you see an MEV lane, an Oracle lane, it can fit into those other use cases of ABCI++ to just create this highly super-powered application that can do so much more in protocol that normally had to require on outside applications. That's my talk. Hope it wasn't too complicated. I hope it was helpful.
All right, my caffeine pill has kicked in, so I am awake now. Thank you very much. So the other night I was walking home on a quiet street. It was about 2 a.m. And then I saw the word cosmology just flash past me. And it was none other than our next speaker, Dan Lynch, the founder of Cosmology, who's going to talk about building dApps for Cosmos. Dan?
Hello? All right. Hey, guys. Let's get started. Well, good morning. I'm Dan Lynch, the founder of Cosmology. And I'll start off giving you a quick background. I've kind of been at the intersection of design and technology for a little over a decade. I started a small startup in San Francisco. The domain was famo.us. Hundreds and hundreds of thousands of apps were actually built on it. It's like a Figma in the browser, but actually builds web applications way before no code was a hashtag. And after that, I actually built a website builder called brandcast.com. Ended up getting sold to Time Magazine. So really, my focus has been on enabling non-technical people to do what technical people do. And I've since kind of transitioned into helping developers become more advanced developers. So effectively, just, my goal is not only to bring the technology stack and the developer experience from Web 2 into Web 3, but also bring more developers from Web 2 into Web 3. Effectively, it's really about getting ideas to execution. Oftentimes, you have this great idea, and you want to build it. But to get from your idea to your execution, you get lost in the weeds, especially if you rewind back a year ago or more in Cosmos. You'd have this brilliant idea, you want to build it, and before you know it, you're getting lost in proto-buffers, amino encoding, all these technical details that really have nothing to do with the idea that you were conceiving. So the problem with this is that sometimes developers might get so lost in the weeds, they forget their original idea, they may even give up, or now they just start working on tooling for proto-buffers, which is actually what happened to me. So, minimizing this gap of execution, minimizing the gap between the idea and execution, or getting, as quickly as possible from your intention to the execution of your ideas. That is the core of Cosmology. Real quick, I'll talk about the anatomy of Cosmos. A lot of you probably already know, but we have the Go SDK modules. We've got the CosmWasm smart contracts. Generally, these are interoperable and modular. The Cosmos SDK has over 265 apps in the Cosmos, 60-plus IBC-enabled app chains. The idea is that every app chain serves a purpose. And with IBC, these are already interoperable and modular. And also, with CosmWasm, there's hundreds and hundreds of contracts in the Cosmos already. And these contracts can actually call each other. So they're also composable and modular as well. And my question to you is, what about the modularity of the front end? Well, before Cosmology came in, there was a lot of complexity. We had Akash.js, we had Secret.js. Every chain had to make a new JS, and actually, these teams had to manually build these libraries themselves. Now imagine a world where every single company or team builds their own APIs. It's kind of like the Web 2 world. And if you guys remember what it was like to integrate with Web 2 technologies, I mean, it's kind of an n-squared problem. Like the number of communication channels where all these different apps have to kind of interoperate with each other, but it's not interoperable. And that was the problem that we had before CosmWasm came in, before about a year ago. So, you know, if you think about all these sort of like connecting things, all these like, you know, processes we're doing, like I encourage us to think about when we're building software, like what are we doing today that in 5, 10 years, 20 years from now, we're going to think, wow, I can't believe we were doing that thing that was so archaic. So what are we doing that, you know, how can we innovate and, you know, not end up doing software construction? We should be doing software engineering, software art. And so, you know, one metaphor I like to think about is, you know, in many ways, a lot of what happens is you've got to build an app, and is sort of like asking Jimi Hendrix to grow a tree, harvest the wood, solder some circuit boards, wheeled into his own guitar and music studio before he could even write a song. Would we even be experienced? And so my question is, how can we give Jimmy his guitar, right? So we can be experienced. And essentially, so I introduced to you the Cosmology Suite. So we aim to be the Adobe for Web3. We have a suite of interdependent products. That means just like with Adobe, you've got Photoshop, Illustrator, and After Effects. You can use them by themselves. You can use them together to make bigger projects. But they're all sort of modular or interdependent and serve different functions. So I'll talk a bit about these and kind of the purpose behind them. But first, we have an announcement. Terran 1 has joined Cosmology. So super excited. William Chen is now our head of R&D. The reason this is super exciting is that we've been primarily focused on front-end tooling and catalyzing developers to minimize that gap between intention and execution. And now we can also do that for CosmWasm. So with the acquisition of the team, we've also brought on their tooling, and we'll be supporting the CosmWasm developer ecosystem the same way we've been developing tooling and supporting the ecosystem for the front end. So CW script, it is a new language that actually compiles to CosmWasm. So if you think about it, we've got, I don't know, something about 1,000 or some thousands in the small numbers of CosmWasm developers. There is something about 17 million JavaScript developers. So if we can make a language that actually is something that is much more easier to use, much more simple to express, zero boilerplate, and actually compiles to Rust and compiles to CosmWasm, we can abstract that complexity and open the floodgates to these tens of millions of developers in the JavaScript and Python communities. So our goal here, again, is to, you know, help these folks from Web 2 come into Web 3, and we think CW script is one of those technology solutions that actually solves a people problem and bringing in all these developers from other communities. And so the way we do it, effectively is that, you know, we really, well, actually, William, you know, really thought deeply about the semantics of what a contract is. You know, we have our state, we have our queries and our executions. And so how do we bake that semantic into the syntax of the language so that instead of having this super, you know, general purpose, Rust-based system, we have encapsulated it to something very simple. We also have CW Simulate. This means you can actually run CosmWasm-based contracts in the browser. What's also great about this, we have visual debugging, time travel, and no chain required. What's also really cool for some of you CosmWasm folks out there, you can actually debug nested submessages. So not something possible before with the current CosmWasm tooling, but with the Terran 1 team and Cosmology now joining forces, we've got these tools that we'll be also supporting and innovating on. So I have a question for you guys. Is the first thing you do write a test? Yeah? Okay, cool. Well, you should be. So that's great. But we've launched a new tool called Starship. And again, it's really about, you know, you write a piece of code, and now you want to see the result of that code. Some developers might end up, you know, writing a line of code, refreshing a browser, clicking on some elements on the page, creating a transaction before they can even see the result of the edit that they just made. That is a super terrible feedback loop. It creates developer fatigue. The amount of development that you can do in your cycles will be very slow. But imagine a world where you write a piece of code, there's a watcher, it's running a test, and you instantaneously get back feedback of whether that code has passed or failed your test cases. So introducing Starship, we have a development environment. We can simulate n number of chains, 1 chain, 2 chain, 3 chains, n number. We have different clients for Rust, Go, as well as TypeScript. It also serves up a local chain registry and an Explorer, IBC relayers, and it's actually being used in production for osmosis. We're testing all the amino encoders and proto encoders, all of the LP functionality and pool functionality in Osmo.js. So what's also really cool about this, it works in GitHub Actions. So we have a very lightweight system. It simulates all the things, and in the future, we hope to get not only for testing, but also for running production infrastructure. So one question I also have is, have you guys ever bike shed or wasted time talking about UI frameworks, such as whether you want to use React, Vue, or Svelte? I know we launched Cosmos Kit, and some people are like, hey, we love Cosmos Kit, but you're only supporting React. Well, we heard your feedback. We've listened to you. And we think that people evolve, technology evolves, so should our software, right? So we introduced to you Interchain UI. It's an interoperable UI kit. It's framework agnostic. We have pre-built blocks, branding and theming. Effectively, you can write once and render everywhere. So supporting React, Vue, Angular, Svelte, web components, among others. And it's in collaboration with the Design DAO. Julius here is also part of the team. So we're really excited about this. And we're going to launch Interchain UI in the coming weeks. They'll have an Explorer where you'll be able to just literally, like in the Bootstrap days, where you can just copy paste components in. We're going to have a whole set of categories of components for DEXs, NFTs, wallets, utilities like chain dropdowns and these kind of things, to make it very easy to build applications and front-end applications, in addition to all of our other tooling that we have. So this also brings us to Cosmos Kit. You guys might be familiar. If not, it is a unified wallet adapter. So you've got one interface, but you have many, many wallets. We're supporting 15 plus wallets so far. We have contributors from all the top teams, such as like the CTO from Cosmos Station, team members from Kepler and Chainapsis. So this is a community-driven project, and we're actually, it's just very simple. You connect the modal. You can do either from mobile or from your extension, and it gets you connected. This process, if you rewind about a year ago, could take multiple days, probably up to a week, to even connect to a wallet and make a transaction. Not to mention you have to end up encoding these transactions manually in the past. So again, it just goes back to the core of what we're doing, minimizing that gap between your idea and the execution of your idea. Connecting to a wallet and signing a transaction should be the easiest thing. You shouldn't have to think about it. You should think about the types of messages you want to create and the applications you want to build, not dealing with connecting with wallets. So let's just make that simple. We're announcing Cosmos Kit 2.0. We have a bunch of new features and improvements in Cosmos Kit 2.0. One of the exciting ones is you can natively connect to Ledger, so that whether a wallet supports Ledger or not doesn't matter anymore. You can actually just, right from Cosmos Kit, connect to your Ledger via USB. We also have reduced the bundle size to 1/6 the original. So any folks that were worried about tree shaking or bundle size, we got you. And if you're ever wondering where to start, look no further than create Cosmos app. So run one command and you get a full boilerplate. You get a Next.js application. You've got Cosmos Kit for connecting to wallets. We've got documentation to all the libraries. If we're using specific examples, we might have Telescope or TS Cogen for converting your Cosmos SDK or contracts into TypeScript code. And it's literally just takes seconds to install. We also have a bunch of really great examples. Let's say you're a small startup and you can't necessarily get listed on some of these more popular staking dashboards, well, literally in 3 seconds, you can install our stake tokens example, and now you have a fully functioning staking dashboard. This is not just the UI. This is the UI and the Telescope transpiled libraries. It's also connecting with Cosmos Kit, and the transactions are fully functional. So if you guys launching a chain, want to have your own dashboards, 3 seconds later, you can have one that's fully ready to deploy. We also have swapping tokens. This is based on Osmosis, and we're probably going to be also doing some partnerships with Skip to make some more swap UIs as well. We've got providing liquidity. So if you guys want to make some alternate, Osmosis UIs and maybe integrate with Skip or some things right now, you can use these examples to start from. We also have asset lists and IBC transfers. A new fun one I'm really excited about is the NFT example. So you just literally in 3 seconds can launch your own NFT website powered by Stargaze. So what's cool about this is if you're a creator now, you can customize and make your own experience for people to mint NFTs. So I think this is something that you see a lot in Ethereum, and now we can do this in the Cosmos. So create Cosmos app. It's an NPM install globally, and 3 seconds later with one of these examples, you can start having fun. Essentially, Cosmology is a factory for apps. It's like a Web3 printing press. Effectively, we convert the Cosmos SDK, Go modules, or the CosmWasm smart contracts into these really neat packaged multi-chain client packages. And effectively what this does is it allows us to bring more Web2 developers into Web3 because it abstracts all the complexities of the cryptography, the math, all the blockchain technicalities away so that if you're a Web2 front-end junior React UI developer, you can now start building apps in the Cosmos today. This was not true about a year ago. So effectively, this is what our tooling that got us in the Cosmos does. I'll quickly tell you about some of these products. So the first one is Telescope. This helps you convert Cosmos SDK chains into TypeScript packages. It's downloaded over 5,000 times per week. It's being used by the top projects such as Osmosis, Stride, even DYDX. Effectively what it does is it converts all those proto-buffers and the technical stuff that I won't get too into these really neatly typed packages. And as you can see here in your IDE, it will give you full autocomplete so you can explore all the modules in the Cosmos SDK. All of their messages that you can create are just easily creatable. Also, their arguments are also fully auto-completed here too. So the idea is now as a developer, you can just start to explore all the APIs in the Cosmos or all the APIs in the contracts without having to go to any documentation. The Telescope will basically fully kind of create this self-documenting, self-exploring system so that, again, as a developer now, you want to build a dApp, you don't even know what the modules are. Well, they're fully explorable for you. So, just doing everything we can to help people move faster, query the chains and the contracts, and getting us to the contracts, that's where TS Cogen comes in. So actually, small story, I built Telescope, and I went to a Web3 event in San Francisco and met Jake Hartnell. And he was like, hey, dude, what you did for Telescope, you got to do for contracts. Like, it's actually going to be 10 times easier than Protobuf. So we got together in the mission at a coffee shop. I think we actually put the prototype together in about a half a day. And anyhow, so TS Cogen is now the de facto tool for CosmWasm for the front end. It's downloaded over 4,000 times per week. It's used by top projects such as DAO, Osmosis, Juno, Mars Protocol, Stargaze. Probably, if you're not using TS Cogen for your CosmWasm projects, we don't know what cave you're living in, but you should definitely be using this. It will save you tons and tons of time. So talk to me or Jake or anyone else that is working on CosmWasm. We'll be glad to help you guys out. Effectively what it does, same kind of thing. It just types all of your contracts to give you that really easy to use, fully explorable, self-documenting way of interacting with your contracts. And look how easy it is now. You just instantiate a client and call mint. That's it. So no cryptography, no understanding blockchain, no encoding, no proto-buffers. That stuff gets completely abstracted away. So really just trying to simplify it for developers. A cool new thing we launched at CosmWasm, if you are using CosmWasm, we have this, and in React specifically, we have this use contracts hook. It transpiles all your contracts into a nice hook. And the beauty here is what it does, it automatically will asynchronously fetch all of your RPC URLs. It will fetch all of your async CosmWasm query clients and signing clients under the hood, so that when you're using a contract, look at this is all synchronous. So if you're in a React component, you want to write synchronous code, you use this hook. Here we get with the marketplace signing client synchronously, and we can just literally call this method that I believe is updating the ask price for an NFT. So again, this is something that I think a lot of developers were wrestling with, because they wanted to write they want to update the ask price, but then they're burying in their code this use effect hook for getting the RPC URL, getting these clients, and before they know it, like they're struggling with React hooks and not even getting to call the method on the NFT object. So the idea here is like, hey, let's just get from 0 to calling your NFT contract in 0 to 3 seconds. So under the hood, what it does is it wraps the TS CodeGen clients with all the information that you need, and there's a use effect hook that kind of manages all that for you, so you don't have to deal with it anymore. I think this will probably 5x your current TS CodeGen development if you're already using TS CodeGen. And if you're not using TS CodeGen, you'll probably 10 to 50x your development. Another cool one that I'm still surprised people don't know about this package. The chain registry, which actually there's the Cosmos chain registry. This is where we get all this information. You can NPM install this library that will effectively get all the chain information, all the asset lists and tokens from the Cosmos chain registry into a nicely bundled package. But if you're building DEXs, if you're building anything to do with tokens, which I imagine a lot of you are, you should probably check out this library. And this is downloaded about 6,000 times per week, so it's a very popular library. You can depend on it, that is for sure. It also has all the IBC information. There's another thing that you should know, because some people are wondering, well, hey, should I keep installing this NPM module? Well, if you install our client, you can dynamically fetch these things. So if you want, you can just pass in the chains you're working on. You can then get these asset lists dynamically, so that they fetch it from the Cosmos chain registry while the user is actually using the app. So that way, when we're in the bull run and new tokens are being listed, if you wanted to, you could support those dynamically. So the last thing I'll end this on is in 1983, Trip Hawkins and the Electronic Arts team launched this really awesome campaign, Can a Computer Make You Cry? And they really talked about the aesthetic of building software, the software artist, and I think that in recent years, like technology and software has gotten so complex that we've forgotten that the software engineers were the musicians, the artists, the creative people. And I think a lot of us obviously are really creative, and just remember that it's the aesthetic, it's that creative genius, that excitement and an inspiration that I think brings us all here. And so I hope to help catalyze all of you to execute your ideas and build really amazing things for the cosmos. Thank you, guys.
Well, congratulations, Dan. A lot of achievements, and I think you've got a lot of applause just in that short 20 minutes. Well done. So up next, we have Susanna Evans from Interchain GmbH. She's a product lead there who's going to talk about fungible tokens, the tenet of IBC interoperability.
Hello. Hi, everyone. So yeah, I'm going to talk about fungible tokens and why they're so important for IBC interoperability and interoperability in general. So I'm Susanna. I'm the product lead for the IBC team at Interchain. We work on IBC Go repo and the specs. We maintain and develop, and I'm sure there's lots of you using these repos. So yeah, today I'm going to start by covering interoperability, fungibility, just give an overview of why it's really important. Then we'll go into a bit more detail about channels, and then how you can upgrade channels, which is the reason why we need to upgrade channels. Is all linked to fungibility. So let's go. So I'm sure pretty much everyone here has seen this image. It's from Map of Zones. It's just showing us how the IBC network looks. Currently, we have over 60 chains that are connected and interoperating, all using IBC, token transfer, interchain accounts, queries. There's loads of different cross-chain applications which are just being leveraged by using IBC. And just to give an example of how much this is being used, between last year and February this year, over 29 billion value was transferred using IBC. This is huge. And right now, we have mostly Cosmos SDK chains, Tendermint chains. We recently connected to the Polkadot ecosystem, which is really cool. And we do have more diverse chains coming soon. So we will have connections to Ethereum, Namada, Penumbra. And in this time that IBC has been live, more than 2 years, there have been no exploits. Woo, yeah, exactly. So this is huge, right? Interoperability is so important. We know about the fragility of all of these systems in general, but IBC, battle-tested, secure, strong. So we know how great the IBC network is, but one day a few chains said, hey, actually, I want to have connections with Ethereum. Right now, we can't have a direct connection using IBC to Ethereum. So we have to use other solutions. I've just given a few examples of some solutions. So you could use Gravity Bridge, you could use Axelar, you could use Wormhole, or you could make your own native bridge. There are options. So great, we can connect to Ethereum with one of these options. But let's say I'm Osmosis, right? And I wanted to connect to Ethereum so that I could have USDC flowing into Osmosis. If I chose all three of those solutions and deposited USDC in Osmosis, I would have 3 separate representations of USDC coming from Ethereum, right? And if I'm a user, that's quite frankly terrible. No one wants to have to deal with fragmented liquidity, knowing that these 3 tokens are not going to be fungible with each other. You just want to have one representation of USDC in your USDC Osmo liquidity pool. And Osmosis, they're a great team. They had this foresight, right? They realized you can't have multiple different bridging solutions coming into Osmosis because it's going to create this fragmentation. And they went through a whole governance proposal to decide on a canonical bridge provider to connect them to Ethereum. And in the end, they went with Axelar. And now we can see if we look for the USDC Osmo pool, there's just one, right? The front end is abstracting away that actually it's the representation coming from Axelar, but to an end user, we just have one USDC Osmo pool. And this is just really important for user experience. Like, you don't want to have loads of different representations of, to you, what you think is pretty much the same token. You just want to have one unified liquidity pool. So yeah, why am I talking about other bridges? Let's bring it back to IBC and how fungibility is still relevant for IBC. So imagine I want to send Atom from the Cosmos Hub to Osmosis. I'm going to use ICS-20. That's the standard for token transfer of IBC. Hopefully, as an end user, you would just use one of the existing front-end applications which abstracts away all this complexity. So you've got the native Osmosis front end. Here's TFM. There's IBC.fun by the Skip guys. Loads of options. But under the hood, you're using the channel between the Cosmos Hub and Osmosis. So you're using transfer channel 141 on the Cosmos hub. You're sending data packets to Osmosis to arrive at transfer channel 0. And you're sending Atom, right? So you have your Atom on the hub. And then on Osmosis, it actually arrives as an IBC denomination. And an IBC denomination is the hash of the path and the base denom. So the path for this Atom arriving at Osmosis is the transfer channel 0 on Osmosis, and the base denom is UAtom. And then this actually ends up in this really long, horrible-looking string of letters and numbers. And obviously, as an end user, you don't want to have to see that. And thankfully, front ends abstract away that complexity. So if you go on MintScan and you want to see the atom on Osmosis, it will just appear looking like this: Atom IBC token. But for the observant among you, maybe you've also seen on MintScan that there are like loads of other channels that you could choose to transfer your tokens on with IBC, right? There's not just this one channel. There's a few other which aren't really being used, but they exist. And if we go back to what I just said, what is an IBC denom? It's a representation of the token, and the path that it took to get there is really important, right? So if I send tokens on a different channel, it's going to have a different path. So therefore, it's not going to be fungible with the tokens sent on a different path. So therefore, there is this kind of fungibility problem in IBC as well. If you pick the channel which the liquidity pool isn't made up with, if you try and deposit, it's not going to be possible. So then how do you know which channel to pick? This is a good question, and there's loads of registries in Cosmos which are trying to make it easier for people to know, okay, you should pick this channel. This is just an example of what Stride have on their GitHub. They just list all of their canonical channels. But the canonical channels are really just decided based on social consensus of, okay, we're all going to use this channel. Great. As a side note, I do think that there should be local on-chain registries that chains maintain to indicate which channel they use canonically. Osmosis have implemented one in CosmWasm, but yeah, that's just a little side note. But all of that is to say, all of the accumulated state in a channel is really important. Once you create this channel, it's really important that we keep using this channel. And this channel in particular, between the hub and Osmosis, has been used for 8 million transfers. It's been around for well over 2 years. And this channel in particular has sent back and forth $1.5 billion in value. OK, so let's look a bit more in detail about channels. So a channel is just a way for two applications to communicate with IBC. They do this by sending data packets along this channel. And channels enforce the ordering of packet delivery. So for transfer, we don't care about the order of packet delivery, but other IBC applications order matters. For instance, interchain accounts, you need ordered channels. Channels ensure that packets are delivered only once. And this is really important because, you know, if you're sending tokens, you don't want double spend, things like this. And a channel determines who can communicate on that channel, which application module can send packets on that channel. And I've also just shown you the other abstractions in IBC. We're not going to go into those in detail today. We're really going to focus on channels. But yeah, below the channel layer, there's other transport layer abstractions. We don't need to be concerned with these to understand what's going on at the channel layer and the application layer. So if we just take a little more of a look into what's a packet. So a packet has a sequence. This is important for enforcing ordering. It has information about timeout. So this is to say this packet needs to be delivered by this time. It has information about where the packet came from, where the packet's going to, and then it has data. And this data is just taken by application modules. The application module will decode the data and then perform specific logic that it needs to perform. So for instance, for token transfer, this might be minting a token, escrowing tokens, whatever. So then how do we create these channels? So there's something called the channel handshake, which I'll go into in detail. But what are we actually making when we make these channels? Okay. So the channel end is defined by this interface. You have state of a channel. When packets are freely going back and forth along this channel, it will be in the state open. But to create this channel, we go through two other states. We go through initializing the channel, and we try to open this channel. The ordering, so as I said, token transfer, unordered, but for interchain accounts, you may have ordered channels. And then we want to know who we're talking to, who we're communicating with on this channel. Connection hops is less relevant for IBC today because we don't have multi-hop routing. In IBC, we currently have direct connections. But in the future with multi-hop, you can have two channel ends which have an intermediate chain between them. And the version is defining which application module is using this channel. And upgrade is what we will talk about a bit later in this talk. But first, how do we make this channel? So first of all, we have two chains. They don't have channel, so the state doesn't exist yet. Then an application module calls chan open init. They say, I want to form a channel between my chain and my counterparty. The channel on chain A now is in the initialization stage. So we've defined all of the parameters that we want this channel to have. And this is just the starting point of creating the channel. Then a relayer will basically let the counterparty know, hey, your counterparty wants to make a channel. Here's all the parameters that they want to make this channel with. What do you think? Looks good to you? If the counterparty says, yes, I want to make this channel as well, I agree, all of these parameters look great, then it moves into the try open state. Then a relayer will send a message back to the chain A who wanted to make the channel in the first place saying, hey, chain B says it's all looking good. They agree with the parameters you proposed. And then the channel on chain A moves to open. And the last step is sending back this confirmation that your counterparty is ready to open this channel. And then you have an open channel, so packets can flow freely between the two chains. And then we have to write the channel in state. So in this case, for the communication between the hub and Osmosis, we have open channel, we have unordered channel because we're just using transfer. The port ID is transfer for ICS20. The channel identifier on Osmosis is 0. And our version is app version ICS21. So yeah, then we end up with this channel, which we've been using to send Atom from the hub to Osmosis. That's great. But one day, a relayer says, hey, I love IBC and everything. It's amazing. But I'm actually paying all of these fees and infrastructure costs to relay these packets. And then the IBC team said, OK, that's fine. Don't worry about it. We made ICS29. So ICS29 is a middleware you add to both ends of your channel, and it ensures the timely delivery of packets whilst making no new packets in the process. Great, we can add incentives to relayers. Everyone should be happy, right? But then let's look again at our channel, okay? So we have this version, app version ICS21. This is the version of the channel 141 between the hub and channel 0 between Osmosis. But now if we add fee middleware to this channel, we have a different version, okay? We have fee version ICS29, app version ICS20. So it's not the same anymore. So what can we do? We could create a new channel. The problem of doing that is we lose all of this built-up state in this channel, and we lose the fungibility of all the tokens that was transferred along this channel. Okay, it's probably not a good enough trade-off to bother creating a new channel, right? There was 8 million transfers that took place along this channel. I don't see why anyone would bother, and no one has bothered creating new channels, right? So there must be another solution, and thankfully there is one coming very soon. So you can upgrade an existing channel, okay? So what's the benefit? You retain all of the built-up state in the channel. You retain the fungibility of all the tokens you transferred along that channel. And another bonus is you get to prune all of the prior acknowledgements along that channel. So just for some context there, Osmosis have 26 gigabytes of pruned state in their archives, and 5 gigabytes of that is IBC data. So if you could prune some of that data, that would be pretty nice as well. So yeah, now let's talk a bit more about what channel upgradability is. So channel upgradability is basically renegotiating the channel parameters. And what you can change is the ordering of a channel, the version, so you could add fee middleware, you could even upgrade existing application modules, and you can change the network topology by adding and removing connection hops between two channel ends. And you do all this whilst retaining all of the built-up and existing state in the channel. And this is really important for future-proofing IBC. So how does it work? Now we have our two channel ends. They're both in the open state. After a governance or authority-gated process, chain A will call channel upgrade init. And this is signaling, I'm ready to perform this specific type of upgrade. And what they will do is they will say, OK, for this specific channel, I want to perform this upgrade. And they'll put that in a provable store. Now, in this scenario, we're taking kind of the simple happy path scenario. Chain B is ready for this upgrade. They've already done all of their wiring they need for the upgrade. And they have decided to permissionally accept incoming upgrades. So now we know that our counterparty wants to do this upgrade. So a relayer can then submit chan upgrade try. And they submit this along with the proof that the counterparty wants to perform this upgrade. Everything's going well. The chain B also wants to upgrade. So now they can start flushing the channel of all of the packets from the previous version in that channel. So now channel B will move to flushing. Then a relayer will submit chan upgrade ACK. So this is to say channel B agrees to this upgrade, and they've started flushing packets on their side. We're also going to start that process as well. So we're going to start flushing out all of the packets in the channel that are from the old version. And obviously, during this flushing process, you can't send new packets. So send packet is enabled in the channel. So basically, it's kind of freezing the channel, getting rid of all the previous packets that may have been built up. Then both channel ends will complete the flushing process. You submit confirmation that the upgrade has been successful, all of the previous packets have been flushed. We can now move the channel to the new version. And you'll also submit that on the originating chain for the upgrade. And now we have the channel in the open state again. Packets can flow freely between the channels. But we have the new version of the channel. Okay, now we've added fee middleware to the channel. Okay, so we've got relayer incentives and we've got token fungibility. Amazing. But that was just one example of what channel upgradability can be used for, because as soon as the feature is live, it's ready to use that. But channel upgradability has a lot more to offer than just adding relayer incentives. There's 3 main things you can change, right? So ordering. Right now, for Interchain accounts, you need ordered channels. You might want to not have ordered channels. I think this has been a bit of a pain point. There shouldn't be ordering necessarily with Interchain accounts channels. So now, with channel upgradability, you could change an ordered channel to an unordered channel. Censorship might also be a concern, right? So with token transfer, you have unordered channels. What if you want to enforce some kind of weak ordering to make sure that all packets are actually delivered. So you could retain token fungibility of your token transfer channels and change the ordering from unordered to weak ordering. As I mentioned, versioning. So any upgrade that requires middleware at both ends of the channel or some kind of change that would not be backwards compatible. The example here is adding relay incentives, but this can really be extended a lot further. So if we want to improve ICS 20, one of the big improvements many people have asked for is having multiple coin types in an ICS 20 packet. With channel upgradability, we can now enable that. And connection hops is really, really important for future-proofing. And if we presume that Interchain is going to grow, we need to change the network topology of IBC, right? We might say, okay, I have this direct connection between two chains. It's really congested. I actually want to use a router chain who's going to give me some kind of benefit. They're going to deal with all the infrastructure of relaying, especially when we're connecting non-heterogeneous blockchains. It's going to make a lot of sense to have router chains then. Right now, we just have a lot of Tendermint Cosmos SDK chains. Everyone has a direct connection. But in the future, connecting to Ethereum, this is going to be a lot more expensive than having these direct Cosmos connections. So yeah, it's just a really important feature for future-proofing the protocol. So yeah, thank you for listening, and yeah.
As we get set up for the next session, I'm just going to very quickly tell you something special about day 2 today. The studio is open for 2 workshops. The first one at 2 p.m. I'm personally really excited about because I'm running it with a few members of the Cosmos Cartel called Moving the Needle for Women in Web3 and Cosmos. It is a discussion of still a representation of women in Cosmos, but also an interactive experience where I hope that all projects will send a representative to join us, both men and women, to kind of develop actionable solutions that will help onboard all women and also benefit Cosmos ecosystem as a whole. So it's a chilled room. It's going to be Chatham House rules. So we're going to share, we're going to talk and discuss and actually do it right this time. The second workshop is at 3:15, which is hosted by Chainflow. It's a validator meet and greet. There will be a presentation by Chorus One. I don't know if Brian, you're doing the presentation? No. Someone else is doing the presentation. So yeah, come join the women's session and then stay on for the validator meet and greet. Now, we're moving on to the next session, which I think will be a very, very lively discussion called Does Cosmos Have an Identity Problem? It will be moderated by our very own Crypto Danny. And for the panelists, we have Yelena Juric, the co-founder of Noble and the Cosmos OG. We have Charlotte Dorsey, who is the CEO of DYDX Foundation, and Adrien Fage, who actually, I think he's now the founder of Stake Lab and no longer DevRel of Ledger. So panelists, please take the stage.
Hello.
Yeah, it's very hot.
Testing.
I'm going to be sweating.
Good morning. Thank you, everyone. Oh. Are you fine? There's water.
Rest in peace, coffee.
Yeah, rest in peace, coffee.
Oh, the coffee died.
So,
Yeah.
first, I'd like to thank Adrian, Charles, and Jelena for joining me on the stage today for the panel. And as a non-technical person, it's nice to see the views from people on the technical side of things, which led to the panel today being called Does Cosmos Have an Identity Problem? So what I wanted to start with the first question is, how do you see Cosmos, how is Cosmos being perceived from an outside perspective?
Okay, before we get started, I actually want to hear from the crowd. Who here thinks Cosmos has an identity problem? Raise your hand. So, that's a bad thing. So, we think that's a bad thing. Okay, and who here thinks there's no identity problem? We've figured it out. We know what we're all about. One person, okay. All right, so just to set the stage, I think a lot of people are going to be expecting us to talk about the fact that we have an identity problem. So, sorry, what was the question again?
The question was, how is Cosmos being perceived from outside the ecosystem?
Yeah, I mean, I'll begin. I definitely resonate with the crowd that just raised their hands to say that Cosmos has an identity problem. You know, I think we're looking at ourselves in comparison to other ecosystems, Ethereum, Polkadot, Solana, you know, Avalanche. And it's definitely very chaotic and very sort of divisive, right? We have this, you know, thesis of the Internet of Blockchains, of sovereignty, and I think with that comes a lot of, you know, identity crises. But I'm curious what my panelists have to say.
I can go next. So, okay, probably I think like the thing we kind of like missed is just because when you go like outside, it's like people like walking and they're kind of like maxi about like Ethereum mostly or Bitcoin mostly. So they will probably work on something really different than the framework that Cosmos have. Cosmos is all about like interoperability, as you say. And the thing is, we have this question about identity because there is like a lot of chain. There is like no CEO. There was one before, like for Cosmos, but RIP. So I guess like now we don't have like anyone that just like lead the thing. There is like many people that you will know, like Jelena, Charles. You will have I don't know, like Zaki, Jack, Jay. So many people. Like from the outside, I guess like people are just wondering like, who the fuck just like lead this? So yeah, I guess probably this is like the problem that we start to have. And there is a good project like DIDX here that can probably have this thing like, I don't want to say like I'm building on Cosmos, but I use the Cosmos SDK.
Yeah.
I think there is an analogy I want to take is maybe Cosmos is in the early days of his journey and is probably entering some kind of teenager crisis. And whenever you're parents and you have a teenager, you know it's complicated, you have a lot of question marks, but eventually you stay optimistic and you know that you're going to go through this, right? So another analogy which comes to mind, also coming more from the Ethereum side of things and kind of entering into the Cosmos space is I see the Cosmos ecosystem as maybe like a city. Maybe let's take the example of Paris, since we are in Paris today. Thinking of everyone can come to the city has some very great infrastructure, and then you will have different districts within the city. In France, we call them arrondissements. So maybe some district will be more towards maybe manufacturing, some other district will be more like entertainment, restaurants, and eventually this identity kind of iterate itself and give like a sense of identity for the member. So everyone come with your own identity, his own identity within the city, and eventually you get also like a shared identity. And this process takes time. I'm natural optimistic. I'm very optimistic in the industry overall. And when I see this kind of setup where we've got a lot of infrastructure, a lot of different live journeys, people come within the space for different things. People have an infrastructure play. Some others are thinking of applications, gaming, DeFi, you name them. I think this kind of patchwork usually works very, very well, and we've seen some cities in the world which are really inspiring. I'm thinking of New York, I'm thinking of Paris, I'm thinking of London, I'm thinking of many other Asian cities as well. And keeping this kind of inspiration and being good citizens, and kind of ambassadors of our ecosystem will help solving the identity.
Yeah, I mean, I love that analogy of a city. Another one I really resonate with is this idea of a bazaar. You know, you have this marketplace of, of vendors and sellers that are all creating these products, and almost anybody can set up a stall at this bazaar. There's no ticket to entry, really. There's no high cost. And so everyone really, I think, from that perspective, is kind of welcome to set up their own shop and kind of do trade and conduct business with other people and other businesses in this bazaar. And I think that very low barrier to entry is actually very empowering as well. So it's a very self-organizing, self-organizing system of different actors and different people.
Yeah, no, that's great. And I think, like you say, it's important that users and the community and people like that can see from your side of from your point of view and everything. So what I will do is go on to question 2. We'll go straight on with it. We'll get straight on with it.
No worries.
So the next question I want to ask is, what attracts builders to come and build in Cosmos?
Okay, I can take it. So I think like the real thing that we are good at, probably not the identity part, but we do have like a big framework, like the Cosmos SDK, let's say it. It's literally like something that everyone can use and everyone is building on the same. Probably if you go like somewhere else, you will have like some problem with, because you will need like to create like custom things to just like differentiate yourself. It's gonna be hard to just move forward with the others because as it's custom, it creates a lot of problem. In the Cosmos SDK, everything is like interoperable, using the same. There is like different version, but actually they are compatible, so it's pretty okay. So I guess like this is like the thing that interests them because you have like the whole set that is like kind of like Lego. So you just like take the little one you want and you build your castle. When you have your castle, you can modify it and just like build on top of it. And it's just like pretty easy. Like you can see like there is like Noble that build like an emission chain for like any token, like assets. So yeah, you can even like make just a trading one, like for perp or whatever. You can literally build like anything. It works because it's flexible. And I guess like on the other ecosystem, it's less flexible, so more complex, I guess, to build like very fast.
I think there is also a trust component. Even though we are all building trustless technologies, the trust of users or trust of developers needs to anchor somewhere, and that's also a little bit of a paradigm in our space. And Cosmos has been out for a long time. The developers are respected. Coming from Ethereum, you've got like a great reputation also as a Cosmos developer. You've got the SDK, which is also in place and kind of battle tested. So this trust aspect is also something which is also a great asset and part of the kind of branding assets for the Cosmos ecosystem overall.
Yeah, I mean, I think we maybe don't do a good enough job of emphasizing how easy, well, you know, to Adrian's point, it is to build with something like the SDK. You have obviously all of these modules that have been, you know, battle tested, that have been well adopted by, you know, 50 other projects. If it's something like the bank module or even something newer like the token factory module, which obviously Noble is leveraging. So the fact that you have all of these like little building blocks that are pretty much out of the box already extremely efficient and easy to use is maybe something we don't talk about enough. So from a developer experience, it's relatively easy. But I would say actually IBC is probably the thing that really gets developers excited and motivated. The fact that you have all of these applications on top of IBC, the fact that, of course, you could do token transfers, but you could also do, you know, things like, queries, and you could do different types of applications on top of IBC, things like a solo machine, and you know, I mean, there's like 20 different standards. Is very inspiring for developers that can all of a sudden, you know, kind of fit IBC to their use case pretty easily.
Yeah, and I guess like about like what you're saying, something that is very strong is you have like different chain. They are not like using the same language. You can have JavaScript with Algoric, for example. You will have like basic Rust if you want to use like CosmWasm, like a smart contract. You can even like make like Solidity, like using like some EVM, like Ethos or whatever. So generally, you have like a lot of like different language, and I guess it's like more open like to people. If you want to build on Ethereum, just learn Solidity, and you don't have like much way to just like build something. So pretty more open to builders.
Yeah, anything else you wanted to add?
Well, I'm just going back to the question, does Cosmos have an identity problem? I mean, maybe it's because of this abundance of choice and freedom of choice that it's really hard to create an identity for your project because, like you said, you can be a Java developer, you can be a Go developer, a Rust developer. So all of a sudden, you know, what's the thing that unites all of them? Sometimes it's kind of hard to kind of make that cohesive and have an identity that unites the entire ecosystem, which, you know, actually maybe is not a bad thing. Maybe it's better to have this plurality of identities.
Yeah, no, that's great, amazing. And then, so carrying on from this conversation, I think question 3 leads perfectly into it, which is what's needed to bring more builders and adoption into the ecosystem?
I think the stage, in my opinion, of building infrastructure is definitely well on. And the same way you build a city and you want to make sure transportation is great for your city to strive, We have obviously a lot of bridges around us, but what I would love to see is more projects thinking on how to bring tooling to bring more users, and not thinking of building the foundations and building the infrastructure, but like thinking of how do we bring more bridges, more pieces of software to maybe bring people in, making sure there is code available for applications to kind of help them to acquire users and land users more easily. So it's a lot of user experience. It's a lot maybe of affiliate modules, so that whoever builds within the Cosmos ecosystem will come with possibly part of an updated SDK, having an affiliate system to really help all these infrastructure players and new dApps to really acquire new users. I think the space overall has been shy on really thinking not only about infrastructure, but thinking how do we set our newcomers, new developers, new apps, new dApps being successful by giving them the tools to acquire users much faster. A little bit like the early internet, when Web 2's applications were not really ready to kind of scale customer acquisition, and I think this can be a really strong and impactful contribution to our space, is to get tooling and kind of also shift of mindset in a way. So we just think, okay, how do we make those guys successful in a more long-term way?
Yeah, no, you're right. I think because from a user perspective, it can be still quite challenging navigating the space. I think it's one of them where if you know how to use the space, then you're fine within it. But if you're someone new coming into the space, it can be scary and things like that. But do you guys have anything that you want to add to?
Yeah, I mean, I'll take a slightly different approach. If you go to an Ethereum conference and talk about Cosmos to, Ethereum people, they will say how Cosmos has the best developers and the best technology, and it's a great stack, and, it's like some of the smartest people they know, but from a business perspective or from like a go-to-market perspective, they don't really know who to talk to. So actually, I think that having more people like this join our ecosystem that are, can talk to maybe larger institutions, can talk to maybe more of a mainstream audience. To be honest, like what Consensus did in the early days for Ethereum, to have that in Cosmos would be pretty amazing. And you don't need one organization to necessarily do that. You can have that function be split across many different projects, including DYDX. Definitely something that Noble is focused on. Osmosis does a good job of doing this as well. And so really making sure that there is this go-to-market business focus that's very strategic in nature, because the technology, I think, works and is here. And, we have DYDX obviously coming to Cosmos, and we're very excited about that. So how do we celebrate that and, make sure that more kind of business audience understands why that happened, how that's happening, and what that means for crypto more generally. So.
And I think it's like we are kind of like very early. Like it's been like only few years that IBC is like connected. There is like the version that started like 2 years, 2.5. Okay, yeah. So quite not a lot. So it's pretty young. Like people are still like, okay, should I make a Cosmos chain? What's like infrastructure or tool I should use? So there is good tools actually that are building. Like Cosmology is one. There is like some infrastructure, like let's say like Lava, building like the RPC like for everyone. There is like good thing, but the thing is, it's pretty new. They are not even live, so they are only in testnet. So imagine like for someone that just for example like in Ethereum ecosystem, for them we are lacking liquidity because we are young. We are lacking probably tools. We are lacking infrastructure. So I guess like everyone does like build like quite fast because the framework is more easier. And people should just like come and get part like of the party. we are here like it's pretty young, but we are making like just look at around you. There is like a lot of builders, and it's going very fast. Like in a year, we went almost to 100 like chains. So it's going very fast.
Yeah.
Yeah, no, I agree. And actually, I wanted to touch on something that you just mentioned, which obviously wasn't in anything that we've spoke about, but with marketing. Is marketing another problem that we have within Cosmos? Is it something that we need to collaborate more with other projects so that we can actually draw more people in as a collective?
Oh, God. How long do you have? 14 minutes and 35 seconds.
There
okay. I mean, we're not going to obviously talk about this problem for the next 14 minutes and 30 seconds, but this issue of marketing and how we tell the story of like what Cosmos is something that has definitely been very challenging. It goes back to our identity problem, the fact that you have 55 plus Cosmos chains that all have their own perspective of what Cosmos means, how Cosmos works. They have their own language, they have their own terminology, which is both a strength and a challenge. And so I think that from my perspective, it's really important to align on the basics and like align on certain fundamental truths about what Cosmos is. I mean, the fact that we don't even have one name for the Cosmos Hub. A lot of people call it Cosmos. Some people call it the Atom chain. Others call it the Cosmos Hub chain. There's like 3-4 different terms for even how you refer to one entity, which is obviously challenging. I think if we can like align on those fundamentals that have a lot of disagreements, then I think we will be one step forward to having maybe a more cohesive narrative. But I mean, at the same time, for something like the Cosmos Hub, that's important. But maybe for DYDX, that's really not important at all, because why would you necessarily care what the Cosmos Hub refers itself to? At least if you know how it works, and if you know that the Atom token is what governs it, maybe that's enough. And so I think it depends kind of who you're talking to and who your audience is. And that's where the problems lie. I mean, I think a few weeks ago, Antonio was tweeting, we don't even want to be referred to as a Cosmos project necessarily. It's not because we don't like Cosmos. It's not because we don't use Cosmos technology. Of course, that's very well known, and that's all open source. And you can look at the code yourself. But from a marketing perspective, they just want to be a good project. So I'm actually very curious to get your perspective on this. From a marketing perspective.
DYDX has a culture of really kind of reverse engineering everything from the user. It's kind of an open door we are knocking at, but this has been kind of the North Star for the team for a long time. And on the new version of DYDX built on Cosmos, users will be able to come with their MetaMask wallet, with their Cosmos native wallet, with their ledgers, with Wallet Connect, with whatever it is. So we kind of do the abstractions, taking the assumption that users don't really want to know all the details below. So some part of the audience are developers. They want to know exactly how the kind of backend works and how it's kind of performing. Some other subset of the users of DYDX are just coming for the application. So I think we should also kind of adapt the language and making sure we've got like different kind of user journeys within the Cosmos ecosystem. I feel there is clarity on how do you enter the Cosmos ecosystem as a developer or as an entrepreneur. We should maybe think and kind of work as good citizens of the Cosmos ecosystem on defining the user journey for a user, and maybe the user don't really want to know what's happening in the kitchen. They just want to enjoy just high performance applications with high connectivity and ease of use. So yeah, I think we should look at subsets of audiences and define user journeys, and that's probably something we should do as an ecosystem within Cosmos, and not being shy that we don't have to disclose all the details. Some people don't really care. It comes back to the analogy of a city, making sure that if the people wants to come to your city by train, you've got enough trains and covering enough kind of cities around, so you can become a hub. Same for plane, trains, cars. If people wants to sail to the city, just making sure as many doors are open, and if you enter the city as a user, you've got like a clear path and everything is laid on. I feel we've been targeting developers for a long time, and it's time to kind of open the kind of playbook for other subsets of users.
Yeah, and just to finish about like the marketing part, I guess it's all about like we are having like something. It's the first time there is something like decentralized as Cosmos right now, and the thing is, I guess it's all about like the culture, and there is like so many different culture. Like if you see, there is like some wizard, there is like some people wearing like bear mask or chihuahua mask. Like there is like many different cultures. So I guess like it's pretty hard. Like we are just like defining it. We are trying like probably to see like which identity we should have. Everyone is like trying to do them at their level, but at the global level, it's pretty hard because we don't even know how to make it. It's pretty difficult. Like imagine a project which is like very centralized. Even for them, I guess like they kind of like struggle to realize like who they are, like who which cultures they should like provide to everyone, which identity they had. And we are just like here with like 100 chain and just like struggling to say like, well, what should we use as a marketing? And probably I just like think we should just like build like all chains and just see at the end.
No, that's great. Yeah, exactly. So yeah, I think like you say, because we've got 9 minutes left, I'm going to get on with the last question for the panel, which is, so is IBC the standout narrative for what Cosmos is trying to achieve, or is building on the SDK stack, sovereignty and scalability, you know, is it, yeah, which one is drawing the people in?
Well,
or is it both? Sorry.
I don't know. Maybe to Charles's points, it's neither. Maybe we shouldn't be focusing on, you know, is it the SDK or is it IBC or is it Tendermint? Maybe it should be more about the philosophy of what Cosmos represents, which is, again, more of this self-organizing, highly decentralized, highly sovereign ecosystem of, you know, entities and chains and developers and entrepreneurs that all kind of come together, you know, to your point, and just experiment with culture, experiment with applications, you know, experiment, you know, with technology in a way that makes them excited, and maybe we'll see kind of what comes from that. You know, is you know, Cosmos more about DeFi? Is it more about bad kids? Is it more about, you know, attracting, you know, the highly successful, highly kind of scalable Ethereum applications like DYDX? Let's see. You know, I think that focusing on is Cosmos IBC or is it really more about the SDK maybe misses the forest for the trees a little bit.
In my opinion, the shared security also kind of upcoming feature within the space of Cosmos is something really strong. I think it gives an opportunity for upcoming projects, upcoming chains, smaller size chain to rely on each other, and that's something which is not available necessarily elsewhere in some other ecosystem. So trying to keep iterating on the kind of marketing for the Cosmos space and telling them, yes, you can be interconnected. That's a great feature. And also, if you come as young and upcoming, there will be some, by design, possibilities for you to remain safe and to kind of share security with others. In my opinion, that's a very strong upcoming feature for the space. And if it's done right, it's going to enable a lot of new projects and just scale everything.
Yeah, I guess you're right. And basically, it's all about like testing, experimenting. Like, as you say, like we are just like at the genesis of everything. Like we did IBC like 2 years ago. We are trying to make it like a standard to the whole ecosystem and even outside the ecosystem, because there is like, for example, like Picasso with like composable that did make like the first IBC transfer from Polkadot to Cosmos using Chihuahua chain. Whoop. And it's all about like this. We are experimenting, and I guess we cannot say like which one gonna just like lead us to where we should go. We just like build, I guess, standardization on almost everything. There is like, as you say, replicate security. There is like another model with mesh security. So it's all about like experimenting, but at the end, we will see like which one we're gonna like, take the lead. And you cannot, like I guess in advance we are not an oracle. We can just like build things and see like, okay, if there is like adoption from it, probably this is the way we should just like go straight forward. And probably at this time we're gonna solve like the identity problem if everyone just like use the same standard and go forward with it. But let's see, like we do have like now 2 consumer chain like for the replicate security, for example, and we don't even know if it's gonna work. So yeah. Let's see. I
mean, Noble is at the forefront of replicated security. We're going to be sharing security with the Atom Validator set, and
will you?
We will, absolutely. See, this is how challenging marketing is in Cosmos. Some people know, some people don't know. And I think that's fine. It's by design, and you know, it's an experimentation phase. It's a bootstrapping phase, and you know, to be able to share security with a $4 billion chain with 175, you know, validators all over the world. It's kind of amazing that you can just out of the box leverage a community so efficiently. So. I think to both Adrian and Charles's point, that's a really strong feature of the Cosmos ecosystem. Just you know, being a smaller project and being able to succeed, you know, with something like shared security, even though you haven't raised a token, you know, raised money for a token, you haven't, you know, gotten those validators on board. It's kind of a very privileged position to be in, to be honest.
And maybe they need to come back to the title of the panel. For me, seeing an identity crisis, if there is one going on within Cosmos, is a very positive signal. If you look at the history of blockchains in our industry, Bitcoin got also a lot of drama. Ethereum has not been a rosy journey. There was up and down. There was a leadership crisis, and people kind of reset the whole protocol and the whole things all along the way. So it's just kind of strengthened the ecosystem. So seeing Cosmos having a little bit of question marks on many different questions, for me is a very strong signal that things essentially will kind of consolidate, and there is more decentralization. We don't have to follow one leader or one thing. So it comes a little bit more messy, but eventually it's a strong signal that this is there is an upcoming very strong foundation, and it's going to be long-lasting. So I'm very comfortable with the crisis. I want everyone to navigate this as smoothly and quickly as possible, but that's a strong signal of something solid coming up.
Well, yeah, I mean, I think it's a strong signal because people actually care. If nobody cared, nobody would be here. We wouldn't be in Paris. There wouldn't be 5 Cosmos events alongside ECC that with, probably more than 1,000 people in total, probably even more than 2,000 people in total joining those events. So, I mean, obviously these are strong signals because, people care. They care.
And yeah, probably to just like answer the question, like as we still have like few minutes, I guess like probably bad kids is literally like their answer. Like it's just generally we just look at Twitter. There is only bad kids. Like I guess like builders understand that if you have a bad kids, you're part of like the community. And probably there was just like a need of an NFT. I guess probably like this simple, because I guess there is like some phases, and we are like at the phases that we want to build. And builders just like buy a bad kid. So we know each other. We say, oh, this is the bad kid. Oh, it's building on top of Cosmos. So you just know directly that the guy is using Cosmos to build.
That's great. I think we can call it a day there. I think you've answered everything amazingly, unless you want to add something else.
One more thing. So we did a poll. Does Cosmos have an identity problem? Let's just quickly do it once more for the people that were maybe listening. So raise your hand. Does Cosmos have an identity problem? Okay. So yeah, but actually less. And if no...
We are progressing.
Yeah, we're progressing. And if you don't think Cosmos has an identity problem, maybe raise your hand. Okay, see, we have more people on the other side. So I think, that's progress.
No, and that's great. And I think all we can do is just keep educating people and teaching them how to use the space and things like that. So if everyone can give my panel a round of applause, it's been an honor and a pleasure having you on.
Thank you, Danny.
Thank you.
And yeah, I look forward to doing it maybe again in the future.
Thank you too.
Thank you.
Awesome. Thank you. That went really well.
Great. So, a lot of Cosmos love there. Yeah. A lot of Cosmos love there. We will now take a very quick 10-minute break, stretch your legs, get some coffee, wake yourself up, and come back at 11:40 for, I may be biased, but it will be one of the best sessions of the summit. See you soon. Testing. We're starting the next session really soon, so grab your coffees, come to the stage. All right. So, for the next talk, I may be a little biased, but I think it will be one of the best of the summit because it is my very own DevRel from NIM who's going to talk about NIM and Cosmos, an introduction to building privacy-enhancing services. So, warm welcome to Max, who was noodling away and changing his demo dramatically last night because he want to make sure it is the best fucking demo ever. Max?
I don't need my laptop. It's okay. It's all there. Cool. Hello, everybody. So, yep, I'm Max. I'm the DevRel from NIM. And the talk I'm going to be doing today, which is a mixture of a talk and a demo, is called NIM and Cosmos, an introduction to building privacy-enhanced services. So, if I just... There we go. That's me. I'm Max. I'm the Senior Developer Relations for NIM. And it's basically my job to write all the documentation so other developers can build on it, and then also now build a demo app myself for all of you to have a look at, and look at how easy it is to use our SDK. So the outline of the talk that I'm going to do today, and I've set myself a bit of a challenge by talking about all 4 of these things, so I'm going to blast through the first 2. I've talked about this, other members of the team have talked about this. Those talks are online and they're recorded. Is that good? Sorry? Yep. I'll talk louder as well. So first, I'm going to talk about the problem that NIM is actually trying to solve, which TLDR, it's global surveillance and how to break it. Then I'm going to talk about how the network actually works, so how the mixed networks or blockchain. Then I'm going to talk about the Rust SDK, which is kind of the main focus of why I'm here today. And then I'm going to show you how easy it is to use the SDK with a demo. And that demo is going to be privacy enhancing a token transaction at the network level, right? So the main problem, which is quite a big one, is with regards to privacy, the internet fundamentally is broken, right? There isn't a single solution right now that can basically defend you, a user, against stuff like people like the NSA. This has been known for a long time after the Snowden revelations. And increasingly, private companies like Google and Meta are able to leverage the massive amounts of compute that they have, and they're able to essentially have like a surveillance dragnet. So they're able to monitor basically most of the internet and use that information in combination with machine learning to start building profiles, building patterns, and start de-anonymizing you and putting you in boxes, right? So you hear a lot about end-to-end encryption. There's a lot of talk about encryption washing at the moment, right? But even if you're using a messaging app like Signal, right, or you're using a zero-knowledge cryptocurrency like Zcash, you're still leaking metadata at the network level. What that means is that you're still leaking information about yourself. You're leaking data about the data, right? You're leaking your IP address, the type of connection you're using, the timing, and all of these things that, again, like I said before, enabled by machine learning, can start building up these patterns about you, and they can start to de-anonymize you, even if the contents of your messages are still encrypted, so they can't be read, right? VPNs don't really help you at all. All they do is push trust. They kind of kick the can down the road. You're sending all your traffic to a VPN, and you're hoping that they either don't get subpoenaed to give a government all the information about their users, and you've probably paid for it using a credit card, or you're just trusting that the VPN isn't actually logging everything and then going to sell that data to someone else, right? So this doesn't help us here. And even Tor can't necessarily protect you against the kind of global adversary that we're talking about here, the kind of adversary that can essentially monitor the whole internet and look at packets traveling around everywhere and tell who is talking to who, right? So that's the kind of lay of the land. That's the situation, which is a huge problem. So the solution that NIM presents is I won't stand in front of it, a decentralized, incentivized mixnet to protect you on the network level, and then some private credentialing scheme, a selective disclosure scheme, so that you can have anonymity on the application level as well. And these are the 4 components. There is a mixnet. I'm going to talk about that in a moment. There is a token. It's incentivized. We want the people who run the network to be paid for doing so, right? And there's great talks about the tokenomics and how this is working online, our credentialing scheme, and then the Nix blockchain as well. The reason that I'm also at a Cosmos event, we have a blockchain called Nix, which is built with the Cosmos SDK. It's CosmWasm and IBC enabled, right? And this is the thing that I'm going to be interacting with later in my demo. But like I said, I've only got 20 minutes. I've set myself a bit of a task, so I'm just going to focus on the stuff that's pertinent for today's talk, right? I'm going to do a high-level overview of how the mixnet works, how this prevents traffic analysis by this kind of global adversary like the NSA that I was talking about, talk about the Nix blockchain and the Rust SDK, which is what today's demo is built with, and show you how easy it is to use. So, how does the mixnet actually help you? What is the mixnet? The goal of a mixnet is basically to create a situation where, even in this situation, where you have someone who has a god's eye view of a network, who can see all the packets moving through the internet, right? Even in that situation, the goal is to be able to create a situation where users can talk to each other, and this global adversary can't tell who is talking to who or when. Which sounds, it sounds simple. It's actually very complicated, obviously. How did we do this? So traffic that's sent through the mixnet goes through multiple hops. I think anyone who's familiar with Tor, it's a similar kind of thing. Packets are routed according to the route that they take through the mixnet. They're decrypted at each hop, and they're sent on, right? This is just a way of unlinking your origin, and your stuff like your IP address from the thing that you're actually talking to, the service you're talking to, right? So they can't tell where the traffic is coming from. All of the data that's sent through the mixnet is encrypted in the Sphinx packet format. It's the same format that Lightning uses. But most importantly, all of the Sphinx packets are the same size, right? So you can start to see how, if you're an adversary looking at the network, then you have traffic going through multiple hops, and all of that traffic looks the same. It looks identical, okay? So stuff like traffic analysis, which you can perform on stuff like Tor, is kind of broken down. All of the traffic that you send is then mixed in with what we call cover traffic, fake traffic, right? So it's mixed in into essentially kind of a constant, imagine a signal being hidden in noise, right? Where the noise is a constant stream of identically sized, identically encrypted packets, okay? And then at each hop, and there's a diagram on the next slide, all of your packets are actually reordered as well. So you kind of send packets to one mix node. That mix node will then hold them for a variable length amount of time. It will kind of mix the packets that it has, and it will send them out in a different order that it got them. Okay? So then you can't follow one of these identically sized packets through the mixnet either. The latency that we currently have is about 500 milliseconds. We're aiming to get that down to about 200 or 300. And we're working on further optimizations on that now, which, if you're interested, come chat to me after. So this is a graph. This was meant to be animated, but it doesn't really matter. So you kind of see at the bottom, with a VPN, all your traffic, it's different sized. You can kind of start to de-anonymize the traffic just based on the timing patterns, okay? And all you're doing with a VPN, you're kicking it to your VPN, and they're passing it on to whatever service you're talking to, okay? With Tor, you're doing a similar thing, okay? Your packets can still be de-anonymized. You can still see the pattern of the packets moving through the network, and they all move through the same circuit, which again, doesn't necessarily defend you from an adversary who can watch everything going in and out of the network. Now, at the top, you have you're kind of, before your packets enter the mixnet, they're encrypted to be the same size. There should have been more of them. On the kind of GIF, you can see this. And each of these packets is routed per packet, not per stream, like with Tor, okay? And then they come out the other side. They've all come out in a mixed up order. They're all the same size, and you can't tell exactly where they've come from. I'm blowing through this very quickly because I've only got 11 minutes left, so If you have questions about this, come find me after. And yeah, here is a more kind of a deeper diagram explaining that and showing how your packets enter your NIM client. They leave it identically sized, identically encrypted. They're all routed individually through the mixnet with the multiple hops mixed in with cover traffic. The timing is obfuscated by the variable length time delays, the mixing, and then they come out of the other side and talk to your service, okay? So that's the mixnet on a very, very high level. Our next chain is a Cosmos SDK-based chain, right? It's CosmWasm and IBC enabled. And this has been running the mixnet since we launched 2 years ago. At the moment, we have 600 nodes. In our test nets, we had up to 10,000 nodes, and it functioned absolutely fine. All of these nodes were actually held, and all the rewards for these nodes were dealt with in a CosmWasm smart contract as well. So we all kind of know this, but CosmWasm massively outperforms Ethereum in this regard. There's no way you could have built this smart contract infrastructure on Ethereum, okay? And CosmWasm obviously is a lot more secure than Solidity and stuff like this. You can't do re-entrancy attacks due to the design of CosmWasm. Again, whoop, I see some CosmWasm adherents in the audience. So, onto the stuff that I haven't talked about before, the Rust SDK. We have two SDKs. We have a Rust one and we have a TypeScript one. I'm going to be focusing on the Rust one today. What does the SDK allow you to do? It allows you to integrate a NIM client actually into your code. Okay, so you can deal with the creation of your client, your creation of your key pairs, all of this, and actually integrating the mixnet functionality. So sending your packets, dealing with the stuff that you get back from the mixnet, just into your normal app processes. Okay. Previously, you had to run a client alongside your app. This obviously is quite clunky, it's quite difficult to integrate, so we've kind of allowed for developers to pull this functionality in right now. And even though the SDK is in alpha, we actually rebuilt one of our services, our network requesters, which you can kind of think of analogously to a Tor exit node. We integrated the SDK into that months ago to kind of very, very alpha test it, and those have been running really, really well so far. So even though it's not on Crates.io yet, you can pull it in from GitHub. There's some examples on our documentation of how you can do this. What this actually allows you to do is, as well as the security guarantees of Rust, which are obviously fantastic, you kind of don't necessarily need to worry about all of the complicated mixnet stuff that I just spoke about as a developer. Okay, and I'll show you how easy it is to actually just kind of plug the mixnet functionality into your app now. Obviously, it's good to know, but you don't have to, which is really nice. So, 8 minutes, let's do this. Today's demo is going to be a Cosmos transaction broadcaster service. And so what that actually means is we're going to use the mixnet to privacy enhance a blockchain transaction at the network level. Okay? So we're not going to leak all of that kind of pernicious metadata to the validator that we're talking to, that we're actually kind of giving our transaction to be included in the block. Okay, so we're not going to leak our IP address, the timing, the connection details, any of this, which can be used to de-anonymize you over time, right? We're going to communicate with a service, and that service is going to kind of make the request on our behalf with the mixnet in between us and the service to protect us, okay? And the bottom of my slides have been cut off, but in the future, you know, you can think about how you could augment the blockchain level either with our own credentialing scheme, our selective disclosure credentials, or any of the other private interchain stuff that's being worked on, you know, right now, which we've seen some of this at the conference today. So the components, we're going to have some client-side code, which is just simple Rust binary, built with the SDK, clap, and some of our validator code, which is also going to be integrated into the SDK very soon. We're going to have the service built with the same thing. And the main thing about the service is that as well as making these requests for us, like on our behalf, on behalf of the client, then the service is actually going to communicate with us, the client, without even knowing who we are, okay? Which is through the magic of something called single-use reply blocks, which I will talk about in a moment. And all we're going to do is going to make a simple token transfer. This is the architecture of it. Our client-side code will run the traffic into the NIM client dealt with in the SDK. That will go through the mixnet to the service, kind of on the other side of the SDK, right? The service doesn't even know who we are. The service will talk to the chain on our behalf. and it will anonymously pass any replies back to us. Okay? Oh, if we could have the demo video, please. So we have our service on the bottom, and we have our client on the top. All we're doing is we're calling a transaction, say, sign a transaction offline. We're passing it on a mnemonic, who we want to pay, and then the NIM address, that huge string at the bottom of our service provider. So, as you can see, we're sending the information to the broadcaster, right? Saying, could you get the account sequence information for us and the chain ID for our offline signing? And, oh, this is going faster than I thought. It doesn't matter. I will, that's how fast it is, which is nice. It's all right. I've got other slides where I break this down, okay? So let's go back to the slides. Cool. So that's kind of what we're left with, right? And there's two flows of information here, right? That's kind of happening going from the client through the mixnet to the service and back. So we're going to talk about these first bits now, right? We're going to get our sequence information from the chain. Okay, whenever you're signing something offline, you need to have certain bits of sequence information so that you can't, to avoid stuff like replay attacks. So you need to know the sequence, the number of transactions that this account has already made before, and you also need the chain ID. Okay, so this request, the first bit of what we saw there, this request was sent through the mixnet to the service, and the service queried the chain for us, right? Now, obviously, if I have to tell the chain if I have to tell the service my address so it can reply to me, then it's kind of useless. You're doxing yourself to a service, right? But through the magic of single-use reply blocks, the service is able to reply to us without even knowing our NIM address. So it's able to reply without knowing who we are, okay? So even the service can't try and de-anonymize you. How this works is that when your client sends a request to this service and says, hey, could you perform this action for me? Could you query the chain for me? It also sends along a load of pre-addressed packets, right, that the service can write to the payload of. So you're basically kind of sending along a bunch of other packets which are encrypted with the return path through the mixnet to you that the service can't read. But it can write to the payload of, so it can write the responses to these pre-addressed packets and then send them back to you. And that's how we can do anonymous replies. This is kind of what's happening there. So you're basically saying you're constructing a request for sequence information, packaging it up, breaking it up into these identically sized, identically encrypted Sphinx packets, sending it through the mixnet. It goes to the service. The service decrypts those. It deserializes them. It makes the request to the chain. Chain gives it back. And then it's kind of sent with the magic of SERBs back through the mixnet to you, and you deserialize it. Okay? This all sounds very complicated, but it's actually not, and I'll show you how uncomplicated it is now. So this is the code of actually making our client, right? And this is like with the manual storage setup. There is also like a one-liner version of this if you just want to quickly make an ephemeral NIM client and you don't really care about key management and stuff. But this is where, I actually want to properly dictate where the keys live on my machine and all of this kind of stuff, right? Still only like 9 lines of code. So now we look at how we actually construct our sequence requests and send it, right? Our sequence request is just a struct. It's just a simple struct that has the RPC endpoint that we want the service to hit on our behalf, right? Because it's doing this in place of us, remember? From the perspective of the blockchain, the service is the person who's asking for the sequence information. It knows nothing about you, the client, right? And then these lines at the bottom, 18 to 20, which could actually be one line of code if they weren't nicely formatted and stuff. All you're doing is you're saying client send string, you're sending it to your service provider, and you're just serializing this message, this request struct, and you're just serializing that so you can send it through the mixnet, right? We're sending a string here. You can also send raw bytes if you want to do that. Okay, so this is now on the service side, and what the service is basically doing is it's listening out on line 29. It's listening out for these requests, and it's going to pass them. And I'll show you how that happens in a moment. And then from the pass message, what it's doing is it's grabbing 2 things. It's getting the message it just received, and it's getting the sender tag. And what the sender tag is basically a randomized alphanumeric string that just dictates the bucket of these pre-addressed packets. that it's going to use to reply to you, right? Because if you imagine a situation where a service is maybe getting, hundreds of requests, it obviously has to be able to differentiate between which serbs to use to send back to the right people, but it doesn't know the address. So this is just a random UID, basically, for a bucket of serbs. That's all it is. So we're just passing that, and then we're just sending, right at the bottom, sending a string reply, using these using the serb bucket, the sender tag, basically to construct like an anonymous recipient type, and then we can use that to send the traffic back through the mixnet. If the clicker was working, then, oh no. Oh, here we go, cool. And this is actually how we're passing it, right? Again, very simple. All we're doing, we get a vector of messages from our client, we pass them into a string, and we just pull out the request type, we pull out that struct, and we pull out the sender tag, this alphanumeric string, and we can use that to essentially do our computation that's requested, and then anonymously reply. So now we're looking at the second bit, very much the same thing. We're, we the client, we've got the sequence information, we're going to use that to construct, and sign our transaction offline, yeah? And then we're going to broadcast that signed transaction to the service to make on our behalf. And the service, again, is going to get the response from the blockchain, which in this case is a transaction hash, and it's going to anonymously send that back to us through the mixnet. Okay, so again, this service is making all of these things on our behalf. The blockchain doesn't know anything about us, the client, right? On the metadata level, it doesn't know our IP, it doesn't know where we're coming from, it doesn't know anything about our connection. I'm going to really quickly run through the rest of this now. I'm over time, and basically the same as before. And basically the same as before. So, I don't know what's happened to my slides. Okay, I'll just ignore those. So this was a very, very simple demo, basically showing how you could use the SDK to kind of protect yourself on the network level, right? Okay, it doesn't matter. Ignore the slides. Yeah, and so obviously, if you were wanting to kind of build this out into an app, if you're wanting to actually protect yourself on the level of the chain as well, then that's where you would have to be thinking about, interacting with either a ZK chain, something like this, one of the kind of private Interchain L1s, or alternatively using our selective disclosure scheme as well, which there is an example of in our SDK documentation as well as our SERB documentation. This is me, Max at nimtech.net, if you want to reach out or just come find me afterwards. This is my Twitter account. Our docs are nimtech.net/docs, and thank you for listening.
All right, thank you, Max. Please do go speak to him so that we can make sure that the Cosmos apps and services and products will actually have the network level privacy that we all deserve. Now, so on to the next speaker, we have Ismail Kofi, who is the co-founder and CTO of Celestia. He will be talking about the Celestia architecture, present and future. Ismail?
Hello? Yeah, now it works. Hey everyone, I'm Ismail Kofi, CTO and co-founder. Louder! Okay, I'm gonna shout. Okay, again, hey, I'm Ismail Kofi, co-founder and CTO of Celestia. Today I'm gonna talk about what Celestia is and currently what we're gonna launch with and how it might look in the future. So I give a few future directions. It's not a full-fledged roadmap, but it is a few ideas what we could work on moving forward. So let's dive into the first part. let me stand here, I guess. Let's dive into the first part. So for those who are not familiar with Celestia, I'll give like a very quick overview what it is and how it works and how we implemented it. So from a very high level perspective, Celestia is the first modular blockchain network. And the core idea is to decouple consensus from execution. What does this mean, right? Like every chain today operates the following way. Like that's also true for all Cosmos chains, roughly. If you produce blocks, your clients validate the following, right? Like you validate if the header has consensus, and you also validate the transactions, like all of the transactions. So it's also true for all Cosmos chains in the sense that, like, even if you're like launch like a CosmWasm zone, you just have more transactions to validate. So this is what we call a monolithic blockchain because it does everything, right? Like it does all the tasks a chain does. In Celestia, which we call like a modular blockchain, it operates slightly differently in the sense that headers are still validated, right? You still validate if a header has consensus, right? But instead of validating all the transactions, you just validate if the transactions were actually published to the network and are available, so that you have a chance to recompute those. But the Celestia base layer doesn't do this. That's the main difference. I'm standing in front of my slides. So that's the main difference here, right? What does it mean for the transactions to be available? It just means that they've been published. And because it doesn't validate if each transaction is valid from like a state machine perspective, these transactions can be arbitrary blobs of other applications, right? You might wonder, if the transactions do not get executed and validated, where does the execution actually happen? Usually, like in a Cosmos zone, all the transactions get validated on the same chain. And if it's like a general purpose execution environment, you have like a CosmWasm zone or Evmos EVM zone, then the execution happens still on the same chain in like NVM. In the Celestia modular blockchain model, the execution happens usually in so-called roll-ups, or sometimes called client-side execution. So while Celestia only guarantees that the messages of the application have been published and ordered, and there's consensus on the order, the execution is done on a different chain in a so-called rollup that just posts the data for ordering and consensus to Celestia. So the execution happens there, and the state validity is guaranteed either through state fraud proofs, or so-called validity proofs. So like a validity proof could be like a ZK proof, right? These are like the two ways, the two main ways how execution works in Celestia. These are the design principles that we designed Celestia with. I'm gonna very quickly summarize those. So the block validity is done via available, like it's only checked if the data is available, right? That I already mentioned that. Two other main goals were that applications only need to care about their data, right? Like they only need to care about the data they need to execute in their rollup. They do not need to download any other data from any other application. This is different from like how Ethereum, for instance, currently works. In Ethereum, you download all the transaction data of all Solidity smart contracts deployed on Ethereum. Additionally, one design goal was that you're able to like prove that, like to an application, that you downloaded all the transactions, right? Nothing is missing from your application. And also that you only need to care to execute. I mean, you only download those that you care about. Like you only download those transactions, the data that you care about. So you also only have to execute the transactions of your application and nothing else. Again, that's very different from, like, for instance, Ethereum's World Computer model, where all the state transitions are executed. It's also different from a CosmWasm zone, where all the CosmWasm smart contracts are executed. So how did we achieve this? There's like mainly 3 ingredients we used to achieve this. First of all, we erasure code the block data. Erasure coding is a technique that most of you are familiar with. When you scan a QR code, there's erasure coding implied. So like if something's missing in the QR code, you still get to the website. If a CD is scratched, you can still listen to the music. That's erasure coding happening right there. The other way is the other ingredient is how we commit to the data. And we commit to the data with a so-called namespace Merkle tree, which is very similar to like how Tendermint currently commits to the data. I'll explain that later. But like the third ingredient is data availability sampling. That basically, like all these 3 things basically make a vanilla Cosmos chain to Celestia. So let's look a little bit into the erasure coding, not too much into detail, but so how it roughly works is you take the original block data, right, like all the transactions in the block, and you arrange them in a square, chunking the data into like equally sized chunks. And then you extend the data using that erasure coding 3 times actually. And what you Merkleize is not just the original data like in Tendermint usually, but what you Merkleize is like the whole extended data, the whole square, and you do it once with every row and with every column. So we had to swap out the data root in the Tendermint header. So let's briefly look into how we commit to that data, right? Like I said, the rows and columns are Merkleized using a namespace Merkle tree. So the chunks are also prefixed with a namespace, and the namespace Merkle tree takes the data sorted by namespace, and it also, I mean, as you can see here, it also basically separates the data per namespace, right? So if you want to prove, for instance, the completeness of the data, you can download a namespace and you can prove to the left or to the right that there's other namespaces involved. So you have proven completeness, assuming that the data was sorted, which is also guaranteed via consensus. So speaking about data availability sampling, the third ingredient, that's the main, the goal of Celestia is to guarantee data availability, and this is done by this erasure coding that I mentioned. Here you can see a little bit in more detail the chunks. So how this works in practice is via the erasure coding, you only need to download a small portion of the block and have very high probabilistic guarantee that all the block data was actually available. So it's very hard for block producers to hide any data. So there's some nuance here, but like roughly, if you download like only less than 1% of the data, you're almost 100% guaranteed that like all the block was published to the network. That's what we call data availability sampling, because light clients or nodes in Celestia sample randomly the block data to assure that it was being published. So from a very high-level architecture perspective, we took Tendermint, we took a Cosmos SDK app, we built a state machine using that, right? You could imagine Celestia being a very simple proof-of-stake chain, the simplest you can imagine. We even removed some of the base app modules, we simplified a few things, but we employed mostly the changes that I mentioned, which is validators commit to the erasure-coded block and Merkleize it using the namespace Merkle tree. So that happens in Celestia app, which is like a vanilla proof-of-stake app where these changes were employed. And the data availability sampling is done on a separate peer-to-peer network using libp2p and Bitswap mainly. So that's completely written from scratch. Like that part is very familiar to every very similar to every Cosmos chain, just much simpler. And that part is completely new and never has been done before. So we added one transaction type to base app essentially, which is pay for blobs. you can imagine you submit a transaction, which is an arbitrary blob, and you pay per byte for that. And then Celestia goes, does the erasure coding, and guarantees that this has been published, and everyone can verify themselves, like with a very small client, that this is actually the case by employing that, that sampling that I mentioned before. Okay, so to the more interesting part, to those who are already familiar with Celestia, some future directions and open problems. As I said, this is not a full-fledged roadmap, but a few directions that might be like prioritized moving forward. So first of all, how is it guaranteed that the erasure coding and the merkleization is done correctly, right? Like, as you remember, nodes only download the data that they care about. How do you guarantee that the erasure coding has been done correctly? So what we currently do, like what we're going to launch with, is the light clients can rely on something that's called bad encoding fraud proof. Everyone who downloads like a whole row or column can generate these bad encoding fraud proofs by like looking at the rows and columns, matching those to the merkleized, like to the Merkle tree of that row or column, and then send around the proof that they do not actually match to what like consensus agreed on, or that the data actually that the data is actually different, or like there's no integrity in the block. This is important because rollups, the only thing we guarantee, as I said, is that rollups can post the data and they can download the data to recompute their state, right? And this bad encoding fraud proofs guarantees that by ensuring that not like the validator set didn't just commit to garbage or something. The bad encoding fraud proofs have the downside that light clients need to wait for them, right, for the block to be final. One way to get rid of that is using so-called KZG commitments. That's, for instance, what Polygon Veil is doing, and Ethereum was also eyeballing with. And I think we can actually do better than that by instead now we continue as before, essentially, but we compute like a zero knowledge proof that the erasure coding and the construction of the block and the commitment has been done correctly. That has like many benefits because the computation before is still very fast and easy, and you can send around a small proof immediately after the prover is done. You can send around a small proof, and you have immediate finality and do not need to wait for a bad encoding fraud proof. Another thing that we will most likely need to prioritize, or the community will ask for, I'm sure, is having a two-way bridge directly from and to Celestia to get the base layer tokens in and out to rollups and back. Why this is relevant is then with that, if you had that bridge, you could deploy a rollup and use the base layer token for gas consumption, right? You don't need your own token if you don't want to, and you have to use the base layer token to pay for the blobs anyways, so it just makes sense. It will feel more natural if there was a two-way bridge to get the tokens in and out. The problem with that is that we want to keep the base layer as minimalistic as possible, right? Like I mentioned, applications just post their data, there's no execution environment, and there's no general purpose execution environment such that you could like host a bridge there for all the different kind of execution environments that deploy their applications on top of Celestia, and that could be very different. So for each of those, if you need a bridge, you would need to have an execution environment running on Celestia. The question is, can we do without that? And thanks to an idea that Mustafa came up with, and thanks to ZK Snarks, it is actually possible. Like the high-level idea, without going into detail, because any of this could be a a 20, 30 minutes talk of their own. The high-level idea is, if you look at how a ZK snark verifier operates, it's basically very similar to the plain old cryptographic signature verification. So what if we took the public key of such a verifier and we used that as a specific address on Celestia, and then the user flow would roughly look as follows. So to get tier out, or like the base layer token, let's call it tier. If you want to get that out of Celestia, you send a deposit transaction to that public key of the ZK snark verifier, right? Like, let's call it verification key address. Once that's done, you credit the user with tier on the rollup. And yeah, that's very easy, no magic. It's basically like an escrow. It's just that the public key that you send the tokens to are tied to a ZK verifier. So the way back is a little bit more nuanced. Here, on the rollup, the user, very similar, sends a withdrawal transaction on tier. It gets verified on the state machine. The transaction gets confirmed, and additionally, you generate a ZK proof that this transaction actually happened, right? And then the magic is you use that ZK proof as like a kind of signature on Celestia, and then there's the verifier runs on Celestia for like this ZK proof, and then on Celestia, without having like a general purpose execution environment, you just have a verifier, right? Like an opcode. You withdraw the tier back to the user. There's a lot of nuance here. There's a lot of design decisions to be made. That's the high-level idea. It's very easy and very appealing. If you're into working on ZK stuff, please reach out or participate on our research forum that I will bring up a little bit like at the end of the slides. Another hot topic that we need to tackle is MEV. There's a lot of research going on. In the modular paradigm, there are a few more nuances because you have these like heterogeneous app layer on top. So there's MEV in these rollups. There's MEV in the base layer, and then how do you reason about these state-of-the-art research in the context of that? Skip is looking into that, and like other projects as well. I think that's a very very interesting research field if you're into MEV. I would recommend to look into the early Celestia ecosystem and how to tackle MEV and how to improve censorship resistance mainly, because the rollups inherit the censorship resistance of the base layer. Because, yeah. Okay, one more thing before I wrap it up. The vision that we have is we want 1 gigabyte blocks, 1 million rollups ideally, or more, and 1 billion light nodes, right? You need a lot of light nodes to securely scale the block size. And to achieve that, there's a lot of like implementation that needs to happen, which is like optimization work, mainly on the peer-to-peer layer. So we currently work, like Callum, my colleague, has an optimized mempool, which is called content addressable mempool. But there's still, like, to get to the goal of like at least a gigabyte blocks, there's still a lot to be optimized in the mempool, because it's not the 10-element mempool is not meant for these like block sizes. Similar on the Celestia node side, there's a lot of work to be done to improve dashing, like on the peer-to-peer layer and on the storage layer. For the 1 billion light nodes, an interesting target is the browser, obviously, because everyone runs a browser. People run wallets in their browser. People use Infura and like other centralized service providers to interact with chains. But what they actually could do is they could all run a light node that is data availability sampling, have much higher security guarantees, and like basically contribute to the security of the network. So if you want to work in browser data availability sampling light nodes, please reach out. There's roughly 2 ideas how to do this. One is to have a Rust client which compiles to WASM, and then you have, you deploy that in the browser. The other idea is to use the Go code and have a WASM compile target. Go improved recently a lot on WASM support, so that's a very appealing approach here. Okay, I'm gonna skip this slide and go directly to the links, and I move aside. If you want to participate on any of the ZK stuff, particularly or any of the researchy topic, I would recommend you to go to our research forum and post your ideas there. There's a QR code. If you want to work on any of the implementation-specific stuff, if you're into peer-to-peer systems, networking, storage, databases, our GitHub repositories are the right address. Please reach out. Thank you very much.
All right, thank you, Ismail. Next up, we have one of my favorite projects of Cosmos, Federico, who is the co-founder of FMOS. I've always had a pleasure working with the FMOS team. So let's welcome him to talk about the innovation, EVM extensions, dynamic IBC, and the new tokenomics.
No, it was change it, but. Actually, the title is slightly different than the one we just introduced. Hi, everyone. I'm Federico. I'm the founder of Evmos. And today I'm going to present you Evmos 2.0 on the decentralized applications of the future. So my journey in Cosmos has been very long. I've been interacting with every one of you on the different projects that we can see today. I started my career as an intern building the first user interface for the ones that have been here since 2018. The project was called Voyager. I built a lot of components of the stack going from the Cosmos SDK. I participated in some improvements in Tendermint Core. I was core team of the Cosmos Hub and Gaia. And then I transitioned to IBC. In the past 2 years, I've been working on the infrastructure that is going to power the interoperable smart contracts of the next century. So we built a great piece of infrastructure and technology. Today, the common sentiment is that Evmos has a really great technology, but we need to make it resilient. We need to make it elastic and malleable to the different conditions of the network. And for that, today we're introducing Evmos 2.0. Evmos 2.0, and I haven't shared my vision of the Interchain with you guys so far, so I'm really excited to present this today. My vision for the Interchain is, and particularly for Evmos, is to build a financial infrastructure for the next century. The next century applications that are going to be powering every single user experience. And today, we're building the infrastructure layer that is going to power all these decentralized applications. So our goal at Evmos is to be able to deploy applications only once and use everywhere, completely forgetting the limitations of deploying multiple instances, and instead focusing on interoperability and composability use cases that are going to be creating new functionality for these smart contracts and decentralized applications. So we looked into this problem in terms of filters for adoption. So every single user, when they come to our ecosystem, they face different filters that they need to overcome in order to have a successful transaction. And we've categorized these into 4 main filters for this user adoption. The first one being onboarding. When you transfer a transaction via IBC and suddenly you don't have the native token, you can't really move from that unless you transfer the native tokens to be able to pay for the transaction fees. That's the main limitation right now that users are facing, particularly on Evmos. How do we engage with them and fix the onboarding user experience so that they can move to the next phase, which is like, okay, I have an intent of going to Evmos in the first place. Now we can start using and having all the utility that Evmos provides. Then we have liquidity and discoverability. Today I'm going to be focusing on the first three ones. So the main one is onboarding. And we're building unparalleled onboarding through our application by having a copilot that is going to be guiding the user in their onboarding journey so that within 5 minutes, they're able to successfully onboard from every ecosystem into Evmos and the Interchain. So the onboarding user experience is key for the user to start interacting with the decentralized applications or interacting with IVC or interacting with Cosmos altogether. If we don't fix onboarding, there's nothing else left because it's the first barrier and filter for the adoption of the users. So onboarding through Evmos from fiat or onboarding through different cryptocurrencies and different ecosystems is the main challenge that we need to face as an entire ecosystem, and particularly on Evmos to be able to build this like next generation infrastructure. Then we've been working on utility, the utility of what is going to be powering all the decentralized applications in the next century, and the amazing applications that are going to be using all the interoperability components from IVC and compose with one another. So now I'm going to go deep dive in the components that we're building that are going to be creating this unmatched utility in the entire ecosystem. So we want to enable the next decentralized applications of the future, and this is exactly the pitch deck that Ethan Bachman was saying to their investors when they were raising for Cosmos. We don't know what types of applications are going to be created with this interoperability protocol or with this ecosystem altogether called Cosmos, but we know that there's going to be a huge demand for these interchain applications, and they're going to be able to talk to one another and compose with one another and build new use cases that we don't know today how they were. So this was back in 2015. So Evmos, in the same way, is going to enable the same application, the same functionality for decentralized application. So the first one, the integration. EVM extensions is our newest functionality that is going to be powering seamless integration between Cosmos core functionality and EVM smart contracts. So how EVM extensions work is that through a predefined address, a precompiled address, these smart contract applications can interact today with staking, accessing new functionalities for DeFi. They can interact via IVC and immediately access liquidity that is available across the ecosystem. We're also going to be introducing governance EVM extensions so that DAOs can directly vote on the protocol level governance components. So enabling that access for smart contracts is going to be powering new use cases. The second one is composability, this unparalleled utility that's going to be powering new use cases for the entire ecosystem is going to be given via these outposts, Cosmos outposts, Ethereum outposts, etc. So this is the Osmosis DEX outpost that we're building. And notice a slight difference here in the corner. You're using an Evmos address for the same user interface, so you can directly onboard to Osmosis and every single interchain application via EVM wallets. So right now, if we think about it, the major limitation for this entire ecosystem and the maximum number of users that we can access is limited by how many users are interacting with Kepler today. If we're opening those borders, they're going to be able to access all the interchain applications through MetaMask and any other EVM-compatible wallet, including Wallet Connect. So enabling this functionality is going to access a whole lot more of utility for everyone. And how it works, we built an innovative design that basically allows any smart contracts to interact with this EVM extension through this outpost and provide liquidity or swap tokens directly with a different set of instructions, send over the token, perform the action on osmosis, send it back to Evmos, and the smart contracts or the user will have the newly available token. Instead of sending 3 transactions for that, it's only a single transaction using a completely different wallet and only one single account. So you can abstract all the user experience into one single transaction and enable smart contracts to access liquidity that is not available on the Evmos chain right now. And this will happen with all the other smart contract applications. So this is now live on mainnet. We've been building a few use cases that are interacting through our EVM extensions, but soon we're going to be abstracting it, making it easier for smart contracts today to access this outpost functionality and access all the liquidity and functionality that is available in the entire Interchain ecosystem. The next innovation is dynamic IVC. So a major limitation today, when we have the Interchain stack for IVC that I was able to participate as a core engineer, so there's different layers for the core protocol that involve clients, connections, and channels that are part of the core primitives of IVC. But as a smart contract developer, you don't want to know how to build a channel, how to be able to call the IVC callbacks. All those components are really complicated and very technical for a developer that is coming from a completely different ecosystem. So how are we able to abstract all those primitives away from the development layer, in this case a smart contract application, and be able only to focus on what's the data that is being sent over to the destination chain? And so that's when dynamic IVC comes, is that it's a wrapper around the core component of IVC, the channels, connections, and clients, so that you're able to effectively onboard the entire Ethereum ecosystem into the entire Interchain. So today, we're saying welcome Ethereum developers to the Interchain by abstracting all the IVC functionality and only having them to define what's the data that they're going to be sending. And this is massive for the Interchain ecosystem, because now they can build a whole new set of IVC applications for the Interchain that is going to be increasing the development cycles, is going to bring way more innovation, and they're going to be interfacing not only with smart contracts, but also with layer 1's and application-specific blockchain in the ecosystem. So this is onboarding an entire, the largest development mindshare in the entire blockchain ecosystem to the Cosmos by abstracting the IVC components. And the next one is, and the final one in terms of utility that is going to be powering the decentralized applications of the future, is how to experiment, how to build new use cases besides the interoperability ones that I just mentioned. So EIPs is a Ethereum Improvement Proposal standards that live on Ethereum. So today there's like a massive need for onboarding new primitives into new EIPs into new layer 2s and new EVM chains. There are more than 150 EVM chains. Not all of them are integrating these EIPs that developers desperately want but can access because of the slow development cycles of Go Ethereum. So there needs to be a space for innovation. There needs to be a space for them to be able to develop new account abstraction models, new elliptic curves, a new functionality that they're required to build the next generation applications, the decentralized applications of the future. So today we're introducing Evmos as the Ethereum Canary Chain. Evmos 2.0 will become the Ethereum Canary Chain by implementing most of the EIPs that developers truly want and being able to hook them up with interchain IVC composability and interoperability. Ethereum will be welcomed by the entire interchain ecosystem through Evmos. The next major limitation that I mentioned was, besides onboarding and utility, is the fact that today liquidity is completely fractionalized and spread across the entire ecosystem. So even though you might have one single token, that token today is available on Osmosis, on Stride. It's available on a liquidity pool on Evmos. So the problem right now is that we're the total value locked metric, the TVL, only represents the amount of tokens that are currently available in one single chain, when in reality they're completely spread out. So today we're introducing the total reachable liquidity. How much liquidity can you access from a single chain or from a single smart contract in the entire ecosystem? And this, we believe, is a new metric that is going to be powering the entire liquidity ecosystem and going to make the entire Osmosis ecosystem, Stride, etc. So how can we enable these decentralized applications to access more liquidity for their needs? And as part of this, we're introducing Omni liquidity. All the liquidity that is available in the ecosystem now suddenly available via Evmos 2.0 through the Outpost, EVM extensions, and dynamic IVC. That's the new liquidity standard that we want for the next generation applications of the future. Omni liquidity is a new narrative, is the next narrative for how to access all the liquidity that is available. TVL is gone. TVL is 2020. Let's look forward in terms of how liquidity is going to be accessed by all these decentralized applications. And as part of this, Evmos 2.0, and why Evmos 2.0 is different, is our leadership team. Our leadership team is going to be able to take on these responsibilities and take Evmos and decentralized applications and these financial applications that we're building to the next level. Please welcome the team, and it's time to build. It's time to build products. We'll build the entire infrastructure, and now it's time to build products that are interacting with this infrastructure layer that we built for so long. So thank you very much, and looking forward to be working with you.
Thank you, Fede. All right, we have one last presentation before lunch break. We have Thomas De Keyser, a developer advocate from Polymer Labs. He's going to speak about IBC, from Cosmos to Ethereum and back, a developer's journey. I'm guessing it's his own journey. So welcome, Thomas, to the stage.
Some modification idea of your presentation. Ah, yes.
Test. All right. Good afternoon, everyone. I am going to present to you today an exciting topic, how we bring IBC from Cosmos to Ethereum. So who am I? My name is Thomas. I'm a developer advocate at Polymer Labs. And we are expanding IBC beyond the Cosmos, basically anywhere. Before I was a developer advocate at Polymer Labs, I was a developer relations at Interchain, at the IBC team. And it's always been a dream of mine to make sure that developing with IBC is not just something for the Cosmos and Interchain gigabrains, but that it's very accessible to every developer. And so, one question to start out with, who has ever built or tested IBC applications? That can be Go modules, that can be smart contracts that are IBC enabled. I think the people that have probably know that essentially it's quite tricky to get set up. So IBC means that you have a cross-chain application, so you have multiple chains, you need a relayer in between. If you're just an application developer, you probably don't really care about all the DevOps stuff that goes into the background. And that's why we at Polymer Labs have made the assessment that to make IBC successfully come to Ethereum, it's not only important to provide the technical aspects to do this, but also to provide great tooling. And that is why part of this presentation will be about the IBC SDK. So what is required to bring IBC to Ethereum? over the past couple of months, we've already been bringing out a number of blog posts about these different topics. And you can see multi-hop IBC, virtual IBC, ZK Mint, and then ultimately the IBC SDK, which is the tooling we're going to discuss. It's a lot of things, a lot of puzzle pieces. But we developers, we like composability, we like modularity. And today I'm going to explain how all of these puzzle pieces together make sure that we bring IBC from Cosmos to Ethereum. So first, let's briefly review the interoperability model. As you can see, we can take inspiration from the original OSI model. So for the interoperability model as well, we have a clean separation of layers that are modular. So on top, we have the application layer. This is where application developers interact with IBC. Then we have the transport layer in between, and ultimately the state layer. The state layer is how we verify that some state has been committed on the remote chain. And the transport layer, which is often overlooked, is actually very important because it allows us to standardize transport semantics. In IBC, these are the clients, the connections, the channels across ecosystems, and make it really easy for application developers to develop between different ecosystems and different chains. So this is an overview of IBC as you probably know it if you know IBC. So we essentially have two Cosmos chains you can think of. We have the IBC Go module, which is the transport implementation. Then we have our light clients, which in Cosmos represents Tendermint light clients. And we built connections, we built channels, and then we can send over packets with the help of the relayer, which you see down below. Now, how is it that we haven't seen an IBC implementation come to Ethereum yet? That's because there are some issues that arise when we want to implement IBC outside of Cosmos. And this kind of shows you the worst case scenario, if you will, where if we have an IBC chain on the right and an other chain that we want to connect on the left that is not from Cosmos, the worst case scenario, it does not have an IBC transport implementation, so that's something you would have to develop. It doesn't have the light clients on both sides, actually. And also, there is no guaranteed relayer support. So all of these things we would have to develop from scratch in a regular situation. And so specifically for Ethereum, there's also the issue that verifying Tendermint consensus, which is what Cosmos SDK chains use, in the EVM is cost prohibitive. So we need to find solutions for that. And also, Ethereum does not have single slot finality, which is also a requirement. If you have different forks, an Ethereum Lite client is not immediately IBC compatible. And so when we think about the puzzle pieces that I showed you, the first one is multi-hop IBC. So this actually works also between multiple Cosmos chains. It's not limited to the problem of connecting to Ethereum. And so what happens is that with a chain in the middle, you can still create a multi-hop channel that acts and functions much like you would have a regular IBC channel, at least from the applications developer's point of view. But it leverages pre-existing connections between chain A and Polymer and chain B, with Polymer acting as the middle hop, as sort of a router. And that is one piece of the puzzle. Another piece of the puzzle is virtual IBC. And if we think back to the interoperability model, we'll remember that we had these different separation of layers, app layer, transport layer, state layer. And what we say is that you can actually have modular interoperability. So previously there was a talk from Celestia, and they kind of coined the term modular blockchains. So modular blockchains enable to have the different functions that a logical blockchain needs to have, but they said they don't have to actually be on the same chain. We do something similar for interoperability. We say, yes, you need the application layer, yes, you need the transport layer, yes, you need the state layer, but these can be on different chains, still forming logical interoperability. And so what we did for Ethereum was we consider Ethereum as a virtual IBC chain. And in fact, we bring the transport layer to Polymer. So all the computation related to interoperability will actually be executed on Polymer. And then the remaining puzzle piece was ZK Mint. So remember that verifying Tendermint consensus inside the EVM was cost prohibitive. So how do we go about solving that? So at Polymer we have, At Polymer we have ZK Mint, which is a novel consensus engine, which essentially makes it possible to have at each height multiple headers in a different format that are optimized for each execution environment, in this case, the EVM. And so this is really important to understand that this is not just a solution for Ethereum, it's actually a generalized solution that makes it very adaptive and flexible to every chain environment ecosystem that we will want to connect into the future. And so when we have Polymer with ZK Mint, the only thing that we need to do is we need to have an off-chain ZK prover making a ZK proof that the computation was done on Polymer, and then we can verify this on the Ethereum chain, which is orders of magnitudes cheaper to execute. And so virtual IBC actually has another benefit, and this comes back to the problem that Ethereum does not have native single-slot finality. And so when we have an ETH client, this is what we call the native light client for the chain. It can have, a view of multiple forks, multiple views. And so to make it IBC compatible, this does not work. So we have introduced this concept of a virtual light client, which is essentially a wrapper around the native light client that can allow you to have different security parameters. This is what we call the fork choice rule. So for different virtual light clients, you can allow for a different number of block confirmations to have gone through to use the client for IBC applications. And so depending on the security requirements that you have, you might choose a different solution. And so when we put all of this together, we have succeeded. We have brought IBC end-to-end from Cosmos to Ethereum. And this looks a little bit complicated, right? And so for developers who want to develop cross-chain applications, we have the IBC SDK, which remember was tooling that basically abstracts away all of the DevOps. So you can imagine having put Polymer in the middle, different relayers going on. You have all these chains to set up. IBC SDK allows to do that all for you, and the application developer can just focus on deploying their smart contracts or their applications. So again, why is this IBC SDK important? Well, for us as Polymer, it's also important because it provides developers the first opportunity to really interact in a tangible way with what I've been describing, the Polymer protocol. And like I said, it's also very important for the UX for developers. Because as I mentioned before, just bringing IBC to Ethereum isn't enough. It also needs to be easy and accessible for developers. And especially, let me just go away. On the left, we have these two diagrams. The one on top is actually a homogeneous environment. And you can think of that as Cosmos. We have all Cosmos SDK chains, and we connect them over IBC. This is still a lot easier than if we go to a heterogeneous environment, which was also always the intention of IBC. If we have a heterogeneous environment, we have all these different types of chains. So you can imagine if you had to spin up all of these chains yourself, know how to interact with them, spin up the different relayers. This is a lot of work, and this is what IBC SDK makes really easy for you. And this is why I'm happy to announce that actually tonight, or last night, we open sourced IBC SDK, and it is available for you to try it out. So what does my developer journey actually look like? Okay, it is open source, I can try it out. What does it look like? So there's a couple of possibilities of what you can do as a developer. So say you're an EVM developer and you want to make an IBC-enabled EVM smart contract. That could just be that you have an application on a CosmWasm chain that you want to interact with. You can just focus on your EVM development with the development environment that you're familiar with. You can easily slot it into the workflow with IBC SDK, and we have a tutorial on that. Or you could be a CosmWasm developer who is interested in developing an application that interacts with an application on Ethereum. That is also possible. And lastly, we have these God-tier developers who essentially will have native cross-chain applications that leverage VMs on different chains in different ecosystems. And hopefully we'll see a lot more of this. So I've prepared a tutorial example. Actually, now that IBC SDK has been open sourced, you can just go to the documentation for it. This will be an example. So very simply, what is happening, we have a CosmWasm chain on one hand, we have Ethereum on the other hand. What I prepared was an example of a lending borrowing contract. So we have an amount of tokens, in this case 3 tokens. We have supplied some collateral as a community, and now we want to vote on what asset to borrow. But we don't want to vote on Ethereum, that's very expensive. So what you could do is actually deploy the polling contract, what you're going to borrow, on CosmWasm. And you can vote on that, make a decision, and when the vote ends and we have a winner, you just send over the IBC packet to Ethereum, and that will execute the loan. And importantly, you also have an ACK, so if you wanted to do something upon the receipt of the ACK, that is also possible. Right? And so my tutorial example is, of course, a great way to get started. But ultimately, if we bring IBC end-to-end from Cosmos to Ethereum, the question is, what are you going to build? And I think I can speak for all of us that we're very excited about this future and very excited to see what great applications the Cosmos developers are going to build to interact with Ethereum. And so I started the presentation with saying that for IBC to thrive, we need a lot of puzzle pieces to be pieced together. And so right now, bringing IBC to Ethereum, how is the puzzle looking? I would say it's starting to look pretty good. But all of the other teams also working on IBC, and a lot of them have presented at this conference, it's starting to look pretty good. How can we improve it, though? One way is to contribute to the IBC SDK to make it even better. Because right now, we started with support for Ethereum and Cosmos chains, but it can be a lot more. It can be any generalized setup. And there's some other things that we still need. We can turn it into a library. We can build dashboards for it to really make it as easy as possible for contract developers. But there's some bigger pieces as well. We think that there's some really huge things that can still change in IBC to bring it to that next level. And if you're curious to find out, be sure to catch Bo's talk in the afternoon, because he is going to talk about a new concept he called enshrined interoperability. That's my presentation. Thank you for listening, and have a great afternoon.
All right, thank you, Thomas. Just very quickly before I let you all go for lunch, the studio, which I was talking about, that's going to host 2 workshops, it is accessible through the entrance. You need to go back out to the registration booth. There's a secret stairway to the right. Come up, join me at 2 p.m. Looking forward to as many projects as possible. And I've had such a great pleasure accompanying you all this morning as your MC. My name is Candice, I'm from NIM. And I'll let you all go for lunch now, and I will hand over the MC role to Sam to take you all through the end of the summit. Thank you, everyone.
Welcome back. We're nearing the end. We're getting close, but we still have lots of great content for you this afternoon. Here on the main stage, there's going to be some very spicy debates and talks, and make sure to be here for the final panel about the future of Cosmos. But first, we're going to have Jake give a talk. He looks excited. And yeah, we'll finish it up around 5:30, 6 o'clock. There's going to be a networking drinks cocktail here at the venue afterwards, so make sure to stick around. That's sponsored by Sommelier. Thanks, Sommelier, for sponsoring the networking drinks and cocktail. And they're setting up the ice cream. So if anybody wants ice cream, make your way to the courtyard. But not right now, though, because you got to sit for Jake's talk first. Cool. Well, I'll bring Sam up, and we can get started this afternoon. Thanks.
Salut les cosmonautes, how are you all doing today? Hope everyone's enjoyed day 2 of Nebular so far. Hope everyone enjoyed their lunch. We have an exciting string of panels and of enlightening talks, as Seb mentioned. And kicking off this afternoon, we have Jake Hartnell, co-founder of Juno, talking to us about the future of Interchain. Let's give it up for Jake.
Sick. How's everybody doing? That's great. Very, very enthusiastic. Everyone's sleepy after food. All right, well, assume this is the clicker. Today, I'm going to be talking about the Interchain future. You ready? Let's go. Oh, but first, there's a little thing I want to show some people in case you weren't at OsmoCon. Hashtag mesh is real. I was going to do a demo, but the Wi-Fi here is a little bit, not that great. So we're going to show some screenshots of the demo, and if you want to see the demo in person, we can try it later. Just ping me. But yeah, mesh security. The idea, cross-stake to secure the internet of blockchains and earn some rewards. Cool. So this is the front landing page. Imagine you click Connect Wallet. Now you're ready to cross-stake. So this is the mesh dashboard. You can see in this screenshot here, we have 2 tokens in the Interchain. We have Osmosis and Juno. And you can see your balance and your portfolio. There's a claim rewards button. If you've actually ever used staking before, all this is going to look really super familiar. We think of mesh as this really complicated thing, but at the end of the day, it's kind of just another staking UI. So yeah, you can claim your rewards. Click claim all rewards. Awesome. You get all that money from the mesh. To stake, you would click, stake or unstake, and then back. So then you choose, okay, how much do I want to cross stake, right? How much do I want to stake? And then you would select which chains you want to cross stake to. Right now in this mesh, we only have one. So we're going to cross stake our Osmo to secure Juno network and get some extra Juno rewards. And then it's just like staking, right? For each chain that you're cross staking to, you're just picking a validator. So on the Osmosis chain, I'm picking this validator. This is running in it's not using the official chains yet. It's running in a test environment. Kudos to Anmol from Starship for helping making this awesome, realistic testing environment that uses actual chain binaries and Hermes and stuff. But yeah, you pick your validator, and then you pick a validator on Juno, and then you hit that next button, and you get a nice little summary page. So here we're going to cross-stake 10,000 Osmo. These are the different validators on each of the different chains and their different commissions. And then we just click cross-stake and you sign a transaction, and the IBC magic happens. It sends an IBC message to another chain, and now you're securing the mesh and you're earning additional rewards. It's really not rocket science. And this is just the first MVP version of the UI that we worked tirelessly on for 2 weeks, right? So imagine how much better the UX can get in another month. In terms of timeframes for mesh, I know that's what everyone wants to know. When mesh? When mesh? Soon. I'm hoping a couple of months. But let's get to the real thing I want to talk about today, which is we're at the beginning of a new paradigm. It's the interchain paradigm. And as you can see here, we've got the interchain as it exists today in 2023. Over 60 blockchains connected, billions of dollars transacted between them. But we're not going to stop there. No, we're not going to stop there at all. This is not good enough, because IBC will connect all. This is, the interchain in maybe 2024, I hope. You see Ethereum, right? Interchain's not real until Ethereum joins the party. You see OP, we see Near, we see Polkadot. Polkadot is already connected to the IBC. The first ever transaction between Kusama and Polkadot happened with IBC. We see Avalanche. Avalanche is joining the party. Awesome. But yeah, this is the goal. And we cannot be satisfied until this goal is reached. In fact, I think this is a good time to announce that in helping to achieve this mission of connecting all these sovereign state machines with IBC, I'm actually starting a fund with Sam. Sam was a co-founder of Consensus. So, it's great to get some Ethereum OGs that are excited about the interchain. How cool is that? OGs from Ethereum are now thinking, oh, this might be the next hot narrative. We have Locke. Locke is a partner at Tuesday Capital and a bunch of other funds and has a ton of experience doing all the things I have no clue how to do, set up legal entities and accounting. And then there's me. I'm just a degenerate and know a lot of devs and, But our thesis is really pretty simple, right? And it's this. I'm going to give you the TLDR version. The interchain will bring mass adoption of crypto. Here's the why, the TLDR version why. If you're interested in being an LP in our fund, we'll give you the slide deck and you can get the long version of this. But first of all, you all probably know this if you're here. IBC enables massive horizontal scalability. The idea that we don't have to run everything on one world computer, that we can actually just have all these networked computers like the internet scales to billions of transactions per second and beyond, right? I think here's a killer point though. Enterprise and permissioned blockchains are actually a huge use case, and they only make sense if they are interoperable with others. Previously, there was a big trend in 2017, if you were around then, around enterprise blockchains. But they never worked because who wants a silo? What good is a blockchain if it's a silo? IBC changes this game. And if we're really going to see a massive influx of capital, if we're going to see companies that are worth multiple trillions of dollars, there are companies out there that are worth more than the entire crypto market. Do you think that they're going to run on anything other than their own sovereign permissioned chain? Do you think governments of large companies are going to run on anything other than their own sovereign chain? So the interchain actually is very aligned with this idea of bringing in people that would normally never join crypto because they can join it on their terms. You can have a permissioned blockchain, you can have an enterprise blockchain, and you can connect with every other one that exists. This is the Internet of State Machines. another big aspect is, network effects. Network effects and composability are going to drive growth, right? I'm going to talk more about this later. But in IBC is everything you need to succeed. All the liquidity is there. The data is there. You can verify the data with cryptography. And the users and the people are there, right? This is going to be compounding the effects of launching a new chain. Previously, when you launched a new L1, you had to build up a whole ecosystem from scratch. You had to build up all your users from scratch. And now in the interconnected world, anyone who has an account on some IBC connected chain, right? They can just go over and check it out. That's really key for the next thing. And then I think, in the bear market, we get all really sad and depressed, and we're like, blockchain doesn't work. But honestly, blockchain is actually more relevant than ever. And sure, there's challenges. We definitely need really good privacy solutions, for example. But if you look at everything that's happening with AI, ideas that we had in 2015, like content registries, like people publishing content and being able to prove that it was from a certain source, with signatures, with cryptographic signatures that cannot be impersonated by AI. Those things are more relevant than ever. And if you actually exist in the Web 2 world at a big corporation and you use the tools that they use, everyone is blockchain is bad UX, Oracle is bad UX. If you have just these PHP websites are just bad UX. Sending PDFs around and Word documents around is bad UX. And the future is being born right now, so I'm glad you're all here. But, I think we haven't fully absorbed this new era, right? It's still very nascent. We're still in the old multi-chain world. And the interchain requires us to start thinking a little bit differently. And so to get you to think differently, and to also liven things up post-lunch, it's time for Interchain hot takes. Who's ready? Okay. So this is the first one. When you are talking with others outside this ecosystem, whether they're from the Ethereum Foundation or Polkadot or Near or some L2, don't use Cosmos. Use Interchain. I hate to say it, but this is a fundamental branding thing, right? If we are going to make IBC connect all kind of vision. If you have bags in another chain and you hear about Cosmos, that's just all associated with somebody else's bags. That's all the Cosmos hub, right? I don't want to be a part of that. That's just like a meme coin, or it's like another ETH killer. It's a shit coin from their perspectives. Interchain is a much more exciting idea. It's a much more powerful idea. And from my conversations, when I talk with people from Ethereum, for example, about the interchain, they pay attention. Because that is something that's really sexy, and it solves their problems. When you talk about the Cosmos, what are we talking about? Are we talking about Cosmos SDK? Are we talking about Cosmos Hub? Are we talking about this network of IBC-connected blockchains? And so my first hot take for you is if you're talking about that network of IBC-connected blockchains, don't use the word Cosmos. Use the word interchain. Second, and I think this is also probably an obvious one, but there's going to be many hubs. That's just natural. That's part of network topology. That's exactly how the internet is. If you're under the illusion that your one chain to rule them all is going to be like the hub for all things, and that there's just going to be one hub in your ecosystem, what year are you living in? That dream has long died. We are in the multi-chain world, and we're soon in the interchain world, and it's going to look like this. There's going to be multiple hubs. There's going to be multiple winners. And yes, some are going to be bigger than others. But yeah, give up on the false idol of one chain to rule them all, or one hub. It won't happen, and it shouldn't happen. That's a dystopian world in my view. All right, here's another one. I'm not going to take credit for this. Hillary from Evmos did this really awesome mental reframing. We oftentimes think of TVL, right? Total, or TLV, total value locked, right? And we judge all DeFi protocols by this. It's all about TVL, TVL, TVL. This metric, it's been hammered in our heads since 2020. But in the interchain era, maybe we should start thinking about things a little bit differently. And this is why it's so important to bring other ecosystems into the interchain, is because maybe it's all about total reachable liquidity. Because with IBC, we can build interchain protocols that are not like the ones that existed in the multi-chain era, where it doesn't really matter if it's on your blockchain specifically, as long as you can access it, as long as you can reach it. When we live in the era of like interchain DAO tooling and interchain accounts, where you can have accounts on all these different chains that you control, that you can utilize, maybe start thinking in terms of total reachable liquidity instead of TVL. Start thinking interchain. This is another one, I hate to bring it up, but I see people in Cosmos all the time, and they're always thinking about protectionism. They're in this protectionist mindset, whether it's like, oh, we could never accept another fee token besides our own native token that might help with like, you know, cross IBC UX. Or maybe they're like, we have to impose like fees or tariffs on taking things off chain because we don't want people to leave on our chain, like leave our chain to go to others. Or maybe, you know, you're a permissionless CosmWasm chain and you have a bunch of custom Cosmos SDK modules that you try to get people to use. And so the idea is that like, oh, no other chain will have these modules and then that code won't be reusable. I see that a lot recently. And I think that's very short-sighted. Free markets are ultimately going to win over mercantilism, and protectionist like ideas will sound good in the short term for the value to token holders, but they're not going to win out in the long term. Just wait. We've seen this before. We've seen this one before. Apps are better than app chains. Don't think of app chains. Think of apps. Deploy everywhere or someone else will. Every chain needs an NFT marketplace. Every chain needs a DEX. Every chain needs DAO tooling. Every chain needs your product. If you want to get the most users, if you want to get the most usage, if you want to capture the most value as your protocol, you have to be everywhere in the interchain era. And IBC gives you the tools to stitch interchain protocols together that we never had before, right? Outposts kind of offer the best of both worlds, right? So if you have an app chain, make it the hub. But deploy everywhere, or I'm not interested in your protocol. Here's another one. I really want to put this thing. You can profit from things that don't run in your block space. Again, you can profit from things that don't run in your block space. This kind of goes along with the protectionist idea, right? Where it's like, oh, everything has to run in our block space. Otherwise, like it's, you know, it's not good. No. As long as value is accruing to your DAO or your token, that's all that matters. This is something that we're very behind on Juno, which is why we're so excited about mesh security, right? If a project starts on Juno and then goes elsewhere, right, or launches its own app chain, we can continue a beneficial economic relationship with them without them having to run their app on our chain. It doesn't matter. These old ideas don't matter. Block space is more plentiful than ever. It's cheaper than ever. And if you're only thinking in terms of like transaction fees and block space, I think you're kind of like, again, living in the previous era. So wake up. This is a big important one for Cosmos. Vibes matter. This community has been super hyper negative lately. There's not like, there's hardly any women in the audience. There's, you know, there's just bad vibes lately. There's this idea in Cosmos, it seems, that there can only be one winner. Winner take all, right? Like, and there's not enough coordination, collaboration. It's not an exciting place to join. No one wants to join a place where there's tons of drama all the time, right? Like, so start being nice to each other, even if they're a quote-unquote competitor project. It's really not like that. We are judged as an ecosystem. And finally, advanced governance tooling is a requirement for mass adoption. As we move into this world of permissioned blockchains, as we move into a world of mass usage, guess what? Your boomer parents expect if something's wrong, they can like have some way of remediating things. You know, immutability is great value, but it can also be a terrible user experience if you've ever lost your keys before, and that happens. So there's balance to be achieved here, but I'm not going to ramble on too much because I've been rambling a lot. I'm running out of time, but you know. Oh, so speaking of DAOs, I gotta get to DAO updates, okay? So first of all, with the Juno DAO, we have this renewed focus on experimentation. People are like, oh, Neutron, what's the difference between Neutron and Juno? We have different alignments. I think Neutron's a great project, actually, really do. But we are much more on the experimental, pushing the boundaries side of things. We are first and foremost a community chain, and we are first and foremost an experimental chain. And sometimes the experiments might not go super great, but that's part of evolution, it's part of learning. So, we're pushing the boundaries. So just to read through our tech roadmap, mesh security is probably Juno's top priority. We are doubling down on mesh security. It is, I think, the future. We're probably going to be one of the first chains to connect to Polkadot because we're using the latest Cosmos SDK and the latest IBC Go versions. So we're going to guinea pig that for you all, and then you can use it on your chains. We have the Juno Constitution in the works. It's going to come out soon. There's some major governance reforms. Spoiler alert, Core 1 is just going to be completely dissolved, and there's going to be a new structure that's put in place. More on that later. I could spend a whole talk on that, but we're going to be trying out some really interesting and novel ideas. Ideas which, like sub-DAOs, which we helped pioneer, we hope these ideas make their way to other chains in the Interchain. CosmWasm modules is something I'm really excited about. It's something that we're going to pioneer. This is an idea from TWasm and Tgrade. You will be able to write SDK modules effectively with smart contracts in Rust. And you don't have to do an upgrade. You don't have to upgrade the modules every time the SDK changes. It's much more stable, and we think that it's going to really unlock a lot of new things. All new Juno features that are at the SDK level are going to be using CosmWasm modules because we think that it's really important to build out that ecosystem. And yes, I am a CosmWasm maximalist, and we have some huge performance improvements on the way. Real quick, Lead Society, it's live. If you don't know what Lead Society is, it is a club for Interchain devs. We are not an investment fund or whatever. It's just a society, but maybe it's beneficial to be part of the society because we have some funds around it that are looking to recruit talent and maybe looking to invest in projects that might come out of it. But if you're a new dev to this space or an experienced one, and you're looking for mentorship, the ability to meet other people, to learn peer-to-peer style, maybe get some cool bounties, come talk to me or go to 1337society.dev and you can join Lead Society. And lastly, DAO update. We're deploying DAO across the Interchain. So if you want DAO on your chain, come talk to me. This is it. We're living up to our values of these. We think the most valuable protocols are the Interchain protocols. If you keep DAO on one chain, it won't be able to create as much value as if DAO and DAOs are everywhere. Secondly, DAO now supports Interchain accounts. So in this little screenshot, you can now have a DAO on Juno that has an account on Osmosis, and you can use all the DAO tooling to do anything on Osmosis. And so I urge you to check it out. I might demo it in the corner in a bit if you're interested, but this is much more than just liquid staking on Stride. This is a real Interchain account experience. You can call smart contracts. You can instantiate smart contracts on other chains. You can do anything that you could do on that chain. So come talk to me afterwards, and I'll showcase it for you. Finally, we're seeking some grants for public goods work. And if you're an investor, here's a little bit of alpha. We might have a secret plan, and we are going to be finally raising investment for DAO. DAO has raised 0 money to date, though it was supported by the wonderful Juno community, which has incubated things like Polytone. We're helping with mesh security, with many people like Confio, Osmosis, DAO. We do good things. We're builders, and we're pushing the boundaries. And so finally, I kind of already talked about this, but just to close, our fates are tied together. We succeed as an ecosystem together. We succeed as an interchain together. Start getting out of the zero-sum mindset. Thank you.
Let's give it up for Jake, everyone. Thank you for opening up this afternoon. Right, next up, we have a very special talk from the CEO of Strangelove, Jack Zampolin, on packet-forward middleware and intents via IBC. Are we good to go? All good to go? Okay, everyone, let's give it for Jack.
Oh, thank you. Yeah, cool. All right. Oh, there we go. Okay. So, hello everyone. Thanks a lot for having me here today at Nebular. Seb, great to see you. I'm here to talk about intents in IBC. So, just a quick little bit about me. My name is Jack Zamplin. You might know me from some of these projects over here, where I've been a product manager. I've been working in Cosmos since 2018, and at Strangelove, we're dedicated to building IBC and supporting its growth. We're one of the primary teams building out the core IBC protocol, and we're doing a lot of work to expand IBC to new ecosystems like Polkadot, Avalanche, and a bunch of other ones. So you hear a lot of people talking about intents recently. What are intents? It's a little bit of an amorphous concept, but you can think about it where a user specifies an intent in a transaction on one chain, and that gets carried out across multiple different systems or different blockchains. This is really important for scaling because if we're going to live in an app chain world where each application lives on a different chain, how do you get the same level of composability that you get in Ethereum? In Ethereum, you can send one transaction, go borrow money on Maker, trade it on Uniswap, and then maybe enter a perp position on some perp protocol. And all of that happens with one single signature from your ledger. But if we're living in a world where all of these applications are on different chains, how do we offer that exact same user experience to end users where they only have to send one transaction to complete a complex set of financial primitives? Well, there's a few different ways to do it. But maybe think about how traditional web systems have scaled and look at this historical example of Google. As a user, you send one request to google.com, and google.com then farms out different pieces of those requests to a bunch of different back-end servers and returns it to you. So intents in IBC will work in a kind of a similar way where you're sending your transaction to one chain and there might be interactions on many different chains that end up happening under the hood to perform what the user wants. So right now, if you want to do this in IBC, and I think a lot of folks in this room are familiar with this, maybe you want to trade on Osmosis and go borrow over on Umi or do various things. There's many transactions that you need to sign in order to do that, and it's kind of painful right now. Honestly, I don't love it. My ledger is getting tired. So let's take this simple user flow here where we want to lend USDC on Umi with Atom that we currently have in an LP on Kujira. So this is the set of transactions that you need to make as a user. First, you need to remove the Atom from the Kujira LP. That's a single transaction. We need to initiate an IBC transfer over to the Cosmos Hub. There's a relayer involved there with another transaction that you don't have to do. You have to IBC that Atom to Osmosis, which is another user transaction. There's the relayer there. Then we, single transaction, trade Atom for USDC on Osmosis. We would IBC the resultant USDC to Noble to unwrap that denomination, and then IBC the USDC to Umi, where we would then enter the lending position and end up there. That's a nice 7 transactions to do something that should be a single transaction. So let's talk about IBC middleware. IBC middleware adds additional processing to IBC packets as they're sent and received. This allows you to kind of think of that ICS-20 packet as a bearer instrument where it's not just a single transfer, but that packet contains the value that the user has, and maybe you want to do other things with it besides just put it directly into the user's account. This relies on this simple JSON structure that's stuffed into the memo field of an IBC transfer that allows users to specify additional actions to be taken, additional processing to be done on the chain that they're sending the transfer to. So here's a little code and a couple of examples of things that are live today. You see the swap over here on the left. This is a swap and forward on Osmosis. We've also built a similar piece of middleware for Duality that will be live with that chain once that goes live. But here you specify the arguments for the swap over on the chain that you're originating the IBC transaction on, and the swap happens without the user having to send a second transaction. And if you know the swap API on Osmosis, this is just all of the exact same arguments, We're just passing them in a different way. Here's an example over on the right of a double forward. Let's say you want to forward an asset through 2 chains. I don't know why you'd want to do that, but it could be fun. And there's the first forward that would get processed on the first chain. And you see the arguments there. And then once the first chain processes it, it pulls off that top level of JSON, goes to that next field, and then makes the memo for the next transfer the second set of forward instructions. So here, with these 2 middlewares that we've described, swap and forward and packet forward middleware, let's go back to that flow we looked at earlier. We're going to remove the atom from a Kujira LP, and then in a single transaction, all of that other stuff is going to happen automatically, and the user would end up in a lending position on UMI. And the only piece of middleware that would not be live in this flow is a middleware to expose that lending position on UMI. But I think that, the way that I'm starting to think about these middlewares is a way to expose an Interchain API for your product. So if you have perps or you have any of these other things and you want users to be able to use those in a more composable way, you can write a little piece of middleware that exposes that functionality to end users and allows them to do these single transactions that accomplish many different things and chain them together in new and unexpected ways. So this is the flow for packet forward middleware. The first thing that happens is the user initiates a transfer, the packet gets received over on the receiving chain, and then we enter the packet forward middleware, which then forwards the packet that's received on the next chain. This is the bottom flow here is a 4-packet example. It would be this piece of JSON over here. And then the acknowledgements come back. And if you'll notice, the acknowledgement only returns to the first chain once the entire flow has unwound. So it allows you to process these things in an atomic way. What does the SAD path look like? In that JSON blob, you might have noticed a field called timeouts. In the event that the packet times out in the intermediate chain, we need to figure out what to do. So what we do is we allow the user to specify how many times they'd like that retried. And you can see here that instead of actually successfully making it to the next chain, in number 7 there, we're returning an error to the end user. And that's after 2 timeouts. Another way to enable this type of composability is with interchain accounts. And Quasar is probably the most prominent project working on this. Stride also has a really robust interchain accounts implementation. But this allows contracts or smart contracts on other chains, accounts or smart contracts, on other chains to control an account or a smart contract on another chain. And in this way, you can have a smart contract on one chain that controls accounts on many different chains and can perform these actions on behalf of the end user. Interchain, and Jake was just up here talking about Polytone. Interchain accounts and Polytone are examples of this. I think that both of these models are really needed, and what we're going to see is application builders are going to end up utilizing either one or the other, or potentially a combination of both of them. So what's next? I was talking a little bit earlier about how Interchain Accounts exposes this Interchain API. I think that there's a lot of other of these middlewares that need to be built to help enable this composability. And as applications are bootstrapping and building their code for the first time, try to think about this. What functionality does your application want to expose via IBC? And how can you easily do it? I think that there's enough examples of these middlewares out there right now. It's relatively easy to write. There's realistically 2 functions, on packet receive and on send packet, that you need to implement as an application developer. And there's enough examples where you can see exactly how to use this. I think one of the other things that I want to call out here is standardization of these JSON blobs is going to be really important. As this sort of like arbitrary text field with arbitrary data in it, there's a lot of unexpected things that might be lurking there, and we need to make sure that we're using the same standards and the same formats across many different applications. There's been a lot of discussion recently about this IBC hooks and packet forward middleware issue where the intermediate chain can potentially spoof the sender. And I think that this is kind of a fundamental property of IBC that's going to be hard to get around until we have something like fully multi-hop transfers, that the fully multi-hop packets that the Polymer team is working on, where you can kind of recursively prove across the clients that the sending chain sent the exact same packet you're getting. With these middlewares, the intermediate chain is actually processing the packet and then recreating a new one. And that can offer an opportunity for a malicious chain to do that. In practice, however, most Cosmos chains have a really constrained coding environment. You can reason about the code that's on the chain, and you can see that it's impossible to spoof that packet in a trusted intermediary. Thank you guys very much. And I've got like 5 minutes left because I rushed through that. But if anyone's got questions, I'm happy to take a few minutes for questions. Sir. Yeah.
Yep.
So you mentioned standards, which is great. Is there an existing organization in which that should sit? For example, we have the Interchain standards like GitHub. Like, I guess what organization, if it exists or doesn't exist, should be responsible for kind of like curating those probably increasingly important IBC standards as we go forward?
So the Interchain Berlin team has done a great job in giving us a high-level format for these. So if you see here this word swap, that references the exact piece of code that your middleware is going to call. And then that next is what you're going to put into the next packet. So this is the standard that we've been given. But I think for swap and forward middleware in particular, each DEX has some slightly different arguments that are slightly differently named for the inputs that they take for a standard swap. In order for DEX aggregation to be effective across the interchain, we're going to need to come up with a standard for that swap and forward in particular. I think that should, again, live in the ICS repo and be a broadly promulgated standard. But I think that one in particular is going to be a little challenging because exchanges tend to view each other competitively, and it would be easy for them to sort of diverge there. When we did the work with Duality, aligned it with the Osmosis work, so I believe that our JSONs are similar. But this is something we need to look out for as we sort of expand this functionality. Great question, Jake. Sir.
How do you recover from, let's say, a failed IBC transaction or a failed swap in that case, if you have multiple hops? How do you get back to the old chain? Is this done automatically, or are the funds going to be just stuck?
OK, so here in the packet forward middleware is a great example. So you see the user sends the transfer first, the packet is received over on the intermediate chain, and then we have a failure. The packet doesn't get relayed in time. There is a couple of timeouts, and then finally we return an error acknowledgement to the user. That error acknowledgement then unlocks those user funds. So the way that we deal with that is sort of natively through the call and response in IBC. And if you look back here, you can see that number 9, the acknowledgement returned to the original sending chain, only comes back after the entire flow that the user has specified is completed. So we wait quite a while on those acknowledgements. But yeah, we try to preserve that basic call and response functionality that IBC gives you. It's a great question. Yes. Open Q&A is like my absolute favorite.
Thanks. Since you're doing a great job trying to simplify the user experience and so on, we just talked about security. What about latency?
Yeah, I think that, fundamentally latency is going to be dependent on the latency on IBC connections and how long it takes it to transmit between two chains or potentially many other chains. if you have a 4 or 5 hop thing, it's going to take 5x the amount of time that a single transfer takes. That kind of goes without saying. But so like, how do we get latency down? As an application developer, try to do as many things in parallel as possible. If you can send 2 packets out at the same time that go do a couple things and then come back, that would be a lot less latency than doing it all serially. So like, think about ways to parallelize that work. And because you have a lot of different workers, which are these different blockchains, you can parallelize that work relatively easily. Other things are sort of like getting down that latency on IBC in general. Reducing block times across chains. The Evmos team has led the way there. But sort of seeing that more broadly and seeing more in faster chains, I think is one other way to reduce latency. As we see roll-ups with different light clients and different trust assumptions and also different block times, I think that will also help to reduce latency. But fundamentally, there will be a decent amount of latency in some of these user interactions, but keeping it acceptable is going to be up to the app developers. Good question. Any other questions? Sir.
How do you see the expansion of the types of middlewares that can be handled, and then the dependency management, like say between chains, of what kinds of middleware actions are allowed or not, right?
Yeah, I think that this just, in my mind, is another great use case for the chain registry and bringing that on chain in terms of a chain naming service. Chains should have the APIs, these Interchain APIs that they exposed, and the way to use those APIs registered somewhere that can be programmatically accessed, or at least like accessed by an end user in an easy way. And I think that as a community, we've done a really good job of building up that chain registry repo, but we need to continue to add new data to that, and this would be one of those things. Yes?
I just wanted to ask, like, why implement them as like a JSON and not like a Cosmos message? Messages are already, you know, very standardized, right? Like they are like
protobuf.
Yeah. So we can like, you know, encode them in a binary format or something, protobuf or something, which is like already generic, and you know, chain them in a way where basically we already have a standard. Then why reinvent the standard in a JSON format?
I think that there's a lot of answers to that question, but fundamentally, as we're thinking about parsing these fields in non-Cosmos places, JSON is a broadly usable data format. It's also human readable, which when you're signing transactions is extremely important. Like if on your ledger you saw this memo field and it was opaque binary and your front end inputted malicious data there, it's really hard to read that. So human readability was one thing. Ease of use in other programming environments is another. I agree, it is a slightly subpar solution, but this does allow us to get things to market much quicker and allow us to offer these user experiences that you see on ibc.fun and TFM and all of these other places that are going to allow us to bring many, many more users into the ecosystem. So I think the trade-off has been worth it, but yeah, it's not the best, but it's what we got. Awesome. I think I'm out of time. Really appreciate you guys as an audience. Thank you very much. Go check me out on Twitter. Check out Strangelove. We're doing IBC work.
Let's give it up for Jack. Woo! Right. Moving on. Next up, we have an exciting talk from Operations and Growth of Composable Finance, Ahmad Webby, on Centauri extending IBC to all ecosystems. Let's give it up for Ahmad. Look. Stop working. Put it close to your mouth. There you go. Just keep it close to your mouth.
Good afternoon. Hi, my name is Ahmed. I lead growth and operations at Composable. That's not my slide. Yeah. The clicker? Yeah, different presentation. Wrong presentation.
One. Let's just give it a minute to switch slides.
All right. Hi, everyone. Sorry for the delay. My name is Ahmed. I lead growth and operations at Composable, and I'm here to let you know that for the first time, IBC is live in production outside of Cosmos. So let's talk about how we got here, what this means, and why we're doing this in the first place. So, you know, DeFi or trusted bridges kind of suck. You know, Ronin was hacked for about 600 million. Wormhole was hacked for 300 million. Multi-chain was hacked for the third time just in 3 weeks ago. We believe that the future of bridging is trustless, and that's why we solely believe in light clients-based bridging, and that's why we chose IBC. And that's why actually we want to take IBC essentially everywhere. So that's one side of it, but you know, bridging is one thing, but bridging allows you to move tokens from point A to point B. For cross-chain DeFi to actually grow, we think that's not enough. You know, we think that users should be able to compose functionality across different chains based on this trustless infrastructure. So that's one, and we believe that this process also needs to be a lot more seamless than what we have today, right? So if you want to go from one ecosystem to another, you can't be toggling across different wallets, dashboards, explorers. That's just not a pretty UX for users, right? So that's what we essentially try to solve with our composable VM. Basically, a user specifying an intention or an instruction, have that instruction be routed across any chain IBC is connected to, and then have that be executed through a single interface. So that's a bit about composable as a whole and where our mind is at. But let's just take a step back and come back to the bridging side. Let's talk about, you know, the importance of IBC and how we basically extended it outside of Cosmos. So composable, at the core of it, or essentially, we were not a Cosmos chain. We didn't have a Tendermint-based chain. We are actually two parachains on Polkadot and Kusama. Our parachain on Kusama is called Picasso, and then our parachain on Polkadot is called Composable, right? So the first implementation of IBC was actually outside of Cosmos, was actually to connect Polkadot and Cosmos, or specifically our chain on Polkadot to our chain on Kusama, and that way, whenever we talk about connecting to Polkadot, it's not just, you know, one parachain or the other, or just a relay chain. It's actually the entire .sama ecosystem. So we started there. So Picasso is now connected to the relay chain of Polkadot, the relay chain of Kusama, and multiple parachains in both ecosystems. And then we went to Cosmos, right? So we'll talk about the specific individual connections and use cases later, but I'll just tell you now that it's live and that new ecosystems are also in the pipeline and are going to be landing really soon. I'm going to tell you that basically two main ones that we're working on today are Ethereum and Near. So as I mentioned, KSM DOT was the first stop. This was important for two reasons for us. One, because there isn't an existing trustless connection between Kusama and Polkadot in the first place. So this is the first time we enable liquidity to flow from Polkadot into the Kusama ecosystem. But I think, so that's mostly relevant for the Polkadot system in of itself. You know, for you or for us as Composable or users of cross-chain DeFi in general, this also means that, you know, through this connection to Picasso, you can tap into all of the Polkadot and all of the Kusama ecosystems. So yeah, next stop, Cosmos Polkadot, right? So this is already live. This is the work of about a year and a half of just working with multiple partners and collaborators, namely the Interchain Foundation. So essentially to make necessary changes to the IBC client to allow it to go cross-chain, Parity as well, Strangelove, and then finally Notional. And I'll talk about why we worked with Notional. So basically today, we can establish a direct connection between Picasso and any chain that has upgraded to the SDK version 0.47 or IBC7, right? But because most chains are not there yet, and because we don't want to wait for all of these chains to upgrade, we have essentially developed an intermediary chain, a hop chain, we're calling Centauri. This was done with the help of Notional, and the idea is that that hop chain is connected to Picasso, And then in turn, just through a very simple IBC connection is connected to, or about to be connected to every Cosmos chain that's out there, right? So basically the flow, let's say you want to go from Osmosis or you want to go from bring DOT into Osmosis. You know, today you could use Axelar, but that is the actual Axelar version of that DOT. If we want to talk about true trustless cross-chain transfers or DOT through IBC, then we can bring this DOT from the relay chain, from Polkadot, bring it into the composable parachain on Polkadot through XCM, which is Polkadot's cross-chain messaging protocol, down to Picasso over IBC, and then over from Picasso into Centauri chain over IBC as well, and then to any other chain out there, namely Osmosis over IBC, right? So that's what the flow would look like. We have already established about 17 connections. We launched just a couple of weeks ago. So if you fast forward a month from now, you can expect that we'll be connected to every single Cosmos chain out there, right? And so what are some of the first implementations? One is actual cross-chain pools, right? So these are cross-chain pools, again, enabled by IBC, right? So we recently launched a stream swap on Osmosis, and through that, we were able to basically put up 3 pools. Pika Osmo, KSM Osmo, and Dot Osmo are the first ones. Our own DEX, called Pablo, is also seeing some initial cross-chain pools, or the first cross-chain pools on the Polkadot side, and that is KSM Osmo and Dot Osmo. We've recently added Atom Dot. We've added ST Atom through Stride to Dot. We've added Stars to Dot. And there's a whole other bunch of them in the pipeline, right? So the idea is now that these connections are possible, you know, it's up to the teams, it's up to users to decide what pools can go up, seed them, and then they'll be live, right? So these are some of the ones that we're planning ourselves or in partnership with teams. Mostly focus on Cosmos because Cosmos has the more interesting DEXs and DeFi primitives in general from our view. So you can see some more pools on Osmosis, on Crescent, on Astroport, and of course Pablo, our own DEX. So we're just getting started. You know, this was last week, and last week all we had was you know, Osmosis, the relay chain from Polkadot, Kusama, and then USDT. Now we've added the Cosmos Hub, we've added Stride, we've added Stargaze as well. So these numbers are starting to look a little bit different. You know, 11,000 IBC transfers already. Pika is the asset that's moving the most, especially that we now have Pika on both Osmosis and on Pablo, our own DEX. And yeah, we're really excited about what this will enable, right? So these are ideas for now. These are not all things that have materialized, but some of them more advanced than others. We're talking to these teams, and we're just trying to imagine now that Polkadot and Cosmos, and then hopefully more ecosystems are connected, what can happen, right? So I think some ideas that I just want to throw out there, you know, IST from Agoric or Interprotocol in .sama. There is no stablecoin in there is no robust stablecoin in Polkadot anymore, right? AUSD is trading, which is the Akala dollar, is trading at around 40 cents on the dollar. So that's a huge white space for a stablecoin to come in, a native, you know, Cosmos-based stablecoin to come in, tap into a new market, tap into a new user base and new ecosystem. So we're hoping that materializes. Some additional collateral for lending. You know, this could be UMI, sorry, but this could also be, you know, Agoric again. You know, if we want to talk about DOT as collateral to mint IST. So basically, with the actual trustless or, you know, IBC version of DOT coming into Cosmos, you have another blue chip asset that's even bigger than Atom itself that can be used in the Cosmos ecosystem, right? So I think there's plenty of opportunities there to be taking in DOT, maybe even KSM as a token, and then establishing that as collateral for borrowing, for lending, for stablecoin minting in the Cosmos ecosystem. Cross-chain liquid staking. So basically, I mentioned that we already have pools with ST Atom. That's the start, but I think there's more we can do. right? So we're exploring basically an ST-PICA, so creating liquid staked derivatives of Polkadot-based tokens. I think that's going to be interesting for the Polkadot ecosystem, but also ST-DOT, which is something that would come a little bit further down the line, and that essentially is a big market for Stride to tap into, and for an opportunity to have DOT have a liquid staked derivative of it. DOT and KSM on Astroport. So I mentioned some pools: Astroport, Crescent, Shade, Helix. I think basically we're hoping these stop or essentially become hubs for cross-chain activity and cross-chain pools. Cross-chain NFTs with Stargaze. I think there's a bunch of things we could do. One of them is moving NFTs back and forth from different ecosystems. But I think also more interestingly, we could, because we've deployed a CosmWasm-based VM on our chain, that means that the likes of Stargaze or even Osmosis or any CosmWasm-based project can deploy on the Polkadot side and have their Cosmos instance and Polkadot instance be connected over IBC. So we're also excited about what that will enable. Yeah, so we're also thinking about how do we just increase adoption of these cross-chain pools and this cross-chain activity. We think that treasury proposals are going to go a long way. Right now, we're working on one big treasury proposal asking for $1 million in DOT from the Polkadot treasury. And the idea is to inject these funds into Osmosis, into Astroport, and start to really get these cross-chain pools to materialize. And I think further down the line, we'd probably do the same from the Cosmos side and then get some funding to support pools on the Polkadot side as well. So last thing I'll mention is basically, IBC is live outside of Cosmos. IBC is going to be live not just on Polkadot, but on Ethereum, on Near, and other ecosystems soon. So I think we're just excited about what that will bring in terms of functionality, and just excited to work with any team that wants to take any idea or use case forward. Thank you. Thanks for listening.
Thank you for that great talk. Oh, can you hear me? Is it working? Oh, there you go. Thank you for that talk. Awesome. Right. Next up, we have our first panel of the afternoon, and it is a spicy one. Yeah? It is a spicy debate between EVM versus CosmWasm. On the side of EVM, we have Jérôme de Taichi, founder and CEO of Comet. And for CosmWasm, we have Jake Hartnell, co-founder of Juno, with Sam Ben-Yacoub, co-founder and CEO of No Guardians Moderating. Let's give it up for all three. Should work. Put yourself in the middle of the stage. And then, there you go. One side. Yeah. It's going to be like a proper thing.
I don't know how spicy this is going to be. I guess we can make it really spicy.
So we're supposed to make it spicy, right?
We're supposed to make it spicy, and Jake and I agreed not to prepare that one. So
I don't know.
I guess we're standing up, and that's probably going to be some kind of stand-up comedy.
Yeah, it's going to be like a rap battle. We're going to just start rapping about Solidity versus Wasm. Ready?
So first of all, I'd like to thank all of you for being here. And out of curiosity, who is building on CosmWasm in the crowd? No one. One. Just one. Okay, who's building on the EVM?
No, you did it because it's easy.
Yeah, all right. So that gives us a base to...
Wait, is it easy?
To kickstart this debate.
Easy to copy-paste.
Oh yeah, that's the best thing about Solidity is the copy-paste ability. If you can't write Solidity, you can just copy someone else. That's great.
Yeah, or you ask ChatGPT, it works as well.
It does work for CosmWasm too. But first, guys, I'll let you introduce yourselves. Jérôme, on the EVM side.
So I'm Jérôme. I've mostly written a smart contract in Solidity since like the Solidity version 2, I think. I run Ethereum France, non-profit hosting conferences and events, notably ETC, and I have a gaming and middleware company called ComF, and we have ETH in the name because we do things on the EVM. But I love the Cosmos ecosystem overall. So if I say something that sounds harsh, it's just for the sake of the debate.
Your kind of comments are not really Cosmos aligned, I would say.
Well, space-wise, yes, we love the space narrative and overall space assets. So yeah. Well.
Jake.
My name is Jake. Started some projects in the Cosmos. Yeah, you might know Juno, you might know DAO, and yeah, work on a bunch of things there. Actually got my start in Solidity, though. I wrote my first line of Solidity around 2016, and I'm currently working on an art project in Solidity, so I still actually write it. And it's like your grandma or your grandfather. It's like they might be a little bit crazy, they might be a little bit outdated, but you still got to respect them because everything, like all these concepts, DAOs, DeFi, like NFTs, they came from Solidity. So there's a lot of respect in my heart towards the EVM.
All right. So where should we start? You're the host. So tell us what's the weapon of choice here.
The weapon of choice is that for a long time on the Cosmos SDK, you could build with CosmWasm and have this general purpose kind of smart contract environment to beef up your Cosmos chain, let's put it this way. And that was a good selling point for CosmWasm. And now we're seeing the L3 stack becoming more mature. You have the ZK stack on ZK Sync. You have Polygon that has an agenda for L3s. You have Sovereign Labs working on different kind of rollups that you can easily bootstrap with an EVM. And it kind of feels that now it is possible to have an EVM or a WASM system while benefiting from the network effects of the whole Ethereum space.
Cosmos was right.
Cosmos was right.
Yeah, Cosmos was right. Just maybe not executed in the right order, but the Cosmos overall approach of modularity was probably the right one. Now, well, one chain have the network effect now. So
interesting. So one chain has the network effect. What would you say against that, Jake?
I mean, I actually agree with all that. So we need to fight more. I think that's what people really want. They want the fighting.
So what do you like about WASM?
What do I like about WASM? Well, one of the things you can actually do with WASM is actually you can run the EVM inside of WASM. That's one thing, right?
WASM was a thing started at DEFCON 0 and abandoned pretty much at DEFCON 6.
Yeah, but I think if you look at why it was abandoned, it didn't make sense in the Ethereum roadmap, right? And that's like the key reason, right? It wasn't necessarily so much a damnation against WebAssembly for smart contracts itself, but it just did not make sense in the challenges Ethereum was facing at the time, which was really like scaling.
And I guess now we are stuck with an EVM that was a VM, the EVM that was built by cryptographer, not by VM experts. So we have lots of hiccups, lots of arithmetics problem. But if we consider it a settlement layer, it cannot make sense to have this as a layer 1 VM, I guess.
I mean, don't get me wrong, I'm a closet ETH maxi. Oh wait, if I just said that, I guess I came out of the closet, I'm an ETH maxi. But I'm not an EVM maxi, and there's some other reasons I really like WASM. So WebAssembly was built by VM experts. It was built with performance in mind. And so one of the things that WebAssembly can do is actually just blow away the EVM in terms of compute and performance.
It runs in the browser.
It also runs in the browser. This is another great thing about WebAssembly. WebAssembly runs in the browser, and we're just at the start, really, of like people being able to experiment with what's possible with that. Like we've seen a little bit of work in the near ecosystem, things like blockchain OS. Like you can actually run front-end code from a blockchain. That's kind of a crazy idea, but very, very decentralized if you're worried about censorship resistance, right? We've seen other ideas. Mars protocol actually takes the CosmWasm contract binaries and then puts them inside the front end for simulation and getting various different types of outputs.
That's a big problem for games. Like if you want to run on-chain games, you need to be able to simulate the world state of your game within smart contracts. There are a couple of really good projects doing that in EVM, like Mud, or in Starknet, the various approaches. And so it's much easier to write the game in WASM and just execute it in the browser as well. So this as you mentioned, it's a field of innovation and of testing, I think, mostly.
Yeah, I think that, I mean, don't get me wrong, I think the EVM is going to be around for a really long time, so I don't really like the ideas of like, there's only going to be one, right? Like, there's not. Like, EVM is going to be around for at least 50 years, but it's going to be like COBOL, like, which is a language that's still in use today and runs a lot of financial infrastructure.
What,
right?
COBOL?
Yeah, COBOL.
Okay.
Like, this is what runs our financial infrastructure, right? And,
Oh, yeah,
you know,
yeah.
I do buy the Ethereum as like a big settlement layer, you know, as kind of like I vibe with that narrative. I think that makes a lot of sense. And so EVM is not going around, but the things you can do with WebAssembly are kind of really next level. Another great advantage of WebAssembly is you can use existing languages. There's a lot of great Rust developers out there. There's more good Rust devs out there than there are Solidity devs.
Absolutely. So
and it's not just Rust. If you look at what the Cosmology team is now doing, you can have like very nice Solidity-like languages. There's this thing called CW script. They're working on TypeScript support, so you'll be able to write TypeScript, which is then transpiled to Rust code and compiled to WebAssembly. So like, how many TypeScript developers are there? There's a lot.
I get that transpiling in WASM, you don't lose that much of efficiency and performances because in the end, WASM is pretty efficient. But I don't really understand the argument of, look, you can write the smart contract in any language you like. It's all compiled to WASM. It's good because you are moving away from the blockchain complexity or abstracting yourself from the blockchain complexity in not the most secure approach. Like if you write in Solidity, which is already like a language that's like not the best language. But
yeah, do we want to talk about security? Because I'm happy to go there.
You have to manipulate a lot of blockchain concepts to write a good Solidity code, which when you write in Rust for WASM, you may be too far away from that pure blockchain infrastructure and blockchain interactions, and thus attracting new developers to say, I'm going to be able to write smart contract because it's in WASM and I don't care, while it's take a lot of knowledge about how the blockchain underneath works to write them properly. Do you agree with that?
A little bit, yeah. But I would push back a little bit because I think, yes, in an ideal world, I actually don't think you can write Solidity unless you have a deep understanding of how the EVM works, right? Like, but the fact is, people do, and then it's like that dog with the lab glasses. They don't know what they're doing, right? And Solidity is this language. It is deceptively simple. It looks really simple, right? But it's actually
extremely hard,
pretty complicated, and you really, really have to know how the EVM works, or I do not want you anywhere near writing code that's going to handle other people's money.
No, it's right. Like, but yeah, I get what you say. On the matter of writing good Solidity code, it takes a lot of time to get there. There's no debate. There's a debate on that. But once you have a good Solidity code, we pretty much, well, we have observed a lot of the attack surface of the EVM and how the edge cases of the EVM were working and appearing here and there. While even if the like CosmWasm has limitation for reentrancy and those kind of protections. I feel like there was also a risk on going WASM by just saying, oh, we haven't had much use cases yet or much high-level usage to be able to say.
I definitely disagree. Have you ever heard of Terra?
Yeah.
Terra did not crash because of flaws in its, but they were handling tens of billions of dollars. CosmWasm, tens of billions of dollars, actual apps, and
with an early build of CosmWasm actually.
Yeah. And definitely, if we looked a year ago or 2 years ago, yes, there was a lot less in CosmWasm. But now you're starting to see CosmWasm not only catch up in terms of copy-paste ability, right?
Yeah.
You're seeing it actually excel. If you look at something like DAO versus DAO tooling in Ethereum, it kind of makes DAO tooling in Ethereum look like a joke. Oh, nice snapshot poll you got there. In CosmWasm, we can do ranked choice voting on chain. Try doing that in the EVM.
Yeah, not possible for somehow good reasons, I think. But on the what I meant to say we've observed the different attack surfaces is that more usage, more use cases, more experiments will bring new flaws and potentially new protections in how you handle the WASM to blockchain link with the different libraries that are in CosmWasm. So they will get better. But from the get-go, you are in a form of uncharted territories where you are happy to head because you can write the code in this language you already know, rather than running another language.
Like, so you basically inherit all the tooling that comes with like WebAssembly that has been built over the last 2 decades. You have runtime isolation.
Yeah. You know, Foundry is pretty good. I've been working on this like art project, and Foundry is really amazing. But I still running like Solidity again with Foundry, which is probably the best tooling out there if you're a Solidity developer. Like, it just pales in comparison to the kind of stuff we have in WebAssembly and Rust. Like for example, we have these amazing thing called macros in Rust, which is like, for those who don't know, a macro is like kind of code that writes code.
And we have dynamic jumps.
But like that, I think there's also this question of investment, right? Like where how much has been invested into like taking this hack that was made by. I love this hack, but you know, it was made by like people to solve a certain problem in like 2014, 2015, right? And they put billions of dollars to like just trying to get. And if you look at CosmWasm, for example, the amount of money that has gone into CosmWasm, even versus the Cosmos SDK, what, like Confio gets like a $1 million, $2 million budget. Now that's going to change very soon. We have plans to make that change very soon. Wasm deserves to be a much more supported and awesome ecosystem. You know, I really hope to see, I think we're going to see a WebAssembly L2 soon.
Absolutely. No, I mean, Altlayer is proposing WebAssembly L2s as a service on Ethereum L1. But I have a spicy one on that, specifically on how EVM was built. Like in the early days of Ethereum, it was initially the C++ client was written by his almightiness Gav of Wood, the inventor of Solidity, the inventor of the EVMs and so on. And he moved away from the light and created Polkadot, or like still got some light or some shadow, I don't want to, depending on how you want to put it. And Polkadot is WASM at its core, but all the parachains that are getting tractions are EVM based. So it's like the light is shining.
It's like a religion, basically. The EVM is a religion. It's the initial smart contract framework that got a lot of people in. And ideally, if you start a new like system, you want to have people to be able to fork out their stuff and deploy with the cheapest cost involved. So I think that's also what explains the fact that we still see a lot of EVM chains running. And
Totally, and I agree with all that. It takes a while to build out a new ecosystem. But then I think if you look at the trend of WASM, right, we're starting to get to the point where not only do we have the copy-paste ability, which is important, right? If you're a CosmWasm chain launching today, like 2 years ago, this was not the case. You want multi-sigs, you want DAO tooling, you want DEXs, you want whatever. Like none of it existed, right? Like it all had to be built. Nowadays, that's not the case. There's like even really great like open source versions for all the things I've just listed, right? And so it takes time for an ecosystem to mature, and we should like set back our expectations a little bit, right? Like you can be really excited for CosmWasm or just for the future of WebAssembly smart contracts, but acknowledge that it's still like a relatively new ecosystem compared to Ethereum. And depending on what your use case is, you might very well choose the EVM. One of the things that I'm really excited about, though, is more hybrid models, right? So, for example, the idea of like running an EVM inside of CosmWasm, or being able to write WASM code that will like, you know, do like Ethereum call signatures, or you know, Ethereum has amazing Rust libraries, for example, and there's nothing stopping you from like using those in your WebAssembly smart contract environment. So maybe it's not either or, right? It could maybe the future successful model is going to be this like sort of hybrid approach.
You have like Arbitrum Stylus, which is a great example of this.
No, completely. I mean, we are trying to onboard more people into blockchain. So one thing I love about this onboarding problem is the approach of SegP 256R1, WebAuthn and Passkeys, which is native to WASM, or like already available in WASM, which is not, or really not in the EVM. We have to write the verifier in Solidity and optimize it, or maybe get them as a precompile. Getting into a new VM gets you a new stage of maturity in terms of what code you can execute on it. But at probably a lower stage of maturity into how much of the existing middleware and basic tooling you can find on the L1 can be applied to this new VM. In the case of Cosmos, yeah, as you said, like the DAO, the multisig, and all of those kind of tools can be now imported because of the modular approach of Cosmos as a whole. And I feel like it's going to be a much quicker path for the EVM to have that available as well. But definitely more flexibility on the VM would be greatly appreciated for on-chain verification as a whole.
It's definitely something that I'm really interested in. Is like WASM EVM hybrids, right? Like this is, I think, a very rich area that's like a good transition phase. I do think eventually WASM is going to become like a much more popular VM than it is right now.
I think it's going to be much more popular, but my view is that 36 months, the EVM will remain the de facto smart contracting platform, the main smart contracting platform.
Yeah, I disagree. I mean, I think we're just talking about timeframes, right? Like we're.
But as a business owner, like trying to make a living and having a successful team on the space, I bet on the EVM because I see 12 months, 18 months, 24 months. Okay, so that's a matter of runway. Like, where do you want to be if you want to execute and actually be able to sell and deploy? And like, if you take a step back, like, okay, we have the EVM, which is probably like a good combustion engine. It fits most of the use cases. It's probably not sustainable in the ultra long run. Now, is CosmWasm and WASM as a whole a bi-rotary motor, like a bi-rotary engine, like some super cool innovation, and like we can do much better, and it's theoretically feasible, and we can do things? Or is it the electric engine? Like, shall we move there slowly, like building up the infrastructure to have a resource station, or should we accept that those two are going to run next to each other for a pretty long time? Because for your day-to-day and simple applications and things that doesn't require lots of peer-reviewed and lots of experience on building off, maybe a Uniswap version in WASM is good enough for an L3 or an L4. Maybe it's better to use the plain Uniswap if you're on L2 because it's proven and there's a lot of tooling on this. That's where I don't know really if I'm willing to make a bet on hybrid right now or if I'm willing to wait.
I like contrarian bets, and I think it's always cool to like build the next thing, right? Like, but you know, it depends on what you're doing, right? Like, and so that's a perfectly valid perspective. I'm not saying that's like not a valid point, right? But you know, for me, I'm just like interested in like what is the thing that is going to push what you can do with smart contracts forward the quickest. And I think WebAssembly is just like going to be a much faster. I mean, look at. Again, just going back to DAO as an example. Here is a DAO that has zero VC funding and has features like sub-DAOs, built-in support for IBC, complex like permission systems with authorizations, like NFT DAOs, roles DAOs, like membership DAOs. Like this is all of this was like happened much faster because the tooling is so much better. I think another thing that we're going to be seeing a lot more and is super, super important and vital to our industry is privacy stuff, right? ZK, like, and the thing is, you know, Rust, all the cryptographic libraries are written in Rust. And I don't want to have to rewrite those in Solidity. That would be a nightmare. And you know, it's just, I think the tech stack that is going to push forward like our industry forward fastest the most, I want to accelerate the development. And I think that WebAssembly, I already know this from personal experience, like, and I wouldn't, every use case, every founder, you're going to need to make your own decisions in terms of like what you're doing, when you're doing it, where your go-to-market is. But as a technologist, someone who wants to build the future, I can just see that WebAssembly is going to, it might be slower in the short term, but it's going to be like exponentially much faster to like push innovation forward as we go forward.
So fast or convenience?
Yeah, basically.
Yeah. Because if you say like, okay, well, we probably live in a transitioning generation where most of the people will have exposure to code, we have exposure to writing an HTML page, writing a small Python routine or something like this. In this world where we make coding available to everyone, it makes total sense to say, hey, you want to actually have a code that's safely executed and that's also uncensorable, and people that interact with this code can actually look at this, like being able to write a code with and commit this code with one another would be, I think, much easier in this future world in WASM than it would be in EVM. Like, okay, now get your mastering Ethereum book, read the different things, capture the flag of OpenZeppelin. Okay, now you can write a code that says, if you do this, you do that. If you do this, you owe me this. If you reimburse, I owe you this. But how fast are we going to be going on this direction? This I don't know, and I'm very comfortable with having the EVM as the settlement layer. Say, okay, well, in the end, it's committing to the EVM, and we have this clumsy thing that we kind of know how it works. It can go south, but we cannot know how it works. So
I think it's like it's Ethereum though as the settlement layer, right? Like it's less about the EVM and more about like, you know, the culture, the assets, the liquidity, right? Like all these other, like the EVM is almost like marginal to like the people, the liquidity, the monetary policy, the assets, like how many, like ETH alone as an asset is, you know, crazy large. But look at Compound or Aave or all these things, like, right? It's like, to me, it's like the EVM. Yes, I'm not. It's going to be around for a long time, but like
we still speak Latin in churches, and I think that if you choose to deploy, if you're looking for, you know, you want to access that liquidity, these network effects, and all those good things that you have on ETH, you can't expect the specs of the EVM to change overnight or the EVM to become parallelizable on mainnet, but you still want to have something that composes and that accesses that liquidity. I think it all depends ultimately
I
on the
think
business.
Wasm will be able to access that quick. This is my like current like life mission right now is like I'm determined to access that. Like and we are not going to stop until we do. I don't know what the time frame is going to be, but like Wasm, we're coming for Ethereum. Like,
so in the well, the Wasm was a good attempt. I really love this project, and I think the team behind Wasm would be like both a little bit burned that they didn't go as fast as they would expect, but also willing to take
and
again.
also when I say Wasm on it, like coming for Ethereum, it's like just being able. Like today, I was talking about like TVL versus total reachable liquidity. I just want to make that liquidity reachable, right? And it might be in the form of like an app rollup, right? That has like a smart contract that's written in Solidity on Ethereum. But the fact is like being able to control it, being able to access that liquidity from like a different VM.
I like your argument of saying for most of the users, the EVM is already alien. Like we don't really know how it works, we don't really know what it is. I had a chat this at lunch about someone that's just saying about onboarding, and they were telling me like, well, I'm building an Explorer, and I don't want anyone to be onboarded that the first thing they do is click on the link that open another website and show them the Explorer, because the Explorer is complex. The Explorer makes people scared, like what are those 0x stuff and what is a block height and so on. But probably, but from my point of view, looking at people being onboarded on blockchain, they get curious. They click, they open the thing, they look at how, like it's like a car. Like you have your first car, and like in the 50s, in the 60s, you would open up the thing and look at the engine and be like, oh, this is the engine. No, I probably should know where to put more oil or when to put more this, when to put more that. Like so, I have a feeling which is probably an optimistic thought about saying that when people start to use Ethereum, they start to open the EVM, to open the Explorer, to look at the contract, to look at the thing. Like just out of curiosity, like when is my next transaction, going to be confirmed? What was the execution? What did it call? Oh, it called mint. Oh no, it called transfer all. Oh, I'm wrecked. Like this kind of thing. Like they open up the Explorer. Like so. And having more and more people getting into opening the thing and looking at the engine makes it more easy to ask your friend like, hey, by the way, what does it mean, like this call on this contract? What does it mean this contract is a blue tick and so on? So it creates a general knowledge of this thing is working, and there's a flywheel on people getting more and more accustomed in interacting with the EVM. From that point of view, like what do you think? How do you think it would? How easy do you think it would be to have a Wasm Explorer and make Wasm accessible?
Yeah, I mean, totally. I mean, I will acknowledge that Etherscan as a block explorer is like very far ahead of like, you know, MintScan's doing a pretty decent job, but there's like a lot more. We have a long way to go to make, you know, but the potential is there, right? Like we can do the same things. That is something as an ecosystem we just need to keep pushing forward on, right?
Yeah. Maybe we should take questions from the crowd, no?
Yeah, maybe the crowd has some spicy questions that will get us to fight more. I don't know.
Thank you. There's more. Yeah, this side is too hot.
You talk about Gavin Wood.
Yeah.
So we
Gav
had
of Wood. Gavin Wood. Gavin Wold. Gavin Wold, definitely.
So we have a co-founder of Ethereum who founded another project. And there is another guy who is also a co-founder of Ethereum, Charles Kinson. And he said Ethereum has no network effects. And you said, I have the network effects based on the EVM. So do we know what is actual real network effects? Because a few hours ago, we talked about reachable liquidity, not just liquidity.
No, there's a lot of different dimensions where you can estimate the network effect. Like the most obvious one is how many nodes. Like how many nodes are there on the layer 1? How many people are replicating the thing? If I pull this plug, how many are still alive? I think we are in between the 8K and the 10K nodes on Ethereum right now. It's difficult to probe, though. Okay. Now the network effect for me, I see it as the EVM franchise. You know, you have the Marvel franchise. Like how many spin-off, how many things, how many Avengers do we get? Like the fact that this VM was adopted by various chains that are doing God's work of onboarding people onto the chain. I'm talking about the BNB chain, the Polygon chain.
You mean all those vampire attacks? You know, I think one of the key advantages of WASM and CosmWasm specifically is this built-in support for IBC. And so you can have this network effect that's much more real, where you can actually capture, like deploy protocols and capture value from those protocols on every chain these things are deployed on, permissionlessly.
Definitely, you have the rise in fees on Ethereum layer 1 makes some applications not possible on layer 1 anymore. There's a form of a death hug from DeFi, like, hey, now you either do DeFi or you go fuck around somewhere else. Excuse my French, but that's definitely the case for gaming. And in the case of, okay, the price is too high now on Ethereum, so where are we going to go? Well, we're going to go on another chain because we are going to move a couple of €100, so it doesn't make sense to pay 20 euros for the fees. So there's a form of vampire attack-ish or extension of the extension.
I think it's just crude, like right, like in this new interchain world we're going into, like being able to, like, and we have seen Ethereum protocols like deploy on these other EVM chains, right? But they're not connected in any meaningful way, and I think that that's something that's like kind of lacking from that model.
I think Charles' remark on we have no network effect is a Trumpian argument. No.
Charles is the worst founder from Ethereum.
We have no network argument.
Yeah, I totally disagree with that. Like, no network effect. What is he talking? What is
so but you have formal verification.
Well, for 1 transaction per second, okay. Anyway, Tezos has a formal verification as well. But anyway, the point is like, how do you measure network effects? So I think all new chains.
Haskell is how you get network effects.
Yep.
Like,
yeah.
Like,
you measure it by the length, the wideness of the network, but also having newcomers saying, I want to go on EVM. Having L2s being like, oh, I want to go on EVM as well. I think the ease of recruiting someone to do a specific smart contract work in Solidity, the ease in finding suppliers for middlewares or core infrastructure stuff. And for me, the most important thing is the installed number of wallets. Like how many wallets are you compatible with? Like if I launch an EVM, I have to convince the guys from MetaMask to list my new network, and okay, voila, now those users can use my network. That's a network effect as well.
I mean, yeah, they're coming for Cosmos as well. I have a slightly different take. I agree with all that. But yeah, I was being sarcastic about the Haskell thing. That's how you don't get network effects, because at the end of the day, you have to build actually useful applications for people. People have built actually useful applications in the EVM, right? And then it's much easier to build usable applications in WebAssembly. Like the Haskell developers, like you can't hire those people, and then the performance of their network sucks. And I don't think marketing squads like going around and like shilling coins to people in like South Asia is like, I don't think that counts as network effect.
Making someone install a wallet is probably the hardest thing we have to do in this ecosystem. So whichever VM or whichever chain has the most installed wallet has a good head start, or most good compatible wallets.
You know, I do think though that like there's a lot that we can gain from just coming together, right?
Yeah.
Standardization. Again, I don't think this is an either-or thing. Maybe we should have fought more, but you know, in many ways, these ecosystems are kind of merging together. The Interchain, Ethereum, like WebAssembly, EVM, the lines are going to get increasingly blurred. Even wallets, right? As we standardize more wallet connection type interfaces, like, you know, I'm really excited for Snaps to come to MetaMask. Like,
and WASM will remove a lot of friction.
And I think that here we're celebrating like interoperability. Like you have the IBC Light Client bridging framework, storage proofs incoming. So there's also a future where both machines can actually coexist in harmony. Oh, wait, not harmony, but like yeah, they can coexist. Yeah.
Yeah, totally.
Yeah.
That's
And learn
the
from
future.
each other's.
Coexistence, interoperability. That's who wouldn't be excited about that? I mean, who wouldn't be excited about like from a Cosmos chain you can access and work with assets and accounts on Ethereum? Like this is the future. This is the interchain future. Let's go.
That's a good closing remark. Well, thank you everyone. Thank you, Jake. Thank you, Jerome. And
Let's give it up for Jake, Jerome, and Sam. Is that working? Yep. Right. We're going to head into a 15, 20-minute break. Right now in the studio, there is a validator meet and greet hosted by Chainflow. The studio can be found by the entrance, by the registration desk, so feel free to check that out. And then after that, at 3:50, we'll head into the final stretch of Nebula Summit 2023 with a talk from co-founder of Squid, Fig, talking about opening up access to Cosmos. Thank you, guys. Catch you in 15. Hello, testing. Yep, okay, that works. All right, welcome back, guys. Welcome to the final stretch of Nebula Summit 2023. We have a very exciting talk from the co-founder of Squid, Fig, on opening up access to the Cosmos ecosystem to anyone. Give it up for Fig.
Hey guys, thank you. All right. So yeah, my name's Fig. I'm one of the co-founders of Squid. Hey, and I want to give a talk about bringing people into the Cosmos, opening it up to anyone, no matter where they are. If they've got a crypto wallet in the EVM, Cosmos, if they don't even have a crypto wallet, we can do it all in one click. So multi-chain UX is hard. This is where Squid came out of. We came out of a world where there's hundreds of app chains, there's roll-ups that are appearing, there's only going to be more and more, and it's scary every time you go to a new bridge. You don't know if you're going to get scammed. It's scary going to a new website you don't know how to use. We just need one standardized way of getting tokens around the ecosystem and just being able to use your money. A little bit like Stripe would be for Web 2. You just go to a website, you know you can pay just because you have a credit card, even if it's in a different country. If you've with a different bank in your country, then you can still use your money. And also, the Cosmos is a really specific case of this, because between EVM we have MetaMask. Everyone has MetaMask, and maybe you can make your way over to a new chain, but then if in the Cosmos you have to download a new wallet, and then you have to learn a ton of new things from there. You have to get gas, you have to learn about IBC. And so that's what we do at Squid. We're using Axelar, IBC, we do DEX aggregation, and we have an intent style system so that you can do any action in one click anywhere in one click. So we do that with smart contracts. We have an API and SDK and a backend, and we've got a set of front-end components which make it really easy to build applications. And it's a bit like the Stripe PayPal thing I said, where you have your app and you can add payment in no matter what the product is, whether it's staking, NFTs, if you just want to onboard people into your bank. And our killer feature is the swaps between EVM and Cosmos. We're really excited about this. It's not live on mainnet publicly, but we've got it working in mainnet and should come out any moment now. And you'll be able to swap from Arbitrum USDC into Atom on any chain in the Cosmos in one click. You'll be able to get ETH to staked ETH on Neutron. You'll be able to go between the Cosmos as well, any token in the Cosmos to any other token in the Cosmos in one click. Everything's in a single click. If we want to compete with Web 2 UX, then we're going to need everything to just be in one click. Every new click that the user does, we potentially lose their attention, lose their decision to buy the product or enter the application. We've got contract calls across chains, and we've got this boost feature, which yesterday you would have seen all the cups, the speed boost Squid cups. So between EVM chains, it's not so simple as IBC. IBC is really fast, and generally the user experience is pretty good going between IBC chains, but going from Arbitrum, for example, it's 20 minutes. You have to wait for the finality on Arbitrum, or same with Ethereum, it's 15 minutes, Polygon it's 6. And we've got a feature which brings everything down into 20 seconds so that you can go between any chain, call any contract in one click in under 20 seconds. And I think once we get there, and the prices are good, which for us they are, we've got a competitive experience with Web 2. We do path unwinding, which is the problem where if you've got Atom on Osmosis, you can't transfer it directly to another chain. You have to go back to the Cosmos hub, then to the destination chain. And we do all that in one click using the packet forward middleware. We monitor execution for you so you can see when something's completed. And you can get gas as well. Because when you're going to a new chain, you always need to get a new gas token so that you can actually use your tokens once you're over there. And we've made a simple button in the widgets, and on the API it's a simple parameter where if you set it to true, then you get a tiny bit of gas and you can use your assets once you arrive. We're connected to 12 EVM chains, a bunch more coming, and currently 30 chains in the Cosmos. Soon to be basically every chain in the Cosmos will be supporting, which I'm really excited about. We do the EVM to Cosmos swaps via Axelar's GMP. Now, Axelar is a Cosmos chain which allows you to call a contract on a Cosmos chain from the EVM world or vice versa. So we're able to compose liquidity. We're able to, Squid doesn't use any of its own liquidity, we just use the existing liquidity that other teams have built up, and they've got their own AMM technology. So we can plug into Osmosis and SushiSwap in the same transaction. And it's really exciting because we can scale so quickly. We can go to 80 chains, like we said, without needing to build up liquidity on 80 different chains. We don't need to offer incentives. We just integrate with everyone. And also, Osmosis is benefiting from all the volume that we're generating. So all of our users going through Osmosis will hopefully bring fees to the network. Same with SushiSwap Curve. And in the Cosmos, we use IBC between chains, and it's possible because of two IBC middlewares. One of them is called the Packet Forward middleware, developed by Strangelove. And we've been working with chains to install this wherever it isn't installed yet, but it's getting fairly good adoption now. And that allows us to go, say, from Atom on Umi, we can send it back to Cosmos Hub, and then to Osmosis, all in the same click. And we can also call a contract on Osmosis, so you can send Atom to Osmosis from Umi and deposit into Mars in one click, for example. And we do the contract call on the end using IBC hooks, and that's something developed by Osmosis, which lets you call a CosmWasm contract using an IBC transfer. And we've been working with other teams like Umi to develop hooks for their chain if they don't support CosmWasm, so we can still get these one-click flows even if they don't have smart contracts on their chain. So you can do all these amazing use cases with Squid. I'm really excited to be building some of them now. We've got, you can buy NFTs in one click across chain with any token. That's going live on the EVM side with Decent. We're working with Stargaze as well, so that when all the cross VM wallets go live, you'll be able to buy a bad kid using any EVM token. Say from your MetaMask, from your Leap wallet, from your XDeFi wallet, from Cosmos Station. And GameFi, obviously the same thing as NFTs, staking across chain, and the wallet piece I'll speak about later. So this is our swap widget. Really easy to use and really easy to install. It takes like 20 minutes to install it, and you can customize it in whatever color or even fonts that you like. It's integrated in 50 different front ends across the Ethereum world and in the Cosmos world, including like PancakeSwap, QuickSwap, StellarSwap. I think the Calc guys have installed it. We've got it in Cosmos Station, Leap. And we've just modified it so you can now build a staking widget really quickly. So now in a matter of hours, you've got a staking product, and you can allow people to buy that staking product from any chain in one click. So you can see here, we've got Pinjam is a lending protocol on Kava, actually, EVM world. And you can pay with whatever token you like, and you receive staked Axel USDC. So that's, you'll be getting yield on your Axel USDC in one click. And we just this week integrated with Cardo, so super excited about this. This is the biggest chain of all, the fiat world. And in terms of onboarding people to the Cosmos, I think there's a huge unlock. So we'll be able to get all of these things I've mentioned, buying NFTs, staking, just getting tokens, getting gas, all using a credit card, using Cardo. And the user doesn't even have to know that Squid's involved. It just happens in the background like magic. For Osmosis, currently you have to install from Ethereum. Sorry, not install, but you have to deposit from Ethereum. And now you'll be able to deposit USDC from Arbitrum, from Avalanche, from Polygon. And also we'll be reducing the fees, which I think a lot of people have been sensitive about. It's really expensive to go from Ethereum, and we can bring it down to, in the hopefully cents, maybe tens of cents, to onboard and offboard from Osmosis. These are the wallets I was talking about. this is the missing piece, I think, now. So once we get the wallet piece right, you'll be able to move between chains without even knowing it. So Squid in the background, moving the assets around, calling contracts. You've got the wallets, managing signing on different chains. And we'll have a user experience which is really competitive with Web 2 and hopefully ready for the next phase of users to come in. If you want to develop with Squid, these are our docs. You can develop with the SDK or the API. There's some examples in there on buying NFTs across chain, Cosmos examples as well, going between Cosmos chains, staking. And this is our widget. As I said, it's only 20 minutes worth just having a look at if you're a front-end dev. Just try installing it and customizing it a little bit. And that's all. So if anyone has any questions, I think I got a bit of time. Give you a minute. Just put your hand up if you have anything. We've got a question over here.
Does this work? Yep.
When Cosmos back to EVM, when are we going interoperable both ways?
Yeah, this is when the swaps go live. So I'm not giving public dates, but let's say in the next month, you'll be able to go back to the EVM as well. Yeah, I think having both ways is going to be important for arbitrageurs to start keeping prices really efficient. Should be driving some volume across and increasing the interest in the Cosmos as well. And then also for Cardo's use case, you'll be able to offboard. So imagine you'll be able to, with your Cosmos wallet, pay at a store in the real world. So use your assets really quickly, offboard into your bank account or offboard into a payment. All right, I'll leave it there. Thanks a lot for having me.
Let's give it up for Fig, everyone. Right, so we just spoke about opening access to Cosmos. Now we've got a very special talk on decentralizing access to Cosmos. Oops, sorry, one sec. Just opening up my phone. Awesome. So we have a talk from Yair Klepper. Sorry, I'm not sure if I'm butchering that pronunciation or not. Co-founder and CEO of Lava Network. Awesome. Just give me 2 secs, bear with me. Awesome, okay.
Hey everyone. Yeah, sometimes even Mac run out of battery. So I'm very excited to be here. Nebular Summit, Cosmos is kind of our home in Lava. We started with this ecosystem a bit more than a year, but really feel here amazing and connected. So I want to talk to you today about public good and how do we give access, much better access to the Interchain. And I want to start with RPC, right? That's the basic, the core protocol of how do you read write to the blockchain. Easy as an ABC RPC. So if you think about RPC, that's the protocol that helps us get access, account balances, gas fee, everything in order to communicate with the different blockchains, hundreds and thousands of blockchains that exist today in the ecosystem, especially in Cosmos. But there are three ways of how we today get access with the ecosystem itself, with the blockchain itself. And I want to start with a question. Who here is running his own node? Perfect. Who's here running nodes for less than 5 chains? Who here is running node for more than 10 chains on Cosmos? Perfect. As you see, nobody wants to run his own node. And this is something that Moxie said 1.5 years ago. That actually gave us the kickstart in order to come and build Lava. Nobody wants to run their own node because it's complicated. As blockchain adoptions grew up, it doesn't make sense to run your own node. So when you starting to get access to an ecosystem, you actually look at the public RPC. Public RPC is where every dev starts. Every developer, when he's coming to Juno, to Axela, to every blockchain here, needs a reliable RPC. And how does he do that? With a public RPC. But today, RPC, if we're speaking between us, it's like the backyard of every ecosystem. Because you don't know what's really going there. So for big protocol, big ecosystems, they're not incentivizing top providers to come because it's very hard to aggregate them. So for devs, you have only one solution. If you don't want to run your RPC, if you don't want to run your own node, if you don't want to use a public RPC, you go to the centralized provider. And we identify 4 problems today with a centralized provider. And as the name hints, you think about single point of failure. When they're down, nobody can get access. You don't know even your MetaMask account balance. You think about censorship. Everyone remembers here Tornado Cash last year and OFAC censor Tornado Cash. So obviously, that's a real problem when you think about the value as censorship resistance. The last thing is privacy. What about the privacy? Guys, we came to blockchain to have some privacy, right? And we don't use it today. We don't get it today if you trust a single provider, a centralized provider, collecting the data and probably sells that. The last thing we wanted to address is the data accuracy. Because when you think about it today, data accuracy doesn't really exist. If you trust someone to bring the data to you, how do you know the data is even from the blockchain at all? And this is what we came up with a conclusion in the last 1 year. When you think about node infrastructure, nodes as a service, reliability is a super, super important word. And if you want to attract to your ecosystem, to L1s, L2s, Interchain, Cosmos ecosystem, you cannot do that with a bad UX, UI, and bad developer experience. So that's what we do in Lava. Lava is a peer-to-peer incentivized network of top RPC API providers, and we're trying to do that with a reliable and much better way to get access to all the blockchain. And the way we do that is that we're creating an incentive for every node runner. We aggregate all the providers on one side of the chain. At the other side of the market, we come up with the different ecosystems and create an incentive pool that at the end of the day attract the nodes. And our peer-to-peer market helps us that if one developer is running in infra, one developer is running one of the nodes in Agoric, for example, in Paris, another developer that needs the access in London can get it immediately. So it's kind of the Uber for nodes. We help node runners to incentivize the existing infrastructure. Already running the infrastructure, why not monetize that, right? Why not creating another monetization stream and revenue stream for them? So we think about a pool, something like when you think about a liquidity pool and Uniswap, think about Lava Pool together with ecosystem to attract developers. And once you list 1, 2, 3 nodes, immediately you can get revenues. We see between $300 up to $700 a month per node. This is significant. So I want to talk to you a bit about now how Lava works. So when we created Lava, we thought how we can attract node providers to come, how we hold them accountable, and how we make sure that the data they serve is being reliable. So every provider can join Lava. It takes 5 minutes up to 30 minutes. Sign up on Lava. We are an app chain on Cosmos built on Tendermint and obviously Cosmos SDK. And we have a list of providers that staking Lava. They're staking Lava in a specific geography, which I'm going to elaborate a bit later. And the dApp, when they coming and need a specific request, RPC API request, immediately they being paired with a fleet of nodes. So if one node goes down, immediately we can revert it to the other node. And one of the things that from the beginning was a game changer is our SDK. Imagine that exactly from the browser, you're going to get access to a fleet of nodes that in one click give you an uptime of 99.99%. So just to talk about a bit key features of the protocol, and we're summarizing them for 3. Auto pairing. Everyone in Lava needs to be stake Lava in a specific geography place. And why is that? Because latency is super important. Because if you think about a node that needs access to Starkware, you need access to Agoric, we want to maintain the same geographic feature, the lowest latency as possible. And we do that by making sure that geographic is the first place. The second is the accuracy and data freshness. Me and my co-founder, we bring a lot of experience in building startups, in building open source, developers tools. And when we came to crypto, sorry to say that, but we felt like the infra is shit. Right? Like, woo! Bucky? Yeah. So, we were investigating a lot. We put a lot of time to think how we can create this kind of win-win, kind of incentivized pool. But when we receive data, we actually know it's originated in the blockchain. And we're doing that by making sure that the uptime, the freshness, and all the feature of the node runners is held accountable for what they bring. And this is how they've been incentive. Because if you are a developer, you can use Lava subscription as 1 month, 3 months, 1 year, and get access to all Web3. But at the same time, you want to make sure that the node runners are getting incentives for their service. So node runners that bringing better service will be incentivized much better. So we launched in Lava 3 types of product. We have the server kit, we have the gateway that's been running for a few months, and last week we announced our SDK, guys, first Lava SDK. It's been very exciting because it's first year and it was exactly 1 year after we found Lava, and coming up with such a tool that for us we think it's going to bring so much benefits. And the gateway before we launched the SDK is basically a public endpoint that being supported in more than 24 chains. 24 chains, a big part of that you're here in Cosmos, and we're growing and working on that every week. That's the first way you get access to the Lava gateway. The SDK, it's a peer-to-peer SDK. If you think about the word decentralization, so we don't want everyone to think about the misconception of the world, because decentralization is one of the reasons we are here. But everyone here will took to less priority the decentralization if the latency is being heard for that. And that's what we wanted to handle. That's what we wanted to address. It's an SDK, it's a game changer. There's no such a tool like that in all the Web3. Straight from the browser, you're installing the SDK and you get access to a fleet of nodes. And I'm glad to tell you that since we've launched, we've seen already more than billions of relay use of SDK, hundreds of downloads for the SDK, and more than 200 providers, node runners, joined the Lava family. So as I said before, we're supporting already 24 chains and growing now rapidly. I'm going to use some quotes that our dear friends, dear family here in Cosmos gave us in a break of water. So I like what Jay said about how how we're supporting the Juno in order to help projects such as DAO and Wind to fully decentralize across all parts of the stack. Cryptocito was quoting that decentralization in Web3 is incomplete. If we keep relying on a centralized provider, we are super stoked to contribute to Lava Network testnet. Sunny, everyone relies on the same centralized RPC provider. And if we want to make blockchain better, utilizing decentralized RPC provider like Lava Network is a crucial step. And our friends from Strangelove and Galileo said we back Lava to make every level of the infrastructure development process more decentralized, flexible, and resource optimized. So I'm going back to what we shared before. We have 3 ways to get access to blockchain, right? But if nobody wants to run his own nodes, if nobody can trust the Web2 infrastructure player, so we left with public RPC. And most developers, when they're coming to the chain, when developing the team to a bigger team, when they need production-grade services, they still want to use the public RPC. However, today, it's unreliable. Because on the one hand, there's a lot of ecosystems that have the best top providers, but they don't know how is the performance of the centralized provider. They don't know how to monetize. They don't know how to distribute the funds they put for every top provider at the end of the month, because they don't know what's going back there. So we today, after developing for 1 year the technology, we're introducing our first product, and we call it RPC as public good. Think about a one public RPC endpoint powered by incentivizing the best quality providers by the ecosystem itself, whether by the native token or whether by fiat. But we want to incentivize and attract the community contributors. So if we create a fund, if every ecosystem going to create a fund, can take the same amount of funds that today attracted to the community to run those RPC nodes, we can attract much more developers that are already running the nodes. And here, the difference is the public RPC today doesn't change, doesn't make any difference when you think about attracting developers. If you're already running an RPC node, validators, providers, you can join Lava today. It takes 5 minutes up to 30 minutes to sign up and be listed on Lava in order to provide the nodes and receive rewards at the end of the day. So when you think about the incentivized public RPC that we do, our product is ready. We launched last week, announced with Evmos, and we're working with big ecosystem and amazing, amazing friends here from Cosmos in order to provide this kind of public RPC. We want you, and we want every developer that's coming to Cosmos to focus on the quality, not on the price. Everyone knows today that RPC is becoming a commodity. Everyone knows today that when you go to one provider and afterwards with the same quote to another provider, the price is going down. But when does it end? Why the providers need to subsidize that? So we want the provider to focus on what's matter for them, not on the quotes, not on the financial, not on the marketing. They want to focus on the performance. But RPC, it's only the start. What if we can create a pool of incentivized APIs? We never heard about this thing before in crypto, but we think that every API can be a public good. So we're starting with an RPC, but shortly after, think about you can use if a node runner, if some developer, even single development developed a Stargaze NFT APIs in London. Why cannot get royalties out of that in the same ecosystem? If a Cosmos Hub Wallet API received and developed this API, why cannot somebody in the other side of the globe use that? And the same goes for Smoothis, and the same goes for every different ecosystem. Think about the Uber of APIs. So I'm very excited to be here today, summarizing my first step after launching our Alpha SDK. And I'm so enthusiastic to be here to help, to contribute to this amazing ecosystem that we're so lucky to be part of that. And as we like to say in Lava, let the lava flow. Thank you, guys.
Nice one. I think we have time for a few questions if anyone's keen. Is that all right, Jeff? Hey, let me actually let me go over. Okay, there you go.
Yeah. Earlier in your talk, you mentioned that node providers sign up and specify the geography that they're in. How do you actually verify that they're actually in that geography? How do you verify that the node provider is actually in London and not just saying they're in London, but they might be in, I don't know, Istanbul?
So we have that's a very good question. We build most of the technology around the performance, around the peer-to-peer. So at the first onboarding, you have, first of all, the accountability of yourself to prove how's the latency. Because from the first, every transaction, you're being accounted and you've been monitored the performance, the latency, what's the uptime, and all of that. So that's how we create a win-win situation for every provider to bring the best performance. By the way, we're working already with BlockDemon, with big other providers that see the value of not running after that, but after the dApps themselves. And another thing that was very interesting is the settlement layer. Because if you think about the billing at the end of the month and you're running after the provider themselves, after the dApps themselves, we do that in Lava.
So the latency is the measure of like geographic distance, is that what you're saying?
Yes, but apparently if you have a performance even in a different region that works better than the hardware you use for running the node the same, it's obviously going to be accountable for that. But the geographic presence is automatically routing the transaction to the dApps in the same region. So to create consensus. What's very interesting about the region is that if you take your question one side further, when you think about dynamic pricing, right? This is the first time you can do that because we see the supply and demand in every different region. So why, if somebody runs a node in China, is the same as running a node in Europe? Maybe there is an NFT drop suddenly in Africa, and there is only 3 providers that's supporting there. So we can attract nodes to where we see high demand.
Cool. Thank you.
You joined, right?
Any other questions? Nope. All right, let's give it up for Jay. Thank you, Jay. Right, we're just going to wait a couple minutes ahead of our final talk of the afternoon, ahead of the final panel. But yep, just sit on tight, and final talk should run in a few minutes. Wait, testing. Okay, there you go. All right. For our last talk of the day, we have the co-founder of Polymer Labs, Bodu, talking to us today about enshrined interoperability, bridges will die, and what's next. Give it up for Bo.
Hey, everyone. Oh, shit. This is not that violent. Is something wrong with the... All right, cool. The display is working now. Hey, everyone. Shit. Yeah. Hey, everyone. My name is Bo. I'm here to talk today about bridges, why I think they will go away or fade away over time, and what I think about what's coming up next. Some background on myself. I'm a co-founder and technical lead at Polymer, where we're working on connecting everything through IBC. Previously, I worked on distributed systems, database systems at a number of startups. So the agenda today is we're going to try to apply operating system design to blockchain design. We're also going to talk about the concept of enshrined interoperability, user space versus kernel space trade-offs, IBC as an ecosystem-wide standard, and how virtual IBC scales adoption. So operating systems are split into user space and kernel space. In user space, we have the applications that you and I use every day. In kernel space, we abstract away the many different computer architectures that underlie these applications. It will be quite challenging for application developers to develop if they have to understand the computer architecture internals of every computer architecture that they're building on. So if we apply operating system design to blockchain design, we have in blockchain user space smart contracts or application-specific modules running in a virtual machine, in the Cosmos SDK as an app module perhaps. And in blockchain kernel space, we have settlement, consensus. Perhaps we have Comet BFT over ABCI, for example. Currently, bridges are built in user space as smart contracts. These smart contracts represent a tax on innovation that's growing and that's limiting future innovation and ideas. The issue with user space interoperability is that when we want to enter user space to execute interoperability code, we're coupling with the transaction format, custom RPC endpoints, account model of every specific chain. This means that we need a custom relayer for every single chain that we want to integrate. This also means that we're exposing the internal chain data structures of every chain to every other chain. For example, if we're connecting to Ethereum, we're exposing the Ethereum state trie to other chains in the IBC network. We need a way to verify proofs into the Ethereum state trie that something was committed. Additionally, inefficient execution means that bridges are forced to make compromises, whether it's by offloading the network management of network topology and routing information to off-chain agents, or if it's by adopting lower or less ideal security primitives. Overall, we get a cost of maintenance that equates to O of n, where n is a number of unique chain types in the network. How can we reduce the cost of innovation, the cost of maintenance from O of n to O of 1? Before we start, I want to define a term. Enshrined is a term commonly used in the Ethereum research community. In the context of rollups, it describes rollup logic that has its logic or its validation logic enshrined into the L1 or the protocol or the L1 client itself. This is different from a smart contract rollup where the rollup's validation logic lives in the smart contract. Let's perform a brief review of the interoperability model before we continue. In the interoperability model, we have the application layer, transport layer, and state layer. The design of bridges today generally do not respect the transport layer because they need to make compromises due to inefficient execution. Additionally, they adopt less secure security primitives as well. They rely on, as I said before, they rely on off-chain agents to manage the network topology and routing information to communicate between chains. Enshrining interoperability would migrate the logic from user space into kernel space. This means that we move the transport and state layers from user space into the kernel, where the kernel now manages encoding of the network topology, routing information, and verification logic of chains. There's a few benefits to this approach. For one, we get standardization. This means that we can have a complete implementation of all three layers of the interoperability model without compromises. This allows us to encode the network topology and routing information on-chain instead of off-chain. Encoding this information on-chain allows us to prove state across chains and allows each chain to have sovereign ownership of its view of the rest of the network. And between chains, you can establish a chain of trust where this view of the network is chained together. We also get an equivalent representation of chains at this transport layer. That means every chain looks the same as every other chain at the network level. This allows us to do things like standardize on a single relayer implementation. It also enables us to decouple execution We can decouple IBC execution from chain execution, IBC state from chain state. Once decoupled, we no longer need to share the same data structures. So we no longer need to we can avoid exposing the internals of each chain to every other chain. We then have the ability to reuse relayer infrastructure and proof verification schemes. We don't need to write a custom relayer anymore for every single chain that we integrate. Overall, we get reduced integration overhead. There's now a minimal interface between the IBC side and the chain side. We can expand on the ideas before. If we standardize on a single relayer implementation, we can remove this relayer completely and replace it with a peer-to-peer network. With a peer-to-peer network, we now have a shared mempool across chains where we have IBC transactions are visible. We can then apply ideas from ANOMA, such as heterogeneous paxos, to allow for cross-chain atomic transactions across the IBC network. You can apply this idea by taking the intersection of the validator set of IBC chains on the network, connect them together, form a new chain, which they call a chimera chain. This is temporary. You can transfer ownership over a subset of the keys in the IBC state to this new chain and allow executing or atomic commitment over this in the chimera chain. Afterwards, the chimera chain returns ownership of these keys back to the original chain. The design of IBC is already hierarchical in nature and is topology specific. So it respects, and you have a very clear distinction of the subset of keys which you would need to grant ownership over in the chimera chain itself. Another fun idea is the ability to have a standard account model across chains at the interop level. This means that we would be able to use interchain gas tokens. A user will be able to issue a transaction cross-chain or across many chains using tokens that they have on the source chain. Overall, enshrined interoperability looks pretty good compared to bridges. But I want to talk about trade-offs. There's no free lunch in computing. Everything has trade-offs. What are we trading off? When we target user space for interoperability, which bridges are doing today, we're trading off for short-term distribution and simplicity. This is inherently a short-term optimization. When we target kernel space, we're trading off for functionality, safety, and future-proofing. This is inherently a long-term optimization. At Polymer Labs, we're building for the millions of developers that will enter the ecosystem in the next 10 to 20 years, not for the next 1 or 2. And to enable these developers to do their best work, chain developers must take control of the interoperability narrative and decide on what standard to enshrine into the chain client itself, to standardize on the interoperability interface for these developers and allow for innovations like the ones we shared before. So how do we decide on an interoperability standard to enshrine? What are the properties that we want? The first property that we would want is we want the standard to be open. It needs to be a standard that is a work of a collection of entities, teams, individuals, and not owned by a single specific entity. We need it to be neutral. There should be no value capture or value extraction at the protocol layer. We need it to be decentralized. It should be permissionless to join at all layers of the stack, and it should ideally maintain or lower the trust required, or lower the trust assumptions required by the system overall. IBC is the best choice given these requirements. However, there are some issues with IBC adoption or IBC integrations, as many of you may be aware. So let's take a look at what IBC looks like today. We have IBC Go, which is implemented as a Cosmos SDK module. Inherently, this lives in user space versus kernel space and inherits many of the issues that I outlined before. At Polymer, we've been exploring the idea of decoupling IBC app layer from the transport layer. after decoupling the app layer from the transport layer, we have the ability to move the transport and state layers of the interoperability model into the chain kernel. This means that we have an asynchronous binding between applications and the tau layer of IBC. We call this approach virtual IBC. It decouples IBC execution and state from chain execution and state. This decoupled approach scales adoption. We call something that implements virtual IBC an IBC outpost. A local IBC outpost can enshrine IBC logic over the virtual IBC interface, or VIBCI, into the chain itself. Also, once decoupled, IBC execution can also be remote to the chain. A remote IBC outpost can remotely enshrine IBC execution into the chain via the virtual IBC interface as well. This allows for permissionless integrations of IBC. An array of these IBC outposts forms an IBC network mesh, and this becomes the basis for future innovation. Targeting user space is an undifferentiated approach to interoperability. The more you simplify, the more you become similar to all other bridging protocols. IBC should take the approach of a kernel space approach and target innovation and differentiation and future-proofing and scale. We want to get to a system where the cost of maintenance of the entire system is constant, or O of 1, instead of being O of n. Bridges today are similar to many of the proprietary networking protocols that preceded TCP/IP standardization. In the 70s and 80s, there were a number of companies building their own proprietary networking protocols. This period was coined the protocol wars. At Polymer, we spent time evaluating the protocol wars, seeing how it progressed, and seeing why TCP/IP was adopted as a standard. We've hired many experts, industry veterans from companies like Arista and Cisco with decades of networking experience to help tackle this problem. The idea is that we want to, over this period, this next 10+ year period of the interop wars, which we're in now, we want to help establish IBC as a de facto industry standard. During this period, there will be many competing proprietary networking protocols or interop protocols that will be seen as standards. Even during the protocol wars in the 70s and 80s, many of these protocols up here were seen as de facto standards of their time. In the same vein, as IBC gains slow adoption over the long-term time horizon, we'll see proprietary systems, perhaps, which I won't name, be seen as industry standards as IBC gains adoption over them in the long-term time horizon. And as always, please join us in building the future of IBC. Thank you.
They're probably the best stickers I've ever seen.
Okay, let's give it up for Bo, everyone. How are we all feeling this afternoon? Are we all still awake? Right, it's been 2 amazing days of insightful talks, fiery debates, and spicy panels. Last but not least, we have a very, very, very exciting panel, star-studded lineup on are the next 12 months make or break for Cosmos? So I give you none other than Sébastien Couture, founder of Interop Ventures and host of Nebular Summit, Ethan Buckman, founder of Informal Systems, Zaki Manian, CEO of Sommelier, Spade, general manager of Neutron, and moderated by Zave Megan, chief investment officer of Chorus One. Let's give it up for all of them. Woo woo!
Line up with your pen. We need our bad kids. Where's everyone's bad kid? Well,
these are super comfy.
Huh? Do you need a mic?
We only have 5 minutes.
Is there another mic?
Dude, we're running out of time.
All right, let's do it. Man, it's hot here.
We start now? Or?
Let's go.
All right, so welcome everyone. There's some familiar faces here. Congratulations, you made it. It's the final panel of the final day of 10 days of conferences in Paris, so good to see you all still here.
Look at all these people. What are y'all still doing here?
Go home.
So today's panel will be on the next 12 months for the Cosmos and just how important growth will be sort of for the ecosystem to compete with some other pretty compelling ecosystems and narratives coming up in the Web3 space. So yeah, we have 4 panelists on with us today. We'll start with Seb. I'm sure all of you know him. He's a co-organizer of the conference, but maybe just a few lines, Seb, on yourself.
Yeah, I'm Seb, founder of Interop Ventures and organizer of this fine event.
And we have Bucky as well.
Hi all, Bucky, co-founder Cosmos, running Informal Systems.
Zaki.
Zaki, co-founder Sommelier.
Spade.
Spade, Chief LARP Officer at Neutron.
And then, yeah, myself, I'm at Chorus One. I'm the Chief Investment Officer there. So, yeah, this panel was actually inspired by a tweet that Zaki published pretty recently. I'm just going to repeat the tweet for anyone that's not familiar with it. So, yeah, from Zaki, I think Cosmos Social Capital has about 12 months to do something unique and differentiated. Otherwise, we get swallowed by ETH-flavored variants of Cosmos-originated ideas like rollups and Eigenlayer. So that's the tweet. We have 12 months apparently, so I'm going to start it off with, to what extent is this actually a threat to the Cosmos? And we'll start with potentially you, Zaki, considering it's your tweet.
So I guess I'll present the evidence that, Cosmos is under threat. I'd say probably the most compelling evidence is that every exchange chain in the past has always been built on the Cosmos, on Tendermint and Cosmos SDK. Exchange chains are like the most successful blockchains, but the 2 new exchange chains are, one is built with the OP stack base, and the other one is a sort of a Frankenstein of multiple L2 stacks that Mantle built. And I think that's like a great example of like large high distribution apps being built, or like large high distribution blockchains that previously were always using some element of Cosmos tech, now using ETH L2 tech. Obviously these things are either just becoming live or about to become live, and so we'll see how they go. But it does represent, I think, a big erosion of Cosmos's place in the market space. And then there's just this enormous, access to users and liquidity that ETH L2s have demonstrated, where there's millions of monthly active wallets versus Cosmos being sort of sitting at around 100,000 monthly active wallets and way lower app use numbers than app use in the EVM ecosystem.
Spade, I see you nodding your head a fair bit there. Do you have anything to add to that?
Yeah, I mean, I think a lot of us in this conference and a lot of the speakers have like touched upon these issues beyond sort of like the fact that the stack is under threat in terms of like being used for these like meaningful projects. I think also just being able to bootstrap an economy in Cosmos that has intrinsic appeal to the outside world is something that we're still working on, and that has not like been encroached yet, right? Like, and I think that's sort of like the threat to everyone who's building Cosmos right now. So completely agree.
So I want to just zoom in on one part of this tweet coming from Zaki. So rollups and Eigenlayer originated in the Cosmos, or these types of ideas. So I wanted to put this question to you, Bucky. So these ideas like rollups and Eigenlayer that are being executed in Ethereum, are they out there in Cosmos already? And if so, how do they exist right now in the Cosmos?
Yeah. So the question here is, are the next 12 months make or break for Cosmos? I think tweeting things like this is make or break for Zaki's Twitter account. The guy has 12 months before Twitter goes under, so he's got to make the best use of it as he can.
I don't think we have 12 months till Twitter goes under.
Yeah, we may have less. So no, I mean, all of Ethereum's good ideas come from Cosmos. I think that much is clear. No, I have a lot of respect for Ethereum, obviously, but the thing about Cosmos is we're sort of values first, right? And we harbor a certain set of values, and that has attracted a certain energy, a certain kind of people. And for me, it's really about the values in the long term. And other people, adopting technology that those values created doesn't compromise those values. And I think so long as we continue to stick to those values and to build according to them, that there's a future. So I think it's great that Ethereum has realized that what Cosmos has been saying forever is the way to scale Ethereum. That's great. It was always our intention that Ethereum would use Cosmos ideas to scale, and it's awesome to see our little brother achieving that. But at the same time, obviously there is. In some sense, there's a very competitive landscape. You could call that threatening. Sure, it's something to pay attention to. It's definitely, we definitely can't be sitting on our laurels. I have often felt that the organizational drama we've experienced in Cosmos is just the universe's way of giving everyone else a chance to catch up, because we were so far ahead that we just needed to be slowed down so that we could compete on fair terms. And so that's where we're at now. So I think we are seeing. I mean, it's true as Zaki said that we're seeing exchanges now use ETH2s because finally they're available. But at the same time, you have to understand that there's the EVM is extremely sticky at this point, and so much tooling and stuff has been built for it. So part of those decisions are also driven by that kind of integration. And at the same time, we're seeing one of the largest applications on Ethereum move into Cosmos, right? And so that's important to look at and watch very closely. And I think everyone here is very excited about DYDX and what they're going to be building. And that's it was the values of Cosmos that shone through, that said the values reflected in the technology of we can build the best product and the best UX for our users. And so we'll see more of that, I think. Yeah.
I think the other thing that wasn't in the tweet, Buzz, that from my point of view, we have all of the building blocks of survival, right? Of not even survival, of success. All of the necessary components of sort of becoming something that is distinct and separate and distinguishable from Ethereum are already in motion. All of the necessary things, whether it's having a more compelling tooling for Ethereum EVM builders from Polaris, to demonstrating what you can do on an app chain that you can't do and you won't be able to do for years on an L2, which is what DYDX is demonstrating, to actually doing a better job of liquid staking, and continuing to evolve the proof of stake economy with the liquid staking module. We've got all the right things in motion to really distinguish ourselves. But this is a critical moment of execution.
Yeah, I think the question, there's another question in the question, which is what is Cosmos, right? And I think to your point, Cosmos is values. It's it's a vision, right? It's a technical vision of how to scale blockchains, and it's also a stack. And at Interop, we sort of look at projects that fall within the values, the tech architecture, and the stack, and we look at those as interchain projects. And we've had this kind of branding thing, and this kind of goes back to the branding things, what is Cosmos? What's a Cosmos project? What's not? I think that this is going to become less and less relevant as the values, the architecture, and the stack start permeating outside of what was typically the Cosmos, the projects of the Cosmos, the Tendermint diaspora or whatever, right? And these ideas that you guys seeded,
the mafia, we're a mafia.
The mafia. Those ideas that you guys seeded have been extremely influential outside of the ecosystem. And so the way that I like to, it was sort of inspired by something Sunny told me, is that I think of Cosmos sort of like Linux. Linux is in literally every device in this room, including these TVs, probably these cameras, people's Apple Watches, etc. None of these devices characterize themselves or brand themselves as Linux products. They're using Unix, they're using the Linux sort of kernel and core technology. Some projects brand themselves as Linux, and that's fine. But DYDX is a perfect example of a project that aligns with the vision, aligns with the values, aligns with the technology, but doesn't necessarily align with the branding, and that's perfectly fine. And Cosmos will continue to live on, even though, even if the Cosmos Hub ceases to exist, these things will continue to be a thing, right?
The Cosmos Hub will not cease to exist, but
it won't. But I think like really the core of it is not necessarily an ecosystem or like this chain or that state or whatever. It's the vision and the stack.
So a lot of this vision in the Cosmos is sort of about the app chain thesis. And so, you have DYDX, which existed in Ethereum, then on a layer 2, and then eventually became an app chain. So do you think sometimes in Cosmos it sort of suffers from cart before the horse? So potentially app chains are built before there's sufficient demand for the apps themselves, and they should actually start on execution layers or something like that first before moving to their own app chain? Or do you think that doesn't matter and you can always start as a layer 1 app chain and see if demand pents up after the network's already been built?
Yeah, I think in some sense the whole industry suffers from that a little bit. I mean, we could talk about building like Web 2 products first, and then so you could say Cosmos also suffers from it insofar as the whole industry does, and maybe a little more. But I think it is a very nice funnel to witness, the sort of easy deploy on these smart contract platforms, and then maybe they move to an L2 before moving into a sovereign zone. But that's also not to say that you can't build something from scratch as an app chain. We saw Osmosis build an app chain from scratch, and it worked very well. Yeah.
I think that Osmosis is an interesting case study. Like Osmosis V1, 2 months, right, from like deciding to build it to shipping, which is like which is like comparable timeline to like any smart contract in Ethereum, arguably faster. But on the other hand, Osmosis catching up to the DeFi innovation on Ethereum that happened in 2021 and 2022 basically took 2 years. And the experience at Sommelier has been our smart contracts. Our chain came out before our smart contracts. Our smart contracts were like an entire year of R&D. But now we're able to iterate a lot faster on our smart contracts than we are able to iterate faster on our chain. It's a very similar experience where you can grind out V1 of a sort of minimal app chain pretty quickly. And as you're searching for product market fit, I experience this constraint. I'm like, okay, like some stuff I can do a lot faster in terms of like we could ship a new WBTC product on top of our smart contract layers a lot faster than I can like change the way the SOM token works in the SOM L1, or like add Axelar support to our L1 architecture, or all of these other things have taken far longer than like I would hope, and like I think it is a realistic representation of like the difference between these environments. And I think it's if DYDX is like going to be the shining example of an app chain, it's very important to recognize that it is DYDX v4, and they were able to spend an entire year building this incredibly advanced application, but like they were able to invest that because they had product market fit on their v3 application, which is the largest by volume DeFi app out there.
But you also literally couldn't have built SOM just on Ethereum. I mean, that's the whole point of SOM, right?
Well, yeah, with Eigenlayer in like a year, I would have been able to build Sommelier without Cosmos. But
yeah. So maybe it's worth making a distinction between kinds of applications, right? There's things that you couldn't possibly do on Ethereum. You can't build Agoric on Ethereum. You can't build a new VM, right? And so there are things where, yeah, there's Dean, yeah. So that's a great example, right? You're not going to like go build Agoric on the EVM and then and then move off. Like you can only do that using Cosmos tech, right? Whereas there are other applications that you could build on Ethereum first and then slowly migrate off. And so that's a viable funnel for those kinds of applications. Once they hit product market fit, they want to tune better to their users, provide better experience, then app chain's the way.
Yeah, but I think there's, I was talking to Neil from Eclipse recently on the podcast, and we were talking about this idea of going from like roll up to app chain and that sort of graduation path. And it seems like going from smart contract to roll up to app chain, like that the upgrade path is not so clear there. But I think we're going to see applications like there are other applications that may go from that may go the DYDX route and go app chain, go full app chain. But I think we'll probably see a lot more applications kind of roll back as cost of security increases. Like what is at stake on those chains versus the security becomes a real concern, and a lot of app chains will probably, sort of like downgrade, or if you will, or sort of come back to a lower layer of security or like less sovereignty in the form of a roll-up. Yeah, I think that's probably what we'll see in the next couple of years.
I mean, the Celestia dream is to move the roll-up to smart contract trade-off to almost zero. How long, like, is that possible? How long would it take? Could that be a future? We certainly haven't really accomplished it in terms of like, if we wanted to make smart contracts and app chain and smart contracts and like Cosmos app chains be as, one for one from a developer experience point of view. I think we had an ambition when we sort of started, and we did not at least accomplish that ambition so far.
So I want to mix it up a bit now and have a sort of discussion around users in Cosmos and whether or not there's actually enough users already. And I know, Zaki, you've talked about before about activating the users that are already there. And I know Spade, Neutron's out now, CosmWasm's available, there's new types of applications coming out. So I have a question for all of you here, which would be around how important is it to focus on the users already in Cosmos and activate them as using products more than what they are now, versus going out to other ecosystems where users already exist, like Ethereum, and trying to onboard them into Cosmos directly. But I want to start with you here, Spade, if that's all right.
Yeah, for sure. I mean, I think they're equally as important, and I think it also depends on like what product you're trying to build, right? It probably doesn't make a lot of sense to try and court the Ethereum community if you're building a very focused, like a Cosmos-focused project that solves like, I don't know, like liquid staking of, exotic coins in Cosmos, for example. I think one of the main problems is like we have a community that's like pretty badly burnt from a lot of the kind of like the bear market basically, and basically becoming like very, very conservative. And so we now are in a position where we have like all of these applications starting to actually launch, and the DeFi ecosystem in Cosmos is regenerating, and it's arguably in a better position than it has ever been since the collapse of Terra last year. But finding ways to actually mobilize people to use these applications and get them battle tested as well, right? Because that's a big part of ensuring that the ecosystem is resilient and can grow. It's like we have this model, these modules, these contracts that are used, that get a lot of activity, that can be used to build new applications, can be reused essentially, is one of the things that makes Ethereum's ecosystem strong, but that we don't really have a lot of in Cosmos currently. And so, yeah, I think basically one part of this is making the UX a lot more frictionless, and we have great teams like Skip and Squid and others like who have been shipping a lot of awesome products in this regard recently, like IBC.fun, for example, is, and the ability to buy bad kids from any chain with any token in one click is an incredible improvement in this regard. But one of the things that I found Zaki's comments on recently particularly interesting is that like it's not just lowering like the onboarding or like the friction. It's also like we need to find ways to motivate people to try things out, because we're in a stage now where they're not even trying to discover what's possible, right? Do you want to share any of the thoughts that we were discussing recently?
Yeah, I mean, I think, so Sommelier has been, I've probably talked with like half the people in this conference about, what has been working for Sommelier from a growth point of view. But activating users on Sommelier, I mean, everyone's like, okay, Sommelier, highest staking yield, has highest ETH yield, like why is this thing sitting at 10 million TVL instead of 100 million TVL? And getting to that 10 million TVL has been like a massive struggle of like reaching out, direct user engagement. Like that has been by far the most effective way of onboarding people. And, I look at Cosmos apps and like, most Cosmos apps you see like there's like 100, 150 wallets that are like sort of willing to go in, start playing with things. And I haven't really done any like sort of analysis to see if it's the same 150 wallets, but I do see this like similar numbers. And like that's clearly not enough, right? Like especially, in an environment that's like, even lower gas costs and like lower fees than Ethereum L2s. So it's just, it's like we should be, and like there's the narratives that Cosmos, that like our people tell themselves in Cosmos, okay, the best way to get airdrops is to, is to go and is to stake your atom. The Ethereum narratives are the best way to get airdrops is to go use the apps, right? Like, we have to change. We have like a huge user activation problem, and people are burned and people are risk averse. But like, now is the time, and really now is the opportunity, if you're aligned with the Cosmos ecosystem, to like go out and start using stuff, become experts on this. Like, we actually have like sort of built the full features of the DeFi ecosystem. We have lending protocols, we have concentrated liquidity, we have perp protocols, like we have all these things. Everything people are doing on ETH-L2s you can do within Cosmos now, but we have to activate a user base to actually go out and use them and yeah, otherwise NGMI.
Seb, do you have anything to add to that?
I just thought that was such a great point that in Cosmos we're sort of like trained to stake our tokens in order to get airdrops, while in Ethereum the airdrops come from using the apps effectively. I think that's
yeah, I mean, on the flip
really
side, that also leads to a lot of like, you know, heartaches when you get non-Sybil resistant airdrops like exploited massively, sometimes by their own investors, like the Ribbon Finance Hub protocol, kind of like, oh, the wrong project, but like Ribbon Finance and stuff. So, I mean, I think that this has come as well from a position of like carefulness. Like, there's history of airdrops going wrong in Cosmos that I think projects are trying to not replicate. But I kind of agree that there's probably like new models that we can invent to really like get people interested in one of the ideas that we were bouncing around, right, is like you know, you have this idea of quests, but they tend to be heavily botted and lead to very sort of like inorganic sort of adoption. And one model that Zaki was sort of like mentioning is like, how about you get a committed group of people and you give them resources to basically go out and, you know, pump their own bags by finding other folks who would be interested in this, presenting these opportunities to them, ensuring that they get, you know, the support that they need to like try things out, and essentially, you know, like reactivate people through a more like P2P approach rather than the sort of like Web 2 like batch campaign type of things, or the, you know, posting a message on Twitter about this opportunity for an airdrop somewhere being present. And I think there's a lot to be explored there. So I see this as kind of like the other side of the public funding question coin, whereby we have we need new infrastructure and new mechanisms to handle funding differently so that we can activate our developer base and like secure it and ensure that people get, you know, interesting opportunities to build on. Same thing for users on the other side, right? Like, those are the two sides of our market, and we need to nurture both of them, basically.
I mean, just on the user thing, like, I want to come back to my initial statement, which was that, you know, Cosmos is very much like it's like a nerd ecosystem, right? It just like, if you go back to like the 90s and you look at the Linux ecosystem, you had to be a real nerd to use Linux and to want to use Linux. And the users came from applications like operating systems that were super user-friendly, that saw this technology and that saw in it the potential to build something really great. Like macOS was, you know, a big part of that. And like, now most of the people that use Linux are using macOS, I think. And so I think that the users of like the current state of Cosmos, it doesn't really matter. What really matters is like what applications that people are building on it, and some of those applications that are really pushing the bar, like some of the applications here, for instance, I think will bring the users, and we won't even know that it's a Cosmos stack underneath. Those users won't care.
But a lot of this discussion seems to be about, you know, reactivating existing users or moving people from Ethereum, and we're all sort of, you know, competing for this small pie versus going after the, what, 6.9 billion people who aren't using cryptocurrency at all by building more useful applications. And Cosmos is the place where you actually have all the tools to build more real-world things, to build, you know, new kinds of social media applications or gaming or you know, payment systems, right? All these kinds of things that are now possible to bring in real users who don't have to know they're necessarily using crypto, or don't have to know they're using blockchains, and don't have to be bogged down in, you know, sort of weird semantics and things. And so that's the opportunity I'd really like to see, rather than, you know, fighting for some small group who got, you know, traumatized by Terra or whatever. You know, let's build like real, practical, useful applications for the real world to bring in like new developers and new users who don't even have to know or care or think about, you know, anarcho-libertarianism or DeFi or any of this nonsense.
So Bucky, why do you think that some of the applications and also user acquisition, let's say, target and focus on existing sort of crypto users rather than these new types of use cases that unlock a new type of user base that might not be in crypto yet already? Why do you think it's so focused on the other way around so far?
Yeah, I mean, I think DeFi has sort of found product market fit, and so everyone is sort of chasing that down into the ground and below. And at some point, we'll get buried 6 feet under or whatever, and that's sort of happening. And until there's like a new use case that's unlocked that really kind of works for people, it'll be hard to open that up and build the momentum and excitement. I mean, it's hard. There's a lot of people that want to build like real world things. It's difficult for them to raise funding because it's like, oh, how does this fit into like the narratives that we're all repeating to each other over and over again, and it doesn't. And so then you're sort of written off because VCs are super contrarian all the time, right? They definitely don't have a herd mentality about anything. So I mean, I think there's a lot of just like narrative and hype, and everyone wants to invest in infrastructure because that's where like the money is to win and take it all. But really, we need to be building useful applications.
I think the reality is also it's like, if you have to onboard a user onto self-custody, if you have to onboard a user, if you have to like acquire that user, set up a wallet, onboard them onto self-custody, like all of that, like, I mean, even for like DeFi experts, I think the apps are like, we're just at like the threshold of like, for like a fairly sophisticated user where it like doesn't take like, 20 minutes to use like an app now. Yeah. Right.
I tried to set up 3 people on Kepler this week using Google Sign and it didn't work.
Josh, where is he?
Yeah, I mean,
fix it.
Web3 auth. We need something better.
No, I mean MPC is the solution. I think
MPC is the solution, but that particular implementation has had so many problems, right? And I think there are better implementations coming. But yeah, I think like, but it's like if you can't get the self-custody, that's the other thing is products only get better when people use them, right? It's that angry user who's like reporting bugs, who's like, who's just like in your DMs being like, this isn't working the way I expect it to, who like it helps your product improve, right? And so we do have to, like the existing community is a resource, I think, for crossing the chasm. And right now they're providing a lot more feedback to people who are building on Ethereum than people who are building on Cosmos. We have a window to change that.
So we've only got a few minutes left, so I might make this the last question I ask all of you. And I'd love to hear if you could list one catalyst each that you think will have the most impact on the Cosmos and its growth in the next 12 months that you're most excited about. We'll start with you, Seb.
Nebular Summit. I mean, I say that a bit facetiously, but I think getting the stack, the vision, and all of that stuff I was mentioning earlier in the hands of entrepreneurs and developers that are looking for like a technology that they're able to build these really cool apps with is what we should be doing. We should be empowering developers to use the stack that we think is viable for the future and to bring on, like, to build the applications that will bring on the millions of people. And so that's what we're trying to do here at Nebular Summit.
Seb showed his thing, so I guess I'll show mine, which is collaborative finance. Yeah, I mean that's our approach to where we can take Cosmos to actually have real world impact in the payment system and meaningfully build up and intervene in finance in a way that's not just like replicating the same thing, but can actually work in the real world, that real world people can use it. But we do have to we have to break through this gap of how we're going to get people to actually use wallets and things like that. And this is why we want to start with sort of a Web 2 solution, just like build something that's like accounts payable, build fintech, and then get it to the point where it actually needs a blockchain to get to the next stage, right? But then you actually really have to tune to users and usability, and that requires solving the kind of key management problem, which is kind of embarrassing that it's still unsolved for us all. But with MPC and these kinds of other sign-in mechanisms, it seems like we're finally there. But we have to actually test it with real users now. So Ko-Fi is how we're going to do that.
This is a very difficult question for me because I do think it's the synthesis of many things is actually the path forward for Cosmos, and in general the path forward for blockchains in general to sort of get out of this sort of local optima. I think I'm really excited about real world assets. I think real world assets are probably going to be a big thing. I'm really excited about intents. It is like it's probably the first research-oriented topic that's ever been UX-driven, and I do think that's probably going to be a big piece of like having a capability of like finally like someone can just like open up their phone and want to do something on a blockchain and like actually get it done.
Yeah, I agree. I think at a smaller scale, two things that I'm pretty excited about is first one is like MetaMask snaps that don't suck, and that will take some time. But once we get there, and they're a pretty good team working on it right now, so bullish. But once we get there, I think that will significantly lower the adoption hurdle for the ecosystem as a whole. The other thing that may or may not happen over the next few years is can we get Atom to have the same moneyness as other like Ethereum and Bitcoin currently? Because if we do, and there's a bunch of very interesting projects working on this, like the TimeWave folks, for example, which could help. If we are able to pull this off, I think it could also be a massive benefit in both UX, but also the stickiness of the ecosystem, its culture, its value, and as a whole, essentially.
Cool. So thanks, guys. We've just wrapped up the final session of Nebular Summit.
Thank you.
And 10 days of conferences. So well done to you all. Thanks
everyone.
so much for coming on the panel. Thanks, everyone, for being here still after many days. It's been fantastic. Thank you.
Thank you for all for the really, everybody came. It was amazing. I was saying, I thought there were going to be 30 people here.
You have no faith.
Well, thanks all for coming. I'm just going to wrap up with some brief closing remarks, and then we can get on to the fun stuff. All right. Woo! That was a hell of a thing. These 2 days, man. I want to say thanks to everybody who's here. And I mean, it's absolutely incredible that we were able to bring together, that all of you came together for Nebular Summit. Brought your energy, your great ideas, your enthusiasm, also, some hot takes and some contradictions. I think that's all great and it all contributes to the conversation. Just wrapping up here, we had 100 people on Sunday for the Hack Day and over 400 attendees for these last 2 days. So, yeah, I mean, that's amazing. I said it before today and yesterday. I'm absolutely blown away by everyone's presence here after a long week, and it just goes to show just how incredible this ecosystem is and how dedicated they are to getting together. So some highlights: we had over 80 speakers. 20 product demos. We had 10 workshops over the Hack Day and in the classrooms. 10 volunteers that worked their asses off to make this possible. They were at the registration desk, running around, finding speakers, emceeing the rooms downstairs, making sure everything was smooth. So thank you to the volunteers. 22 sponsors, which I'll go over in a sec. We served 550 cones of ice cream. And people really love the ice cream. And lots of stuff happened this week. So Creds announced their verifiable credentials. OKP4 announced their no-code UI that allows them to utilize off-chain data and algorithms. DYDX demoed their V4 testnet. Yeah, Andy from the Roll Up was like doing interviews the whole time upstairs. The post-human guys were like running around filming a documentary. And we had a lot of great costumes, of course. It wouldn't be a Cosmos Interchain conference without costumes. The mage outfits were amazing. Thanks, guys. And we did have a bear show up at some point. And a nice touch, the Agoric team with the beret. Love it. And we created some memes. This thing is already on Twitter, and I think we're going to see it for a long time coming. And we made some art. And I think this is one of the things that really I hold dear here with this conference, is I want it to be also an expression of creation. So this is one part of that, having Cedric here recreating the art from the T-shirt. I hope everybody got a T-shirt. There's still lots of T-shirts left if you haven't got one. And we are going, so there's also a badge, right? So the QR code is about everywhere. You can grab that badge as a proof of attendance. Creds also has a verifiable credential that proves you were at Nebular Summit. And we're going to do something very special today. We're going to auction a special edition, one edition of the final result. And actually, this is a GIF that shows the progression of the artwork. And we're going to auction off today. The winner gets lifetime VIP access to any Nebular Summit event or dinner. And the proceeds of this auction will go to a charity that Cedric, the artist, recommended, which is a charity for one of his friend's sons who died of diabetes. So it's a diabetes charity. And he'll be telling us a bit more about that during the cocktail. So lifetime access to Nebular and a really cool NFT. I think you all should participate. Want to thank the sponsors, all our sponsors: Neutron, OKP4, DYDX, Secret, Check, Celestia, Juno, Agoric, Chainflow, NIM, BPI France, Noland, the Interchain Foundation, Sommelier, Kado, Polymer KR1, and there's more: Akash, Kira, Squid, Hyperlane, Composable, Leap, and Hover. So pleased to have such great teams be a part of Nebular Summit and participating in this great community, this big family. So, what are our plans for next year? We're going to do this again, I promise. And because next year the Olympics are happening in Paris, and because ECC is happening in Brussels, we are moving Nebular Summit next year to Brussels. And the dates will be Friday and Saturday, July 12th and 13th. So you don't have to stick around for a whole weekend. It's happening right after ECC. So ECC is Monday to Thursday, and Nebular Summit will be immediately after. We're sitting on those dates. Nobody better sit on those dates because we're sitting on them. No, but I'm sure there's going to be tons of other side events. You know, I'm sure OsmoCon and Modular Summit will also be happening. But we got them first. No. But first, we'll see you at Cosmoverse. We'll be hosting a side event in Turkey, and I hope to see many of you there. I'm sure many of you will be there. And we don't have many details about that yet, but expect to see a Nebular side event in Turkey at Cosmoverse. I hope CryptoCetra's watching. Hey, man. So thank you to everybody. I want to extend a very special thanks to the Very Well team. They're the production company that helped us put this together. Albert School for hosting us this week. Also, let's Mia, who's on her phone here. Big round of applause for Mia, who has been with me on this journey since January, helping put this together, liaising with the sponsors, all the marketing, the comms, and these last 3 days, just making sure everybody was comfortable, fed, putting out fires. Thanks, Mia. Really appreciate it. And that's it. That's a wrap. That's Nebular Summer 2023. Let's go get some drinks and hang out in the courtyard. Weather's clearing up, so should be cool. Thanks.